Alright guys, let's come to our final section for this. So the last thing we need to do is we need to know how to sign an application, and therefore we need to understand why we have to sign an application. And this is what we're gonna learn in this section here. Alright, here we've got our smartphone with the following two applications. We've got the COM example mail and we've got the COM example chess. Now the COM example mail wants to check if there's any update available in the Google Play Store. And the Google Play Store is corresponding with the new update of its version, so the new package version. Now is the question, how can we make sure that this update is regarding to this application? Well, this seems to be a pretty easy question, right? Because we have this package name, and this package name is a unique identifier for this application. Yeah, that's true, but the package name is only a unique identifier for this application on this device, not for the Google Play Store. So how can we make sure that both applications are really from the same developer? Because I can simply open up Android Studio and create an own package name with com-example.mail. And this would be pretty ridiculous if this application now fetches update from a different developer based on this package name. And this is the problem that signing solves. So the developer is creating a private key, and the developer can now sign this application with this private key. So it's a public-private crypto-based operation. It's like writing your signature under this application. And now the Google Play Store has this signed application by the developer, and the application is also asking the Google Play Store if there are any updates available. And now the Google Play Store can check, oh yeah, both applications has been signed with the same key, so they are from the same developer and they have the same package name. The one in the Google Play Store has a higher version as the application on the device, so this is an update for this application on the device. So let's imagine you lose this private key for your application. This means the attacker who got this private key has the possibility to update your application. So the attacker can sign a new version of your application and all other applications will be updated. So the attacker could insert some malware. Therefore, please make sure that you keep your private key private. Store it in some software safe or even in some hardware safe. I also assume that big tech companies store their private keys like, other companies, they are diamonds or things like this, because if an attacker can get this private key, this would be super bad for this company. Alright, besides signing an application, we can do even more stuff, because this whole process verifies the author of this app, and we can use this for more advanced features. We have seen that applications sometimes need the ability to share data between each other. Let's assume we've got this com-example.mail application and we've got a com-example.calendar application. It would be nice if the calendar can keep, or if the mail application can access those calendar and schedule meetings and stuff like this. We have seen we can export these activities, content providers, or whatever we choose in this case. But we have also seen that this is a pretty bad idea, because every other application can also access them. So the developer can declare those activities, content providers, or other components with an own tag, which means if this application is signed by the same certificate, then those two applications can share these data between this connection. This means that these activities, content providers, or whatever we talk about are not exposed to the whole world. These are just exported to application that has been signed by this developer. And this is super great, because the data exchange can happen and there's also no security vulnerability until the attacker has the private key. But then, okay, the whole system will mess up. So this is some safe way to exchange these data based on the signing process. So we do not need this during this course to exchange data based on the same signing certificate. But it's good to know that this option exists, because if you're a developer, then please use this instead of exporting your activities to the outside world. We have talked a lot about signing an application, and we also talked a little bit about the handy features that comes with this signature or signing an application. Now we want to finally look at how to sign an application, because this is the last step that is required for our final challenge at the end of this section. So let's do a quick recap. So we've got our game APK. This is the application we want to modify. And our aim is the game mod APK, the modified version, which is in this purple or however you call this color version. What we have to do is we have to decompile or decode this application first. Then we get the directory structure, which we are pretty familiar with this right now. We know the purpose of those files, and we can do our modification on this. For example, if we want to change the source code, we can modify the Smiley files, or even the resources in the assets directory and things like this. After we've done our modification, we need to build this directory structure back again into an application. And this is what APK tool B does. This is our point where we are right now. So now we need to sign this application that we can install this. And the signing can be done with the jar signer. This was my approach for the last 7 years. So by using the jar signer, we can sign this application. But this is not working anymore for Android version 11. I stumbled across this during the preparation of this course and I got super freaked out. Why is it not working anymore? What have they changed and stuff like this? Okay, and then I figured out that they have changed the signing process. So the layout is a little bit different and this is what jar signer is not handling anymore. Therefore we have a new approach for this, but it's also not that complicated. We simply have to use zip-align first and then the APK signer. What zip-align does is it prepares some offsets, some paths for the certificate that the application has the certificate at the correct place. So if the certificate is longer or smaller, it will fit into the correct place right now. And the application can then reference to this and can install this successful. And this is how we can sign an application now for the Android version 11. Because this is the most up-to-date version and this is what you deserve when you have purchased this course. A working solution for the most up-to-date version right now. Alright, let's see how we can do this. Because signing requires a certificate and a private key, so how can we create this? So our certificates needs to be stored in a key store, which is some kind of safe. And we can create a new key store by opening a terminal using the key tool and providing the following parameters. It looks a little bit complicated, I'm absolutely honest with you, but let's go through to this and you will figure out, okay, we can handle this. So the first parameter is generate a new key, -gen key. And this simply generates a new private key. Then we've got the -v option, which is not verbose, it's print the certificate in a human readable form. Okay, so normally your certificate will be stored in some binary form, but with the -v option, we can say, okay, it is human readable, which is a little bit more easier afterwards. Then we have to provide a new file, and this is the key store. In this case, we are creating a new key store because this file doesn't exist. Then we have to provide an alias name, which is the reference to our certificate. In this case, it's just alias_name, but we can choose whatever we like. For example, Udemy or app pentesting or hacking certificate, things like this. We just have to remember this alias name, but we can also print it out later on, of course. Then we use the key algorithms, which is RSA. A key size, we use 2048 because it's just a hacking certificate and it doesn't have to be that secure. And then we've got the validity, pretty hard word, validity, yeah, that's correct, which simply describes how many days the certificate is valid. So in this case, it's valid for 1 year. And that's all. Then we have created our key store. So the next step is now to use this key store or the certificate within this key store to sign this application. And this is where jar signer has been used in the past. We can use jar signer with the parameters we have provided. We just need to reference to the alias name. So the alias name, which is orange right here, is the alias name which has been defined as the reference for the certificate in the key store. So these names need to be similar, of course, otherwise the jar signer cannot find the certificate in the key store. And that's it. And after using jar signer, we can also use zip-align to meet those offsets, but this hasn't been that necessary in the past. Sometimes it was necessary, but it's pretty rare, so I guess I used it, let's say, 5 up to 10 times within the last 7 years, the zip alignment, to get the certificate correct. But this has changed right now. So now we have to do the approach for Android version 11. And this is the same regarding to the key store file. So we are creating a new key store. And after creating this key store, we now use zip-align first. And afterwards, we simply use APK signer and provide the key store file and the APK file. And that's all. So I would recommend we take a look at this approach and we keep this approach, not the other one, because this is the most up-to-date and this will work on all versions. All right, so let's do this now in practice. All right, welcome back. This whole theory stuff might be a little bit confusing. So let's do this in practice and then you will see, okay, it's not that hard. We now create our own key store and then we sign an application with a certificate that it's stored in this key store. So let's go. We open a new terminal, make this a little bit bigger. And then we use this key tool command. But before, let's make sure, okay, there's no key store here available. I put this in the home directory, but you can put it whatever you like. You just have to remember the reference, of course. So I'm using the key tool command here, and you can also find this in the PDF cheat sheet in this, which is attached to this course. So if you want to copy paste this, feel free to do so. Otherwise, we go through the parameters and you can also type them in. Now we've got this key tool, alias. This is the alias name, and this is the reference to the certificate that gets stored in this key store afterwards. So we are creating a new key store and a new signing certificate in one step here. This is with the gen key parameter here. Key algorithms, RSA, the key size, and this one here is now the key store file. So I put this in the current directory under the name android-app-hack-key store. Signature algorithms, SHA-1, and validity, which is still a hard word, is 365 days. Then we've got -v for make the certificate human readable and not verbose. This is not a verbose flag, this is make the certificate human readable. Okay, now we need to enter a password. Why? Because it's a key store, and this key store is a kind of safe, and this safe wants to be protected with a password. The default password for Java applications or Java key stores is change it. And I stick to this, but you can choose whatever you like right here. I have to retype this. And now we have to define the parameters for our signing certificate. So we have to provide first and last name, and we can take whatever we want. We can leave them unknown or define values, because this is a self-signed certificate and we do not care about this. So yeah, we can put in whatever values we like. All right, I choose here Udemy, for example. And here app hacking. And this is unknown, this is unknown, this is unknown, this is unknown. And here, this is the last master question. Here is if you have passed the test, because if you hit enter, you have to repeat the step right now. So here the key store file is checking if all those values are correct. And yeah, in my case, I hit or type in yes, and then enter, and then the key store gets generated. If you stumbled across this and you already hit no, then please repeat the step until you reach here again. All right, it says a new certificate has been generated and also a new key store, which is here right now. Let's check this. We've got a new file, and this is the Android key store. If we want to print these values, let me clean this real quick. We can use the key tool with the -l list command, and then we have to provide the key store file, Android app hack key store, and then we can list those certificates. Of course, we have to provide the correct password for this. And here we can see we've got one certificate which is referenced by alias_name. This is the fingerprint, and here are some features. It's signed with SHA-1 with RSA and things like this. Now if we want to add a new certificate into this key store, we can use the same command. So the same key tool command. You can use your arrow keys on the keyboard to browse in the history. So arrow keys up 3 or 4 times, then you get the command back. The only thing we have to change is of course the alias name, because this is the reference to the certificate, and I choose Udemy in this case now. You do not have to do this. I'm just showing this to you that you understand what's going on right here. I also make a nice explanation. I hope it is nice with my drawing board afterwards. So yeah, sit back and relax, stick to one certificate. You will be fine with this. Okay, enter key store password. Let's change it for me. Now I say, I'm a developer, app dev, and these data are correct. Now the second certificate has been added. Clear the screen. Let's verify this. All right, we can see 2 entries. We've got one, our alias name, and now we've got Udemy. And this Udemy has now this developer certificate status. Okay, let me bring up my drawing board and show you what we have done so far, that you can follow this a little bit easier. So here we are in the home directory, and what we've done is we've created a new key store. With the generate new key, we also did add new certificates. In our case, there are now 2 certificates right there. One is referenced by the alias_name, and one is referenced with the alias named Udemy. So these are now both stored in this key store. And if you want to use one of them, we have to provide the correct alias name, of course. For this one, we have to provide alias name, and for this one, we have to provide Udemy. This is what we've done so far. All right. Now let's sign our application. We have decompiled and added the contacts before to a SpacePang application. So let me show this really quick to you. Here we have SpacePang decompile. Here we have base. And here we have the Android manifest XML with the newly added permission right here. Then we did build back this app again. And we've got this destination. And here we've got our base APK. Now we want to sign this APK and install it on our virtual device. But before we do this, let me show you something real quick, because this application has not been signed right now. I will show you. I use ADB shell. No emulator. I have to start the emulator first. So I did start this emulator right now. Let's see. ADB shell, no devices. I have, of course, connect to this first. All right, now it's up. And I use ADB install base APK. And that says, no, I am not going to install this application because it has no signing certificate. Let's decompile this and verify this. So APK tool, D on the base APK, which is decode, but I say decompile. I'm going to open this in a directory. And within the original directory, there should be this meta-inf directory. And this one is missing. And the meta-inf directory contains all the signing information, the signature file, the manifest file, and also the signature itself. So this one has not been added right now. If we now sign this application and decompile it afterwards, there should be a meta-inf directory corresponding to our certificate. So let's do this. I'm going to delete the base directory. Please be careful if you have followed me so far, that you do not delete the base APK. All right. And now we use the zip align first to make sure that the alignment and the offsets are correct afterwards. So let's take a look at the zip align parameters. We've got zip align and then -v verbose output, and we have to use an alignment which is on Android applications always 4 bytes. Now we have to provide an in file, which is our base APK, and we have to provide an out file because zip alignment is not doing this operation on the same file. Therefore we name this out APK, for example. It says verification successful, so this application now has been signed. We use the APK signer to install this application right now. So APK signer, we say sign using this key store, and we use our out APK file. The password has been changed. And now in my case, it says, ooh, there are more than one certificate entries. We have to choose which one we want to use. If you only have one certificate in your key store, then you will be fine. It will automatically use this one. In this case, I simply say --key s key alias, and in my case, I use, for example, Udemy. Or now let's say I use alias _ name. Then we are equivalent and have this similar certificate and things like this. Not a similar certificate, but the similar alias name. Oh, and please make sure that you have the parameters at the correct place in your arguments. So this is not possible afterwards. We have to do this before. All right, now I have to use the password again. And yeah, no error message. So I would assume this application has now been signed. And here we can see our new out APK file, and this file can be simply ignored. So now we can say ADB install out APK. And we get an error because the package name signature does not match the previous installed version. We have installed the SpacePang application before, and now we want to update this application with a signature that is different. This is the case we talked about the signing process. We cannot update an application based on the same package name but different certificate. Therefore, we have to uninstall this first, or we can also use adb install to overwrite this file. But uninstalling is way more clean. Okay, so let's uninstall this application. So I swipe this up. I hold this pretty long with my left mouse button, and then I simply drag it to uninstall. All right. Uninstall SpacePang. Now let's install our modified version with the context permission. So if your installing process hangs at this moment, please take a look at the virtual machine. Because here we can see, oh, it's blocked by Play Protect because it doesn't include the latest privacy protections. But we can say install anyway. And we don't want to send notifications to Google. So now we should have this application being installed. So here we have now this application installed, and if you click on this, we can see it's working. So we can now start playing this game, but yeah, we already did this. But if you want to make yourself familiar with it, feel free to go on. I will quit out and have a look into the settings, the permissions of this app. So apps, SpacePang, app permission. No, this one. And here we can see call logs and contacts. So we've got now 2 permissions added beside the vibrate. The vibrate is not listed here because this application doesn't request the vibrate permission on a virtual machine. But here we can see our modification has been successful. We have added a permission into this application, which is great. In the next video, we'll take a look at the meta-inf directory because this one is missing right now in our Android structure. Alright guys, to finish this chapter, let's take a look at the meta-inf directory and see what files are in there and how those values gets calculated. It's not that necessary to know because the only thing I can imagine of that you need to know this is in case of any tamper detection, but at least it's nice to understand the whole structure of this, and it's really not that complicated. So I open up the directory. We have decompiled this application and built it back again and then decompiled it again. So this one right here. In the last step, we have seen that now we've got the meta-inf directory that contains our certificate info. But what's in there? Here we have the RSA file, and this is the signature. We've got the SF extension, which is the signature file, and we've got the MF extension, which is the manifest file. So let's have a look at the manifest MF. And here we can see all those single Android files that are packed in this binary. We have, for example, this game OGG file right here, which is a music file. And underneath this file, we got this SHA-1 digest, which seems to be a base64 encoded string. We can see this because of the equal sign at the end. Now let's take the string and have a look what this is. I open a new terminal and I use echo and pipe this through base64-d for decode. And here we can see, okay, this looks some binary, this looks like some binary content. So we pipe this through XXD. And here we can see, okay, this one looks like a hash. So this is the hash of the file. But now's the question, what is a hash? A hash is some kind of one-way operation. So you put you throw your input into some kind of complex algorithm, and at the end you get this representation of your single bits. So this is some kind of, let's call it checksum. It's not really a checksum, but this makes things a little bit easier. And this is some kind of checksum about your file. And the nice thing about a hash is you cannot reverse this. So you can throw your input into those complex algorithms and you get this value, but you cannot return from this value back to your input. And what's also nice, if you change one single bit in your input, you get a complete different hash. I will show this to you. So we now calculate this SHA-1 digest of the original file, then we make a modification and then we look at the difference. And the reason why you might need all this stuff right now is regarding to tamper detection. Now we just calculate this hash. And how can this be done? Well, first let me go into the directory because otherwise I have to provide the whole path and this would be super ridiculous. So assets, music. And here we've got this game file. Now I open this directory right here to show you this file first. So here we have the game OGG, and if I play this, you would see or hear, I guess you would hear and not see this, some kind of background music. So this is the game music. All right. Now let's calculate this hash, and this can be done with OpenSSL. OpenSSL should be installed on your distribution already, on your Linux distribution, and it's a super nice handy tool. Okay, we use OpenSSL and we say SHA-1 because we want to generate a new SHA-1 sum of this file, and we say read this file in binary mode. And then we have to provide the file name, which is game OGG. And here we can see, oh, these looks pretty identical, but to make sure we base64 encode this one. And here we can see, yes, these are now identical. If we compare those two strings, these are identical, and we can also see this is the SHA-1 digest right here. So this file contains all those SHA-1 digests of all files. Now let's have a look at the signature file. So going to the out directory, original, metainf, and now let's have a look at the signature file. The signature file looks similar to the manifest.mf at the first look because we have now again all those files and the corresponding SHA-1 hashes. But let's have a look. This one here seems to be different. And the reason why this is the case is this file makes a SHA-1 hash over the manifest.mf entries name and SHA-1. I know this is a little bit complicated, but let's break this down into single pieces. Therefore, I open those files side by side. Okay, on the left we've got the manifest.mf and on the right we've got the signature file. On the left we've got a SHA-1 hash over this file within the name tag. And on the right we've got a signature over the name tag and the hash in the manifest.mf file. So first of all, don't worry because all these steps are being performed automatically by the signing process. If you sign an application, this is done automatically. So you don't need to know how to do this. But it's good to know how these values are being generated because there might be this one application where you have to modify or adjust this hash in this file right here. And then this knowledge comes handy. All right, to recap this. On the left side, manifest.mf, we've got all hashes for these files, and on the right we've got a new hash about the file name and the hash that has been calculated before. So these files just make sure that the application or the files are in a correct state regarding to tamper detection or regarding to corrupted files. So if a file has been damaged, this file can notice this fact. All right, this is all you need to know about those two. The last one is the signature. We also take a look at this one, of course. And afterwards, we take a look at a real world vulnerability regarding to signatures and signing an application. So here we have the RSA file, which is the signature of this application. And we can simply print this out. So I open a new terminal, and this time we use the key tool command. We use print cert, and we provide this file. RSA. I'm gonna enlarge this to give a nice overview. And here we can see, yes, this file has been signed with this following certificate, and this was our certificate during the signing process. But we cannot do something with this. This is just public information, and unless we do not have the private key, we cannot use this. But it's good to know how you can read those stuff, because you might find additional information, maybe some kind of additional company that maybe has this app developed or things like this. So it's worth taking a look into this file right here. All right, and that's the last point. So for now, you can completely understand the whole Android structure. You can see. All right, and this is the last point for now. So we have, all right, and that's it regarding to the metainf directory. Now you have a fully understanding of the whole Android application structure, which is super nice. And this is the base, during our course for further exercises and challenges and things like this. Cut. All right, that's all you need to know about the metainf directory. We have finally finished this whole theory part about the Android app structure, but it's really good to know how all these things come together and how this works. And these are also super handy for our further challenges. So in the next section, we take a look at a real world example, a real world vulnerability. And then finally, you have your master challenge for this chapter where you have to modify those resources. And now you are equipped with all the skills you need to do this challenge. So feel free to browse through all this directory and make yourself familiar with this. And if you have any questions, please drop them in the comment section below. And for now, I'm looking forward to see you in the next section. So here we are back at our familiar Ubuntu VM. And what we've done so far is we always decompiled an application, modified it, built it back again, and then we have signed this application with our own certificate. Wouldn't it be nice if we can modify an existing application with the original certificate? I guess this depends on the view, because this would also mean that the complete Android system would be broken and that you can infect people with malware by having original certificates. So for me, I would say, no, this wouldn't be that nice. But for an attacker, of course, this would be ridiculous nice. And this was the approach of this vulnerability. An attacker could modify an existing application with the original certificate by exploiting a nice behavior during the verification of this process. But before we jump right into this, let's verify what would happen if we modify an existing application. And therefore, I go into our original application directory first. So I open the files, apps, spacepan, and here we have the APK file. We can double click or right click open with Archive Manager. And then we've got the zip archive where we can directly edit those files. So we go into the assets directory and we use a file which is not in binary form, so no XML files. Let's see, skin, uiskin.json, this one right here. Okay, now we open this one and we make our modification. We say, for example, this one is now A2. We save this file and we say update. And now we have modified this APK archive right here. And let's install this application. So I right click, say open a new terminal, because then I'm already in this directory right here. And then I say adb connect and adb install this application. Now it says, there is some check, and the check failed because the manifest MF has an invalid digest. And this is why we get through this whole process, what these hashes are for and things like this in the signing section just before. So we know how to calculate this one and why the digest has been changed right now. So let's do this real quick. So we go into the assets directory, we go into skin, then we open the uiskin.json, and then we make also here our modification. And then we use this file now to calculate our SHA-1 sum. So OpenSSL, SHA-1, binary, uiskin.json. All right, now we pipe this through base64 and we replace now this value in the package archive. So I open this in a new terminal, spacepan, this one right here. Metainf directory, manifest mf, and we look for uiskin.json. You do not need to do this because it will be a dead end at the end. So you can sit back and relax while I'm doing this. We have now modified this one right here, and we also need to change the hash in the signature file. Therefore, I copy paste this one right here. And then we use the OpenSSL command regarding to the name and the SHA-1 digest to calculate the signature file hash. So this is this one right here. If these things are too complex, an easier way would be to make this modification in our original application. So decompile this app, make this modification, and then build this app back again, because then all those hashes has been automatically updated and we can simply copy paste them out from there. But yeah, we are also ready for now, so this isn't really faster, but it's way easier. All right, here we have the second signature. So we, after changing this one, did I update this? I guess yes. Let's verify this real quick that I do not mess up something during this copy paste process. So uiskin is this one. Yep, that's correct. All right. And now we go into the signature file, this one right here. UI scan, and this one needs to be replaced right now with this one here. So we adjusted those hashes. This is a normal operation and everyone can do this. Let's see what happens if we try to install this application right now. We hit update, we close all those windows. Oops. And now we say open a new terminal and we say adb install. Alright, we still get an error, but it's not related to the manifest MF anymore. It's regarding to failed certificate, failed verification in the signature file right here. So here we can see we've got a new error. This is now regarding to install pass failed no certificates. It's not with the manifest MF. We have calculated these hashes correct and we also placed them in the correct position. So this part has been successful. But now it says install pass failed no certificate. By adjusting those files or modifying those files, we did break the signature of this APK. And this is something we cannot correct, because this is something that only the developer can do by having the private key. So we do not have the private key and therefore we are not able to modify these files. So how was this exploit even possible to circumvent this issue? Well, it did not circumvent the signing process because this is pretty stable and built properly, so there's no issue within the signing process, but there's an issue within the verification process, and this is something I would like to show you right now. Okay, so here I have restored the original version because we have modified the last one. So we have a clean base and we can install this application just to make sure that it's the original one, and we can install this. Success. Okay. So if we open this, we cannot modify those files. But what about adding a file? Well, let's see. Let's take, for example, this one right here, the APK tool meta information. All right, it has been packed into the file. Now let's try to install this one. Here we have the error that there's no entry for this file available in the application. So adding completely new files does not work. But what happens if we add a file with the exact same name? For example, if we add a new classes.dex file. So let's find this out. First, I'm going to delete this one, that we get the original state back. And now we add a new classes.dex file with exactly the same name. So let's see what happens. And here we've got this classes.dex. So let's see what happens if we drag and drop this one right into this. We can see the file size has been changed. So this file has been overwritten. It's also not working this way. So we cannot add two files with the exact same name into one single zip directory. Or can we? Well, let me get the original state right here. And then, let's have a look how this one would work. All right, here I have restored the original value back again. We can see the date is the same and also 2.1 MB. So this is the original classes.dex file from the SpacePang application right here. I go back into our Thief application right here. And then I rename this file because adding new files with new file names is possible. So we renamed this to classes with Z at the end. And now we put this into here. And we can see, yes, we have both classes.dex and classes with Z at the end. Now let's open this zip archive in an hex editor. So I go back to the SpacePang application, this one right here, and I say open in terminal, ghex, and this application. All right, here we already can see those file names. So we are looking for classes with the z.dex. And here we have one. What we now do is we simply change this binary content by pressing this Z and replacing it with an S. All right, now find the next one. Here's one again. And the next one, that's all. Now let's save this file and open it back again to see what has changed. So I open it and voila, we've got two exact file names into one zip archive. So now's the question, what would happen if we install this application? Which classes.dex will be installed? Well, the answer is the last one that has been added by the attacker. And this was the exact vulnerability. So by having two exact file names in the zip archive, the last one gets installed and not the previous one. And this one also does not get checked, so the last one. The attacker is able to provide a new complete source code into this application. This could be, the original one which has been modified, or even a complete different application and having the original certificate. And this is ridiculous amazing, because it's like, this circumvention of the security issue is so genius. I'm super excited about this one. This is what hacking is about. And this is something you get with a lot of practice and thinking creative. And this comes handy for maybe other applications for you. So let's assume you have a customer application and they perform the verification in the same way that the Android system did in 2013. Therefore, you can bypass this with this check, or at least maybe you can bypass this. This is something you should try out at this point. After having some relaxing session, now you get your hands dirty, you have to hack this application. So let's face the challenge in modifying this application. Welcome back. I'm super excited that we have finally finished this huge theory block right now. For now on, we will do lots of hands-on exercises, and we start with our setup to reverse engineer Android applications. Therefore, we take this classes.dex file and we will reconstruct the Java source code out of this. And how this works, I'm going to show you right now. Here we have our game APK, and the first thing we need to do is we need to get the classes.dex file. Do you still remember if we have to use unzip or the APK tool to get this file? I'm pretty sure you do. In this case, it's unzip. If we unzip an APK, we will get this classes.dex file. If we use the APK tool, we take this classes.dex file and we will decompile this into those single smiley class files. Therefore, this isn't really helpful for us right now. Alright, now that we have this classes.dex file, we use a tool named dex2jar. And what dex2jar does is, it takes the bytecode which is stored in this file and it will reconstruct the Java source code out of this. So by providing this classes.dex file to dex.jar, we will get this classes.jar, and this is a jar archive that contains the complete Java source code in one single jar. But dex2jar is not able to get the original source code out of this. It's more like an interpretation of the original source code, but it's so close to the original one that we can use this easily for our reverse engineering approach. Now we've got our jar archive that contains all of our Java classes. We now use JDGUI to open those, and with JDGUI we can easily browse through all of them and look for interesting things. For example, in our case of the space ping application, the player lives, the shield, how is the alien collision working, and all this kind of stuff. On a real world application, you could look for secrets, certificate pinning, anti-routing detection, RP endpoints, and all this stuff. Okay? One last thing I want to mention right here is, please stick to the exact version numbers and binaries I recommend you in this course. Because I have designed this course to work on Android applications up to 11, which is the most up-to-date version right now. And during my preparation, I faced a lot of problems with the common toolset for Android application version 11. So I spent a lot of time figuring out how to sign an application for Android 11, how we can decompile and reconstruct the source code, and all the other things. Therefore, you do not have to figure it out by yourself to go all through the pain to get your tooling working back again. I did this for you, and this is why you have purchased this course. So please stick to the recommendations and then you are fine. So this saves a lot of time for you. Okay, we now start with the installation of JDGUI in dex2jar, and there we will also have our first variation regarding to the common toolset. So let me switch to my Ubuntu VM for this. Okay, here we are now at our Ubuntu VM. Let's download dex2jar, but we cannot use the original repository because this one is not working for Android 8 and higher. Therefore we have to use a fork of this one, and this one is provided by Lanchon or Lanchon. I'm not sure about the correct pronunciation, so let me show this to you. I'm opening the web browser and I type in dex2jar and Lanchon, I'm not sure. And here we have the fork from the original author, and also thanks to the original author for providing this really amazing tool. In this case, if we click on dex2jar and if we go under releases, we can see This supports DEX version 035. We have seen this in the classes.dex file header up to 3.8, which is Android 8. But I've also tested this for Android application 11. I've created an own application which only works for Android 11 devices, and I tested all this tooling against this app. And there I figured out, wow, a lot of things has changed. And therefore I provide you now everything that works up to this version, which is the most up-to-date nowadays. All right, now let's download this one right here. Now we've got the zip archive and we say extract and we go into our tools directory. We create a new one and we name this dex2char. And we click extract, show files. And yeah, I really hate when this happens, so I copy, paste this out and move one directory up and delete this one. This is not a nice way, but yeah, it's fine, I guess. All right, by the way, if you want to download this Android 11 application, I have attached this to the files in this section right now. Okay, now let's open a terminal and see what we've got here. Here we can see we've got a bunch of sh and bat scripts. Bat is for the Windows operating system and sh is for the Linux operating system. These are green because these are being flagged as executable. We also have a bin and a lib directory and some information. Okay, before we run the script, we have a quick look into this because you should always check unknown code that you're going to run on your operating system. And therefore, I cut this file out. And here we've got a banner and we can see some bash information over there. This looks good so far. And here we can see, okay, afterwards it goes into the lib directory and executes those char files. So let's have a quick look into those lib directory. Okay, and here we have this char files and okay. You can do, of course, a further investigation, but for me it looks okay and I will run the script right now. So let's see if it's working. Oops. And we can see the script is working. Great. Okay, now we create an alias for the script because we do not want to provide the whole directory path all the time when we want to start the script. Therefore, I get the directory and I copy paste it down here. And then I take the file name and check if I provided the correct path to this. So if you want to start the script, we have to provide the full path if we are not in the terminal or in the directory right here. And this one is way too complicated, so we create a short alias, which is a reference for this whole command. Therefore, we just have to remember the short alias name. And I'm doing this in my ZSHRC over there. And here I create a new alias and I name this dex2char. And I provide this whole path over there. Okay. In case if you're not familiar with Vim, this is absolutely no problem. And I do not recommend Vim if you're not familiar with this, because you will face a lot of problems. And this is absolutely fine because everyone else also has those problems when, the person did start with Vim. Okay? So one fun fact about this, I guess the most viewed or rated question on Stack Overflow for a while was how to leave Vim. Therefore, you see, you are definitely not alone if you have struggled or if you struggle with Vim. Okay, in case you do not want to use Vim, you can use gedit, for example. And therefore you can simply open this file and you have a graphic text editor over here. And in case you do not use the ZSH shell, you have to provide this alias name to your bash rc. I'm going to show you this right now. Okay, here we create a new alias name, dex2char. And please do not use spaces. Oops, sorry. Let me fix this first. Okay, now I can talk. Please do not use spaces over here because this will mess up your bash RC. So this is unfortunately not working. You have to remove them. Okay, after providing this, we can run dex2char. Now we get a command not found. And the reason for this is the bash RC and the ZSH RC are going to be loaded when the terminal has been started. So only at this moment, this file gets loaded or refreshed. We can open a new one and type in dex2char. This will work. But if you do not want to create always a new terminal, you can also refresh this environment with the source command. So by providing source on your ZSHRC, you are refreshing this environment for this terminal you are using right now. And now we can use dex2jar also here. So for example, on the home directory, it's also working right now. Great, dex2jar is working. Let's start decompiling this classes.dex file. So I go into apps, spaceping, and here we have this classes.dex file. Now I do a right click, open in terminal, and I say dex2jar classes.dex. And here we can see it's now reconstructing this Java source code out of this classes.dex file. And here we have now our jar archive that contains the whole source code of this classes.dex in a Java code format. Nice. Now to view this file, we have to install JDGUI. And therefore we go again into the internet and we type in JDGUI, decompiler, and we use this one over there. So this is the original version. It's absolutely fine. Now we get a warning if you want to keep this file because it's a binary and it can damage our system. I say keep because I trust this one. Okay. And if you want to start this one, we have to provide java-jar and then JDGUI and this jar archive. Okay, we can see it's working. Okay, I now put this JDGUI into a tools directory and also provide an alias name for this, like we have done this for the dex2jar, just to have a clean setup. All right, now we are back. So I go into the directory, spacepang, and now we open this file with JDGUI. And yes, it's working. Here we have our Java source code, all those package names, and we can see, for example, within services or systems, alien behavior system, here we've got now the Java code, which has been recompiled. We can also see here, for example, there has been some troubles, so it could not be decompiled on this point, and therefore we can also not, copy paste this Java code into a new project because we will end up with tons of error. But for reverse engineering this is absolutely fine. This part, by the way, is some Smali part, and later on we will be able to understand this one. So even if we do not have the Java code over there, we can read this later on in this course, which is super amazing. Alright, that's all for this video right now. We have successfully set up our JDGUI and dex2jar, and we can now recompile this classes.dex file to get our Java source code back again. It's not the original one, but it's pretty close to this. In this video, we'll take a look at JADX and JADX GUI. Both of them are able to handle a whole APK file, and they can also recompile those resources, which means we get access to the Android manifest XML and the Java source code. They have, of course, their disadvantages, and we will compare them against the dex2jar approach, which we have done before. But overall, these two tools are amazing and should be definitely in your toolbox. Now let's start installing them, and afterwards we take a look at the parameter they provide, because some of them come super handy during our reverse engineering process. So I would say let's go, let's switch to the Ubuntu VM. Alrighty, here we are at our Ubuntu VM. Now let's start downloading and installing them. And therefore I open my web browser and I search for JADX and GitHub, because this is a GitHub project. Then we use this from Skyload over there. And then we can use those releases, or we can simply clone the repository, which I do. So I copy paste this one and then I go into tools. And here I simply say git clone, and then we clone the whole repository. If you do not have installed Git, you can simply install it via sudo apt-get install git. And afterwards you can clone this repository. Then we get this directory over here. This one, JADX. Gonna enlarge this a little bit. And then we say Gradle, this is the build system, and we say dist. And now it's fetching all those necessary binaries and also compiling those code which is stored inside there. This take a while, and I will come back after this process has been finished. Alrighty, here we can see build successful, so the build process has now been finished and we've got a new directory over there which is called build. Then we go into this one, into JADX, into bin. And here we have now JADX and JADX GUI and also the Windows version with the BUD extension. Now we add this directory to the path variable that we can simply run JADX and JADX GUI from wherever terminal location we like to. Therefore, I get the directory over here and I simply extend the path variable, which we have done in the past with the Android setup or for other tools. So I open this in Vim. And here we simply append this directory, we add this colon, and now we're good to go. If we go back, then we can run JADX command not found because we need to refresh our ZSH environment. And now we can use JADX. We have to provide an input file. All right, it's working so far. So the installation process is now finished. Now let's have a look at the options of JADX. We've got two tools. We've got JADX and JADX GUI. JADX is the command line version and JADX GUI provides a graphical user interface. But we start with the command line version. So we type H for help. So the first line tells us JADX seems to stand for Dex to Java decompiler. Then we use JADX by providing options and an input file, which can be an APK, a DEX, a jar, a class, a smali, zip, and some other files. We can define output directory that stores our resources and our Java sources. And as in the APK tool, we can also define do not decode resources or sources. And this might come handy if there are some errors within decoding resources or sources. We might to skip then the exact part. We can also say decompile a single class name or class file, which is also nice. Alrighty, what else do we have? Another nice feature is the deobfuscation part. So what is a deobfuscation? Let's assume we've got a class name which is main.class. And this class name now gets reduced to a single letter, for example a.class. And this class name now contains methods like b, c, d, and e. And this happens to all class files. And the algorithm needs to take care that it does not overwrite. For example, rename both classes to the same. But if this does not happen, then we end up with a bunch of chars at the end of the whole source code. So then we've got methods like a.b.c.ab.c. And this is not easy to reverse engineer. Therefore, JADX tries to give this a little bit a better name. Of course, JADX cannot do some magic and restore the original name, but it can try to make some recognizable patterns. And this is what JADX does. This approach helps a little bit, but if you have to deal with a highly obfuscated app, the only thing I can imagine is debugging this application. We have a section about this later on in where we talk about debugging an application. The next two parameters are regarding to the min and max length of this deobfuscation technique. And this also has some side effect, which I'm going to show you later on also. Alright, the last useful option might be this dot file, but I will show you a different application that handles this task, in my opinion, a little bit better. What this parameter does, it saves a call graph into a dot file. And a call graph is simply a graph overview about the calling hierarchy of this application. So if this class opens this method and this method calls this class and this class calls this method, it shows this in a nice overview. And this is super handy because I used this once to solve a very hard reverse engineering challenge of an Android app. I'm also going to show you this approach later on in the special section. Alright, then we've got the verbosity and some log level. For example, error is really useful to include because JADX fails a little more often than Dex2Jar in my opinion. And by providing this error, we can see where it fails at which class name or which resource, for example. And by having this information, we can make the decision for ourselves if we need this now decompiled or if we do not need this decompiled. If we do not need this decompiled, we can simply move on. But if this is the most important piece, then I would try different tools. For example, Dex2Jar or the special tool, which I'm going to show you afterwards. And finally, we've got the threads count over here. And this one is also super nice in JADX. Because JADX is able to multi-thread this whole decompiling process. And this comes super handy if we have to do or decompile a lots of APK or if we have to decompile a huge APK. Multi-threading means we can distribute our task to certain CPU cores. And I've also provided you within the cheat sheet a basic calculation how you can figure out how many cores you can provide to JADX for this multi-threading part. All right, now let's decompile our SpacePang application and take a look at the result. So I'm going into apps and we create a new directory and we name this SpacePang JADX. And we copy paste this out from here. Okay, then I open the terminal over here and we say JADX, then the name, and we say log level is error. I'm going to enlarge this. Now let's see. Now JADX is creating a new directory and also processing those files. And we've got our first error within this class here. The JSON reader path seems not to be decompiled correctly. And we've also got this one over here, which is regarding to a compression class name, can also not be decompiled. We get this at the end with 2 errors. All right, 2 errors is not that bad, to be honest, for this application. Now let's have a look into these single files. Here we've got those resources and sources. If we click into the resources, we are familiar with this. This is our application structure. We've got this classes.dex, but we've got also this Android manifest XML, which is now decoded. So JADX is able to handle those resource files. Okay, so there's nothing special in here right now. We are pretty familiar with this, but we are more interested in the Java code. And this one is over here. And now we've got the structure regarding to the package name of the Java classes. For example, we've got this one here, DE, then the name of the author, SpacePang, and here we've got now the Java source code. Let's have a look into systems, alien behavior system. And here we can see, yes, this is the decompiled Java code. And this looks pretty good so far. Okay, let's have a look at the class name that cannot be decompiled. And here we can see, okay, this one. So this one should be the class name, and it's easier to search for the class name to get this file instead of browsing through all these directories, because we have to replace those dot with slashes. Oh, I've closed this one, but it doesn't matter. So within sources, we have now to go into com and so on. But I search for this class over here. Then I'm going to open it. And here we can see, yes, we have seen this with dex2jar also. So dex2jar was able to handle this class and also this method, but it might fail on other classes. And therefore we can do this approach for both. So we decompile our app with JADX and dex2jar, and then we can merge those results and see, who did a better job in which function, and then we can merge those results afterwards. So this is how JADX works. Now let's have a look at JADX GUI. Go into the apps directory back again. SpacePang JADX. Oops. And then we use JADX GUI, and we can also provide an age, but these are the same parameters. So we can use, for example, the error method over here again, the log level error. Then we can see where JADX GUI also could not decompile those files, but JADX GUI does the same like JADX, but afterwards provides a GUI for this. So that's all. Okay, then we use JADX GUI on this file. And here we have now our editor, and this looks pretty similar to the JDGUI part, but we've got now those resource files over here and also this APK signature. So JADX is also able to decode those resource files over here. Okay, we can now open the Android manifest XML and we can browse through this over here. And the one thing I want to show you right here is the obfuscation technique. So let's see. Now we've got those class name, and this one is an interface with the capital I over here. You can see this here. And if you click on this symbol here, which is the deobfuscation, it tries to deobfuscate this application, but we can see this app has not been obfuscated. But I still hit this button right now. And now we can see something has been changed. We can see DE got 2 letters, and if we hit the deobfuscation button, the program thinks this one is obfuscated and tries to deobfuscate it by appending P005 in front of this. So it makes this a little bit a recognizable pattern. And this also happens for the R, which I do not found anymore. So I'm not sure where the R is right now. Therefore, yeah, if the app is not obfuscated, then you shouldn't also use this option, because you make it, I guess, worse by doing this. I now hit this button again, and we can see right now, okay, this one, I do not know where this class has been decompiled or renamed into, but I couldn't find it. Maybe I didn't extend the directory there. Oh yeah, I didn't extend the directory, therefore I couldn't find it. Sorry. Here we can see this R now gets, this recognizable pattern, C0256R. All right, and this is what the deobfuscation option does. The only thing I wanted to mention right here is this one. If you search for classes, variables, attributes, whatever, please use this instead of this search option, because this is only a class search and this is a text search. And here we can also define all those parameters. And at the bottom, you can see that the indexing takes a while, but now we can search. And now we can see we get those fragments, which is, a little bit wired. In my case, or in my opinion, the best way is to store those Java classes. You can do this with JADX decompiling, or you can hit this button here, save all. And then you can provide a directory name and then use Eclipse to import them again. So I'm going to show you this real quick. So with JADX, we have decompiled this one with the client version. Over here, the sources. And now we download, install Eclipse, and then create a new project and import them. So I speed this up a little bit. Okay, here we have now the project, and we simply drag and drop our directories into this source directory over there. We can also remove this one because it's not necessary. So we go into apps, spacebank JADX, sources, and we drag and drop them over here. Copy files and folders. And now they will be all available, and we can see also a bunch of errors. This is also the reason why we cannot simply decompile this application, put them into this one and compile this app back again, because we will end up with, we are now at 6,000 errors, and this value might even increase. Okay, after they have been imported, we can simply go to search. We click on file. We can here search for Java, but we can also use this file search over here and provide the shield parameter now right here. And then it will go through all the files. And if we do this, we can enlarge this, and here we go. We can now double click on this, and we get all those classes over there where shield appears. So I also like this approach, decompiling this app with JADX and then loading those sources into Eclipse to reverse engineer this application. Alrighty, let's switch back to the presentation. So here we have the command line interface version of JADX, and this comes super handy if you want to mass decompile Android apps. We can use this to load a bunch of applications into JADX and automatically decompile them. This approach would look like this. For example, if we use an RP or if we have fetched a lot of APKs, then we can use JADX to decompile them and store them into single directories over there. And afterwards we can browse through this and, for example, search in the Android manifest for exported content providers or exported activities, static keys, RP endpoints, and things like this. And to automate this whole process, you can use find, which is shown in this command above. So you can use find-iname to find all APKs on your system or in this directory. And then you can use exec JADX, and you can provide those brackets, which is the APK name, and then simply use an output directory and decompile them all into this output directory. I'm going to show you this real quick because this is super nice, this feature. All right, here we are back at our Ubuntu VM. And let's see, I guess within our downloads directory, yes, we've got some APK files over here. And now we create an output directory. And then we use this find. And what find does is, it takes now all APKs in this directory, and it would also go deeper into those directories to find those APKs and decompiling them into this out directory over here. Yes, and now we are done. Let's look into the output directory, and here we have now all those source files. Yes, so we can now browse or grab through these files and search for some vulnerabilities or other stuff. Then we've got JADX GUI, which can be used on a single application file. And we end up with decompiled resources and also with decompiled source files, which is shown over here. Finally, here's an overview about the most important parameters, but we already talked about them. All right, finally the battle between JADX GUI and JDGUI. In this case, it's more like dex2jar and then JDGUI, because JDGUI is not decompiling this application. But here on the left, we can see, okay, JADX fails a little bit more often, in my opinion, than dex2jar. And therefore, I like to use dex2jar more than JADX. But this is my personal preference. In case of dex2jar fails, you can, of course, try it out with JADX GUI and see if this might work better. And afterwards, you can merge those results, and you might have got a more complete Java source code over there. All right, that's all for now. I'm looking forward to see you in the next section where you get your task on reverse engineer this application. Okay, let's have a look at the JDGUI options. So let's have a first view inside this tool. So I go into the apps directory, spacepan, and we open this classes dex2jar.jar with JDGUI. And this one over here. And here we go. This is the overview about this tool, and it's super clean, and I really like this tool. On the left, we've got those package names, and those package names contain the Java classes underneath. For example, within systems, we've got this alien behavior system, and we can see the Java code out of here. If we get this one, JDGUI struggled with the decompiling of this method, and therefore it puts out those bytecode reference. So we do not get the Java source code out of this one right now. Okay, a good starting point is this one over here, because this package name is identical to the package identifier of this application. And this is very likely the case that the code underneath here has been added by the developer, because JDGUI also resolves, for example, the Android Java classes that comes bundled with the Android system and that are not interesting to us. Therefore, this one seems to be from the developer, and we also have proved this already. So underneath this package name, there might be a lot of interesting stuff where I would start reverse engineering this application. JDGUI comes with a lot of nice options, and let's discuss them real quick. We've got this one, for example. This is open type, and we can search here for types. For example, if we type in player, then we get those C, which means classes, or this E, which means enum types. There's also an I for interfaces. And here we can see, for example, if I get more, now we've got all classes that contains player at this point. If we want to search within the whole code, for example, for variables or method names, we have to use a different search, which is right next to this one. And here we can see what we want to search for. And normally I check everything right here because we do not really know what we are looking for. For example, if you look for AES, this might be a field name, it might be a method or a constructor, and so on. Therefore, I like to move on with all of them. If the output gets too large, I try to minimize this approach. For example, if we search for AES, we might not search for type or fields. We might search for AES within methods or constructors, for example. Okay, but most of the time this is not the case, so we can stick to all. And it's also nice to have this regex over here. and it's also case insensitive. For example, if we search for something, let's say alien, we get now all this alien results over there, and here, for example, we can see, okay, here has been an alien class, but this one is a groups class, and this groups class seems to contain some string reference with alien. And here we go. We've got string aliens, alien shots, and so on. So this search is, the most used window in JDGUI for me right now. Okay, next we've got this one, which is the type hierarchy. I'm also not sure about this pronunciation. I hope it's correct. And this comes super handy during our reverse engineering approach because it shows the inheritance of those classes. For example, we've got this alien behavior system over here. And this one extends this entity processing system. If we go to the top, we can see, yes, it extends the entity processing system. And this one extends the entity system. We can see this over here. So there we can see the inheritance through all those classes, which is super handy during our reverse engineering process. All right, and last but not least, what's left? The only thing that's left are those preferences. We can escape Unicode characters. This one is pretty interesting. Directory exploration, sorry for this one. Maximum depth. I've tested this with an application because I was not sure if JDGUI is searching into files that are in subdirectories up to 40. So if we add 40 directories into one application, my assumption was, JDGUI might miss them, but I have tested it and it works. But if you encounter an application that has a lot of subdirectories, it might be some obfuscation or some anti-reverse mechanisms, so please check them out manually. Otherwise, the rest is not that important, and maybe the font size might come handy if you want to increase them to 40, for example, then 14, sorry, then it's easier to read. And that's all about JDGUI right now. We load those Java classes into this file and we can nicely reverse engineer this application right now by having all those tools. In most cases, we simply stick to this one over here, which is the search engine. In the next section, we take a look at JADX, which is a command line tool, and JADX GUI, which is the graphical user interface for this one. And within this tool, we can feed in a whole APK, which is super nice. But it also has some disadvantages, which I would like to point out regarding to this approach. All right, that's all for now. Feel free to browse around and reverse engineer this application. After I have introduced our tool, this will be definitely your task that you get familiar with this, and I also provide you some tasks to do. For example, to find the player lives and other stuff. I do not want to spoil that much right now. Alright guys, are you ready to find out what our mysterious reverse engineering tool is? You absolutely are. And the secret weapon I'm talking about is AndroGuard. So AndroGuard, it's a reverse engineering framework, and you might think, wait, what makes it that special? So AndroGuard has a lot of underrated features, and those features can come super handy if you have to deal with highly obfuscated applications. But before we dive too deep into this, let's get back to the beginning. So what is AndroGuard? AndroGuard is a framework, and it's written in Python. So there are several modules you can use of AndroGuard. And to be honest, I do not use most of them. I only use 2 special modules. But to make a nice layout, I have to include 3 terminals. So now we also talk about the analyze module. Then we've got the call graph module, which is extremely nice if you have to deal with obfuscated apps. And we've got the decompile module, which is also amazing, as you will find out in a few minutes or within the next section where we finally take a look at the CTF challenge. Alright, beside those modules, AndroGuard is able to handle more, but let's focus only on these 3 right now. The analyze module is some kind of static analysis of a binary. So we can use this binary and load it up into our analyze module, and this analyze module now provides us an IPython shell. And with IPython we are now able to browse around through this application. We can do lots of tasks, but we are familiar with all of them because we have done this manually. We can, for example, get all those activities. We can inspect the application based on the app itself. We can browse through the classes, the methods, and further stuff. Alright, so this was not that exciting, I guess, but now we come to the point. Now let's talk about the more exciting features of AndroGuard, and one of them is call graph, and call graph is super amazing if you have to deal with obfuscated binaries. What is a call graph? So let's assume we've got a function that is deep burrowed in this application code, and call graph is the way to this function. In this case, we have this username and password field. And if we hit the login button, which is not available there, but on the real world application it would be, then these parameters are going to be inserted into a function, which calls another function, this calls another function, and this calls another function. And finally, there's this last method which loads this encrypted file into the memory and starts decrypting it. Afterwards, it compares those hashes and figures out if the password we have entered is correct or not. So we get a graphical overview that shows us how we can reach this point, which methods we have to call, and also which parameters we have to provide to end up there. And this is what a call graph does. And as already mentioned, if you have to deal with obfuscated binaries, this comes super handy. Let's imagine we've got this obfuscated app, and the application code we are interested in is deep buried in this application code. And now we stare at the methods and class name, which consists of A, B, AB, ACD, ABD, and so on. You would go crazy if you try to analyze this by staring at this obfuscated code. Therefore, we have to split it up, and by splitting it up, we make single pieces and we can follow them. And this leads us to the final function that we need to call, and now we also know which parameters we have to provide. This is also super handy if you have to deal with routing detection, certificate pinning, strange obfuscation or decryption, encryption methods, and other kind of stuff. So the call graph I'm going to show you an example afterwards is super amazing, and if you have to deal with really hard binaries, this comes handy and should be definitely in your toolbox. And finally, we have this flow graph. A flow graph sounds similar to call graph, but these are different. A call graph is regarding to the method names. So method 1 calls method 2, calls method 3, and so on. We get a graphical overview about this, super nice. A flow graph is now regarding to a single function. Let's assume we've got a function that contains tons of if statements, else clauses, and also some jump instruction, go-tos, switch cases, and all this stuff. Let's assume there are about 40 in there, and there is only one specific path to a solution where we have to get. Staring at this binary and trying to solve this would drive you crazy. Therefore, we can provide a call graph, but only for this single function flow. And this is our flow graph. And let me draw this here real quick. So we've got this username and password, and we now focus only on a single function call. And this username and password is going to, some really strange control flow in this application. Therefore, we start with an if case, and this if case also got some really strange branch instruction. And finally, we reach out the point where we know, okay, this is our solution. We need to get to this point. And now let's imagine we have this graph multiplied by 20 or 30. Trying to solve this by staring at the code will be pretty hard, at least maybe not possible, because you have tons of curly brackets, and it would be super hard to solve it in this way. You also do not know which parameters you have to provide at a certain point to get to the solution. So you have to do it from top to bottom, and you have to go into every branch until you finally find your solution. Therefore, we do this approach backwards. So we go into our solution, and then we trace back, and by tracing it back, we know which path we have to take, and therefore we can only focus on these single instructions and provide the correct solution. If this sounds now complicated, don't worry. I'm going to show you how you can do this, and it's super easy, and you will also see the benefit of this by solving this really hard capture the flag challenge. And by the way, I'm not going to spoiler any solution. I just want you to show you my approach on how to solve this. You have to solve this challenge on your own, but after this course you will be definitely able to solve all challenges in there. Not because I did provide you the solution, because I provide you the knowledge and the skills on how to do this. In the next section we take a look at the installation process of this tool, which is also super easy. And then we create our first call graph and our flow graph regarding to this very hard capture the flag challenge. So I'm looking forward to see you in the next section. Alright guys, I'm super excited because now we are going to finally install AndroGuard, and we have a quick look into the analyze option. In the next section we take a look at the call graph and then into the flow graph. So there's lots of hands-on time. Alrighty, let's start installing AndroGuard. Therefore we go into the well famous internet and we search for installation AndroGuard. And the first link is regarding to AndroGuard, read the docs. Let's have a look over here. This is the, I guess, official documentation of AndroGuard, and yeah, also have a look into this because there are lots of useful hints over there. If you want to install AndroGuard, we can use the pip installation management because AndroGuard is written in Python. Therefore, we can simply run pip install-u AndroGuard. But be careful. This paragraph over here mentions that AndroGuard only works on Python 3 and higher, Python 3.6 and higher. And if you're using an Ubuntu 18.04 and you're running pip, you might be using Python 2 to install AndroGuard. And then you will end up in a mess. So this tool might not be working correctly. Therefore, we are going to use pip 3 to make sure we are also using Python 3. Alrighty, so let's have a look. I open a new terminal and let's check if we have pip 3 installed. No, we haven't, but we can simply install it by running sudo apt-get install python 3-pip. I'm entering the correct password and now the pip 3 is going to be installed. This only takes some seconds. Now we can install AndroGuard with pip 3, install-u to also upgrade those package names, and we use not Android, AndroGuard this way. We do not provide a magic or a GUI parameter, we install this whole AndroGuard bundle right now. Now these additional requirements are going to be installed also, so the dependencies of AndroGuard. And after this has been finished, let's figure out if it's working. We get a bunch of warnings over here and yeah, these might be important, so let's see. If we type in AndroGuard, we can see command not found, and that's the case because those binaries are not within our path variable. I'm going to enlarge this and we have a look into this. We are in the home directory and here we have a hidden directory named local. If we go into this, we have this bin directory over here and here we have now the AndroGuard binaries regarding to the Python package. We need to include this into our path variable and then we can run this afterwards. So we take this and we open the ZSHRC. We should have been a lot of practice in this right now. So we go to this point and we extend this path, add this colon at the end. And now we update this ZSHRC. And we go into the home directory back again and we run AndroGuard. AndroGuard has been installed and that was the whole installation process. Super nice, right? So let's figure out what we have here. Let's have a look at the AndroGuard options. So we've got this analyze module, we've got this call graph module, and we've got this decompile module. We will discuss them in detail. Beside this, we also got an extra option for return package name, version number, and stuff like this of the APK. We can also directly pass this resources ARSC into an XML format, or we can also take a look at the Android manifest XML. Regarding to mass decompiling Android applications, this might come handy, but regarding to a single application, we do not get a real advantage out of this. But however, let's have a look at the analyze option. We go into the apps directory and we go into SpacePang and we load our SpacePang application into this. So we say AndroGuard, and if you want to get a specific help menu, you can type AndroGuard, then the command, for example, analyze, and then --help. And then we get a help menu only for this command. And here we can see analyze is pretty simple. We can provide an option, which is a session path, but we do not have a session created yet. And then afterwards, simply the APK. Therefore, we have to run AndroGuard, analyze, and then the APK name. I'm gonna clear this and run this. And now this APK is going to be passed into AndroGuard, and we have now an IPython 3 shell. AndroGuard also created three main objects, A, D, and DX. A is regarding to the APK, D is regarding to the Dalvik VM format, and DX is regarding to some analyze option. We will only focus on these two, A and DX. The nice thing about IPython is you can type in A dot and then hit the tab button multiple times, and then you get an support on which methods or variables might be available. So let's see what we've got here. We've got a method, for example, get activities. And if we run this, we can see this application only contains one activity, We've also figured this out in the manifest section, but yeah, here we can also prove this once again. What else do we have? We can get, for example, the Android manifest in an XML format. We can get the application name, information about the certificate, information about the JADX file format, files, CSV thumbs, main activity, and other stuff. I'm going to clear the screen because then I guess it's easier to read. There we go. Okay. So here we have now a nice overview about the A object in AndroGuard. But all of them, yeah, can be done manually, and we already done most of them in the last sections. And I like to do the manually approach a little bit more because we have more control over this application and where things might go wrong. But yeah, this can be handy for you if you want to analyze an APK with a Python shell. All right, let's see what we've got in the DX object. Here we have the analyze module, and we can see, okay, we can find classes, methods, strings. We can also create a call graph over here, but we use the AndroGuard specific call graph command because afterwards we need to deal with this file and we will have lots of functions over there and we need to filter them, and therefore we use a different tool to handle all these tasks. But it's nice to see it over here also. All right, yeah. We can also find classes, methods, and things like this. For example, if we try or if we run get classes, AndroGuard is going to fetch all classes that are available in this APK. And we can see there are a lot available over here. So if we scroll up, these are a lot of classes. We have done this approach manually with Dex2Jar and JDGUI or with JADX. Yeah, but if you want to mass decompile or mass analyze applications, this Python interpreter can come handy. I'm not going to use this very often. I just rely on the call graph and flow graph. But yeah, this just depends on my personal preference that I like to do the manual approach. All right, this was a quick introduction into the analyze module of AndroGuard. In the next section, we take a look at the call graph command. And this one is really super nice. We will create a call graph for a special or certain challenge I have prepared for you. And then we will also figure out how we can deal with this file format, because we will have tons of functions over there, and there's a really nice tool which does the visualization process for us and which is super easy to handle. Okay, feel free to play around a little bit with the analyze module over here, and afterwards I'm going to see you in the next section. All right, in the last section we have installed the AndroGuard framework, and now we are going to finally use the call graph. We create our first call graph for a challenge I have prepared for you. So are you ready? Let's go. In this section I have attached a reverse me application, and this is more like a demo application than a capture deflect, but yeah, we use this to illustrate this call graph function. Please download this file and then we are going to install it and see how it looks like. I've already downloaded it over here, and I copy paste this into our apps directory because we want to have our system in a clean state. We name this reverse me challenge. And then I'm open a new terminal. I do an ADB connection to our virtual machine, and I'm going to install this. And this is a nice error we get right now. So within the cheat sheet, I also provided you tons of ADB errors I faced during my last 7 years, and also the solution for this one. I've created a debug version out of this, and we can see this is a test-only installation. And we can use ADB install or the help of ADB install to figure out how we can solve this. So we use ADB install -- help, or I guess it's only ADB -- help. And let's see, within the installation process over here, yes, we can see in this parameter, allow the installation of test packages. And if we provide this one, we can install this application. So we run ADB install -t reverse me APK, and then we can see success, it's working. And let's get the screen content over here that we do not have to switch between them. I swipe this up, and here we have our reverse me application. I'm going to open this, and here we can see, yes, it's not looking that nice because it's more like a demo application. The other challenges are more in a nicer visual state. But it's pretty simple. We have to provide a password and hit the button. And then we can see, okay, the password wasn't correct. So Let's try let me in. Also not working. Let me in, please. I did say please. Okay, we have seen we are not going to solve this challenge in this way. Therefore, let's have a look into the source code. We close this one and we use JADX GUI. Okay, we can see it's loading over here, and now we've got this application. And the first thing I like to do is I like to check the manifest XML over here. Let me make this a little bit larger. All right. Here we've got the Android manifest XML, and we can see this application doesn't require any certain permissions. We also got only one activity, this main activity, and this is our launcher. So we do not have additional activities. And this is pretty simple and clean. Therefore, let's have a look into the main activity, which is available in COM App Hacking Reverse Me main activity. Okay, here we are now at the main activity, and if you are not familiar with the Android development, absolutely no problem, I guide you through this. You do not need to be an Android developer for absolving this course right now, but it is a little bit helpful if you understand the structure about this. We have seen this button, and if we press this button, our input text, the text we have inserted in this application, gets checked. And this one is over here. How do we know that this one is now the button? Well, we have to take a look into the Android layout of this. So this activity gets a layout file, and this layout file describes how these buttons are organized, where this input text is, and all this stuff. We can find this within the resources. So we go into resources, layout, and then we have this activity main layout over here. I'm going to copy paste this into a new code editor because this is not easy to read over here. So we create a new one. We insert this and we also toggle the word wrap. Okay, now we've got the single elements over here. Let me expand them. We've got an edit text, which is our text field. We are going to insert our flag guess. Then we've got this button. It's obviously what this button is. We've got a text view. This might be displaying this text, wrong flag. And we've got an image view, which is the log of this icon. If we go into the button over here, we can see this button has an on-click attribute, and this one has this method name over here. So now we know if you press this button, this check method gets called. And if we go back into the main activity, we can see, all right, this is the method that gets called if we hit the button. And this method takes now our input text and pass it to this function over here, to this class function, onMoveOn. Let's have a look at one. Here we are now at one, and onMoveOn gets a string as parameter, and it checks if the string contains becoming. Okay, that's a first spoiler, but I'm not going to go deeper into this if you want to solve this afterwards. But it's regarding to a demo purpose, so it's not a real challenge approach. However, all right, if this text contains becoming, then we go into toMoveOn. So within toMoveOn, we've got another method, and then we go into 3MoveOn, and so on. Within onMoveOn, we also have our flag over here. So we can see this is the flag method. And this flag method now is going to be called somewhere in all these functions. It's not going to be called over here. So some function over here is referencing to this method. And this is the most important part if you want to solve this challenge. Which function is referencing this and how can we get to this point? And therefore, you guessed it, we are using this call graph. Alrighty, so I'm going to close this one, also going to close this one, also going to clear this one, and now finally we create our first call graph. So we use androguard --help. Here we have the call graph, this CG parameter, so we say androguard CG --help. And now we've got the options. Creating a call graph is super simple, so we only have to run androguard call graph, and then we use the out option over here to create this output file. And this output file has this GML extension. And we use a tool named Gephi, I'm not sure about the pronunciation. I'm going to show you the installation process, so don't worry about this, to visualize this call graph afterwards. And that's all we need to do. We can also filter on certain class methods, method names, if this is a huge application and we are only interested in one. But I'm going to show you how this looks for an application like this. Because then you also see how you can handle larger files later on. And so let's create this call graph. We run androguard call graph and then the -o option, and we name this file callgraph.gml. I guess this would be also the default name. And the last parameter is the APK, reverse me APK. Okay, now androguard is going to create this call graph in this file format. Okay, and here we are getting now our first error. Isn't this nice? It absolutely is, but we can fix this easily. The reason for this error is that the call graph function is relying on an older network library, network-x library, and androguard comes with network-x 2.2. So we can find this within the requirements of the GitHub repository. I'm going to show you this real quick. Androguard GitHub. Here we have the requirements, and here we can see androguard, this package name did install 2.2. To use the call graph menu, we have to downgrade this library version to 1.11. I'm not sure why this is not default the case for this program. Maybe it's a bugging issue, I don't know. We can fix this, and yeah, this is also pretty simple, just one command. Therefore, we run this command pip3 install network-x, and then we can provide with 2 equals the exact version we want to install for this library. And in our case, it's 1.11. And now pip is uninstalling the existing version and also installing the older version, which we can see over here. Now let's try to run this command once again. And we can see, yes, it's finally working. All right. Nice. Now we've got this file, callgraph.gml. Let's take a look into this. Okay, here we have now the graph.gml, and I want to provide you some information about this because you cannot read this, of course. We haven't talked about the Smiley part over here yet. I just want to provide you some hints on how you can do this without understanding Smiley. The first one, this big L, is always the first letter over here. And this is a type definition in Smiley. This means afterwards there will be a class. And here we can see, for example, this one is the Android support v4 app iNotification side channel. So this is the class name that is going to be referenced. Don't worry, you do not have to understand this. The most important part regarding to the call graph is this one then over here. After this class name, there's this arrow, and now we've got this function name. So after this arrow, there's always this function name over here. And we can later on navigate or recognize our function calls by this name after this arrow. We do not have to understand what's here or maybe in front of this. So we just focus on this arrow and then the name afterwards, because this is the method name that is going to be called there. All right. Now to view this file, we need to install a tool, and this is also mentioned on the androguard documentation. So androguard call graph. And here we can see, to visualize this call graph, we use this Gephi tool over here. So we're going to download this one, download this for Linux, and now it's going to be downloaded. While this is downloading, I want to show you some nice pictures over here. So here we can see a call graph of an application, and every single dot is a function name. And you might think, well, is this more easy to handle? And I can tell you yes, because here are now all functions included, but we only focus on a certain function and we will filter them out over here. All right, I'm going to close this one. And now we are going to run or install Gephi. I copy paste this and we go into the tools directory. Gephi. I'm also not sure about the correct pronunciation. It's probably the case that this one is wrong, but I stick to it. Extract over here. And yes, I hate when things like this happen. So I'm going to copy this, paste it here, and then delete this one over here. Okay, so now we've got this Gephi directory, and here we have this bin. And we can directly start this one. If you're using a Windows, you also have a Windows executable over here. Let's start this tool. It's loading, and nice, we get our second error. Great. This time it's regarding to the Java version. So Gephi is relying on an older Java version. In my case, I'm using Java 11, but Gephi only works on Java 8. Therefore, we have to install Java 8 right now. The nice thing about handling Java on a Linux system is you can have multiple instances and switch between them easily. But you need to take care that the other tools are also going to rely on the new updated version. So JADX, for example, might not work on Java 8. Therefore, you have to figure this out and then switch back for the certain type. Alright, now let's install Java 8. Therefore, we run sudo apt-get install open JDK, 8 and then the JDK. I will come back when this installation process has been finished because this might take some minutes. Okay, now we've also got Java 8 installed. Let's figure out what's the case. We run java -version and we can see we are using Java 11 right now. To switch back to Java 8, we have to update those alternative config, and we can do this by sudo update alternatives --config and then we provide Java. And here we can see we are using Java 11, but we can switch now to Java 8 because we have this now installed. I type in number 2, we can see this on the selection over here. And now we are using Java 8, and that's all. This is pretty easy, right? Let's figure this out. We can see this Java 8 has a different version parameter, which is super ridiculous, but okay. And now we can see, yes, we are using version 8. We also have to do this for the Java compiler. And therefore I go back to the command and I simply do this once again for Java C. I also provide the selection 2 over here. And now we also have this Java C instance updated to Java 8. Is it the same? Yes. Okay, now let's try running Gephi once again. And we can see, yes, Gephi is now working. Great. Please take care that you have switched your Java instance for now, and this might interfere with other tools. So after using Gephi, you might want to switch back to Java 11. Okay, but for now we stick to this one. Let's open this file. So open graph file or use it over here. We go into apps, reverse me challenge, call graph, and we select this file and then hit the OK button. Going to maximize this real quick. Okay, afterwards. Now we can see we've got 28,000 nodes and 58,000 edges. So these are functions, and displaying them will be ridiculous. Let's see how good is Gephi doing this. We can see it's slowly loading, but now it's finished. Nice. So we've got this big blob over here and every single dot is a single function call. We can now apply different layouts to handle this a little bit better. And we can find them over here. So if we choose a different layout, for example, this one over here, and we click run, then Gephi is trying to expand this to the view which we have seen on the documentation. But I'm going to stop this because even if Gephi is able to display all this information, we are not able to handle them easily. Therefore, let's filter out in just the information we are interested in. So to filter this, we go into the data laboratory over here. And within the label, we can see this class names and also underneath the arrow, the function name. We are not interested in the Android support v4 and other packages. We are just interested in our package. Therefore, we use this filter. We click onto label and then we provide com.apphacking.reverse_me. It's a regular expression and therefore we do not have to provide those slashes over here. And these are now all function calls within our application. It looks way more clean, right? Okay, let's extract them. I click with the left mouse button onto one and I select this. I hit Ctrl A to select all of them. And then I click right mouse button. And then we say, let's see, move to new workspace. This is the easiest way for me to extract them from the other versions over here or the other function calls. We have now created a new workspace, so we can close the workspace 1, the old ones. Yes. And now if we go back to the overview, nice. This looks way better than the previous approach. So we have limited those edges and function nodes only to our package name, which is way more clean than the approach before. Okay, so let's figure out how we can display these information. So by browsing over one, we can see, only the single function point gets highlighted. If we want to get the reference to this one, we can enable this by hitting this button over here, show edge. And now we can see those lines. And if we hover over one, we can see, okay, this one is calling those three or vice versa. We will figure it out how to read this later on. I'm also going to enable this one because if we highlight one color later on, these function points are also going to be highlighted, also those lines. We've got some single dots which are not going to be referenced in here. So what is this function call over here? That seems not to be called. We can enable the label for this with the text button over here. And now this hasn't become more clean, right? Yes, but we can adjust this label. So by expanding it over here, we go into labels and then we can select the font size and also, the color and things like this. I go on a font size 12. Okay, this looks more clean back again. Let's figure out what this single dot is here. And if you do not have the drag menu, you have to select it over here. And then you can drag and drop those points. We can see this one is regarding to the R class, the init. So we are not going to call this constructor for this class, but of course it's available. And therefore it's not referenced or has some edge nodes over here because we are not calling this function, but it did get called in the Android system itself. Therefore we have those single dots which seems to be not called anymore. Okay, with the right mouse button you can navigate around. So finding our flag method over here, it's like find Voldo in a really huge picture. And I guess that's also not the approach we want to take. Let's mark our flag function that we can find this more easily. We go back into the data laboratory, we search for label and then for the flag method. And we can see, unfortunately, the resource hasn't really been reduced because we've got this flags parameter in all those functions over there. We have to do a different approach. Therefore, we search for one because this is the class name that contains this method. And here we can see we only focus on the part after this arrow. So here we have the method flag, move on, init, distraction, and one compare. I do a left mouse click on the flag over here and then a right mouse click and I say edit node. And now we can adjust some layout for this node point. I do a color change, therefore I click onto this, I select green and then I drag also this button over here, which is I guess some alpha value for this color. Let's see. It got some more values over here. Okay, but now if we click OK, we can see this flag has now been set to green. Let's go back and find our Voldo over there. Zoom out a little bit and here we can see, yes, it's good to see this one over here. Nice, we've got our flag method and we can now also see which functions are referencing to this. We can now start dragging out those functions, but this is not a nice approach. Therefore we use a filter or a layout. We select this one, this Rheingold. This is pretty good for our task. Then we hit run and now we can see the layout changes. I guess we can hit stop because it's already done. You also have some other, for example, for expansion, then you are going to expand this whole graph. It's more like a zoom in and also contraction and other stuff. So feel free to play around with the layouts. In my case, I think this one is really good for our task. Okay, let's filter this a little bit more manually right now. So our function calls are now stacked together over here and we can select all of them. Let me figure out this one does not contain our block. Okay, we are now dragging them a little bit together. In this way. And we are using this cursor over here and we say configure the size of this cursor to, let's say, 80. Can be a little bit bigger. 120. Yes, and now we can simply, we have to stick to the hand. And now we can simply click and drag this block out. All right, we have isolated our function call graph regarding to our flag method from all the rest. Nice. Now I do some manual adjustment over there that we get a nicer overview. I'm going to speed this process up a little bit. Therefore, I switch back the size of this cursor, and now I'm going to do this. All right, here we have now our final overview about our function call graph. Let's figure it out how we can reach this flag method. So we start over here. And yeah, here we have to look very careful, because here we can see, if we zoom in, this arrow is pointing into our flag direction, and this green arrow is pointing away from our flag method. Therefore, we need to follow the left approach because we want to reach our flag method. Okay, let's see what we have to call. Within this one, we have to call this one 4 move on, and this one needs to call 3 move on, and this one needs to call 2 move on, 1 move on, and here we are at our check, which is our entry point. Okay, now we have traced this back. Let's figure it out how we can reach this from the beginning. All right, we've got our check method, and this one calls 1 move on. We can see this in the arrow over here. Now we've got our first branch over here. So this method makes a decision, and we end up in this one over here, 2 move on, or we end up in 5 final value. And if we end up in 5 final value, we are out, because we cannot reach our method on top anymore, because there's no reference to this one. This one is going from here to there, but it's not going to be backwards. You can also see this if you hover this. We only have this line at the bottom. At this point, we already know, okay, we have to make this check that we definitely go into 2 move on. From there on, we've only got one direction into 3 move on, 4 move on, and here we have our next branch. And this one is also really important, because this one makes now the final decision if we go into our check over here, our flag check, or if we end up at this one, 5 move on. But this one is a dead end. So if we go this direction, we lose. If we go right, we win. That's easy. And yeah, this is the approach on how to create and handle a call graph. Let's assume I wouldn't have named this that nice for you. So there isn't a method 1, 2, 3, and 4. So these methods are named A, B, AB, ABC, and so on. You would go crazy if you stare at this code and try to figure out which direction ends up in the final flag check over here. And maybe the flag check isn't named as flag and things like this. So you can try to do this approach manually. It's also not that big of a flow graph over here, but imagine you would have go through 30 or 40 function calls to finally reach your point. I guess this is the best approach, at least in my opinion, to solve this task. Feel free to solve this challenge. I'm not going to spoiler this, and yeah, if you have questions regarding to the solution of this, please write me a message. Alrighty, in the next section we take a look at the real world Android capture the flag, and this one was pretty hard. So showing this approach on a challenge like this really points out the benefit of creating a call graph or a flow graph for an application that is obfuscated or made to be hard to reverse engineer. Feel free to play around with this furthermore, also with the settings, layout, color definition, and things like this. And yeah, after you have finished this, I'm looking forward to see you in the next section where we take a look at the real world capture the flag challenge. So I'm going to see you there. Welcome back. It's CTF time, and therefore I pulled out my black hoodie and we are going to take a look at this very hard reverse engineering challenge. You can find this over here, and I highly encourage you to register yourself on this website and also take a look at the other challenges. Maybe after this course, because then I have weaponized you with all the skills and knowledge on how to solve them. In my case, I already did this, I guess, 2 years ago. And this is not a flex, this is something you might expect from me, right? Absolutely, and I'm glad that I didn't disappoint you right there. The challenge we are going to solve with the flow graph is the UPOS challenge. And this is also the challenge with the highest amount of points and the least amount of solvers. So this is definitely the hardest challenge in this whole box right there. But what makes this challenge that hard? It all did start with the APK itself. My first attempt was, okay, let's try decompile this application and get the Java sources out of this. I opened up my terminal and neither JADX nor dex2jar was able to compile or decompile those classes.dex files. Therefore, I didn't have a Java source code right there. And this was the time where I was looking for a different decompiler than JADX and dex2jar, and I found one, the DAD, within the Androguard tool. And finally, Androguard was able to decompile this application, and I was like, great, maybe this is the hardest part in this challenge, to decompile this application and get back those sources. Well, I was completely wrong about this, because after decompiling this application, I did end up with a bunch of methods. There weren't that many, I guess 3 or 4, but one method was really huge. And this method did look like this, multiplied by 20 times. So this method was full of branch instruction. We get our input, we pass it into a function, and then we got tons of branch instruction. And you have to think of this. One leads to this, and one leads to this, and then we've got these, and then over these, and this multiplied by, 20. And finally, in between all those branch instructions, there's this one single solution which we have to reach. But there were some little sneaky branch instruction in there. It's not like that always the true path is the correct one. Sometimes there were checks like, does this flag contain the following value? For example, upos, and you were like, oh, okay, maybe upos has to be within our input, and you followed the correct branch instruction, but it was the left one, the false branch instruction, and things like this. I guess there were also some anti-debug mechanism there. If you hooked up Frida and tried some runtime analysis, the application behaved in a different way. So this one was ridiculous hard. And after staring at this Java source code, I was like, okay, it's not possible for me to solve this challenge by staring at this Java source code and figure out which branch instruction leads to the final solution. The solution itself, by the way, was not really hard to identify because there was this really long hash, and your input gets modified during all those branch instructions. Afterwards, the input gets hashed and those two values get compared. So where we have to go, this was pretty clear. But how do we get there? Absolutely not. And therefore I figured out, okay, for me the only way to solve this is creating a flow graph. And you will see the benefit afterwards if you have this, and we can then eliminate all those sneaky and wrong branch instructions, and afterwards we end up with a clean way. This isn't that easy as it sounds because this takes time. I guess it did take over 1 hour to eliminate all those wrong branch instructions. But these are the two main keys, patience and time, if you reverse engineer Android applications. Alrighty, the last thing I want to mention is the flow graph contains only Smiley instruction. So we do not get our Java source code in this flow graph, we do get our Smiley source code in there. For me, at this time, this was no problem because I was pretty familiar with the Smiley. But if you want to solve this challenge afterwards, you might have to wait until we have finished the next chapter where we learn Smiley if you're not familiar with this. Of course, if you already know Smiley, then feel free to go ahead with this approach and try solving this challenge. And let me know about this if you could solve this with the flow graph. But please don't ask for a solution. I'm not going to provide you the solution for this, okay? The last funny thing about this challenge was, after I have solved this, I talked with the author about this. And the author did also mention that he did not expect that a decompiler is able to decompile all those Java sources. But even by having this Java sources, I did not get any benefit out of this because the flow graph itself, which was the main concept in solving this challenge for me, was written or has this instruction in Smiley. So even if I did decompile this application, I did not get any advantage. So this was pretty ridiculous for me. But it's super nice to see that different decompilers give different results. So if you struggle with the decompiler, try different tooling. For example, dex2jar, JADX, and now also Androguard. Maybe one of them is able to solve it, or maybe one does better than the other. So please try different tools. Maybe one of them is able to solve this task. Alright, next we are going to have a look in this challenge. We are going to download, install it, and then we take it apart. But only until we get to the point where we have created this flow graph, because I do not want to spoiler any further. Okay, here we are now at our Ubuntu VM, and if you want to download this challenge, then please go to this website. This is the website of the author, and you can find those challenges over here. By the way, the author also put in some amazing slides which you can find over here. So definitely also have a look into this one if you are interested in a certain topic, which is super nice from the author. Okay, you can find the challenges here, and then you have register on this website with an email account, and then you can finally download this APK file. I'm not able to provide you directly this APK file because I would circumvent this whole mechanism of the author, and this is something I don't want to do. The author did put a lot of work into those challenges, and it would be absolutely fair if we at least leave a registration for his website over here. All right? Okay, you can pause this video and register your account over there and download this upus.apk file, and then you can move on with the video where I explain on how to create all the stuff, or you can just lean back and watch me doing this. So I'm going to close this one, and I already downloaded this file. It's within the downloads directory, and here we have it. I copy paste it, and we create a new directory over here, and we name this upus challenge very hard. Alrighty, let's start decompiling this Android application with our DEX to jar approach. Let's see how good this goes. No, I don't want to update right now. And therefore we have to unzip this to get those classes.dex file. Here we have them, we've got 2. So I would assume our interesting source code is over here in classes2.dex. Dex to jar. And here we have our classes2.dex jar now. If we run JDGUI, we can see we have a code over here. Let's figure it out. Yes, Dex to jar is still not able to decompile all those methods, as we can see right here. So this one is the check flag method, and we can see we only got this Java bytecode over here. So we cannot do anything with this right now, okay? Maybe not okay, but we do not have a choice. All right, let's try JADX. JADX GUI on those upus APK. And yes, JADX GUI seems not to be able to decompile anything, but this is an error which is regarding to using the wrong Java version. So in the last video we have changed the Java version. Let's check this real quick. Yes, we've got Java version 8 already installed, or not installed, already in use. We have to switch back to Java 11 if we want to use JADX GUI. All right. So sudo update alternatives --config Java. Yes, and then I select version 0 to use the Java 11. And we also have to repeat this for the Java compiler. Also 0, okay. Now it should be fine. Yes, now we are back on Java version 11. Let's try this again. Yes, okay, this is the window which we should at least get. So if you get a blank window over there, then it's regarding to an outdated Java version. It's annoying, I know, but unfortunately we have to deal with this. Okay, let's see if JADX is doing this. So we can see also JADX is not able to decompile this code. All right. Now let's try androguard. Androguard --help. And here we have this decompile. Androguard decompile --help. Yes, and here we have now the options of androguard decompile. We can see, for example, we can define an output directory that contains then our Java source code. So androguard is decompiling those classes.dex with the DAD decompiler, which is also mentioned here, and creates those single Java class files in this output directory. And this one we will take a look in a few seconds, because this is now the flow graph we can create with the decompiled code together. Okay, but for now, let's only try decompiling this application. Androguard decompile, and then upus, and we have to provide an output directory. I simply named this out because out is not available over here. So we didn't create this directory yet, but if we provide it as a parameter, then AndroGuard is going to create it and stores all this function and decompiled code into this. Alrighty. This might now take some time because, yeah, it's a lot of stuff going on there, and I will come back if this decompilation process has been finished. Now the decompilation process has been finished. Let's figure out what we've got here. Okay, I'm going to open this in a file browser, then it's easier to see. This seems to be our main package names. We've got Android, Android X, and COM. So I would assume our code is within COM because this sounds like the developer path. Mobisec, UPOS, and there we go. We've got Java files, but we do not know how good they are right now. We've got also this directory, and here we've got some HE files. We will take a look into this later on. Okay, here we have now the flag check Java file. Let's try opening this. I open this in the terminal over here, then we are in this directory, and I use gedit, for example, fc Java. Okay, and here we can see this looks like, yes, this is Java code, nice. So AndroGuard is able to decompile this file. We have this check flag method over here, and this is all Java code right now. And you can see all those branch instruction already and the sneaky traps. So our input might have to start with Mobisec or might not. We do not know right now. You have to go down the whole rabbit hole. And you can see there's a lot of stuff going on. If we scroll through all these instructions, and here we can see this one is the final hash that our input gets hashed and compared against afterwards. But this is not the end right here, so I guess, yes, there's a lot of stuff underneath this. So there are some jump instruction upwards and things like this. You can try solving this with this Java source code, but you would go absolutely crazy. Therefore, we are going to create a flow graph. But first, let's install and run this application and have a quick look in how this looks like. The view itself is pretty clean and easy, and yeah, but it's good to know what we have to deal with. So therefore, we go into our apps directory, UPOS challenge, and we are going to make our connection via ADB. Alrighty, then we do ADB install upos.apk. And we are also going to get the screen over here. Here we've got this UPOS application. I'm going to start this. And yeah, as already mentioned, we have to provide this flag over here, and then we have to check this flag. Okay, going to close this one and clean this up real quick. Okay, now we want to create a flow graph for this application. So let's have a look at the official documentation of AndroGuard because we don't know how to do this right now. Therefore, we go into our web browser of choice, AndroGuard decompile, and we take a look at this documentation. Because within the decompile command, we have seen this -f option, additional write control flow graphs for each method. The format is in PNG, JPEG, or RAW, which means a .dot file. All right, if we scroll down a little bit, we can see the examples, and there we have an AndroGuard decompile -o output folder. This is absolutely familiar to us. Then we've got this -f option, which means, okay, write this control flow graph as a PNG file. We have to provide our APK, and then there's also this nice parameter, which is limit. In the last section we have seen, we've got about 25,000 methods in our APK. And if we are now going to create a control flow graph for each method, which an output as a picture, this will take up to an hour. Therefore, we can limit the output to just a certain class names, that we do not have to decompile and provide pictures for every method in this application right now. And this is a regular expression over there, so we can define the beginning of our class name. And I'm going to show you what this looks like for our case. So if we go into this UPOS challenge back again, and we can also use JDGUI to open this classes.dex to jar, because we do not need the method name, we just need to know the class name. And here we can see we've got this Android package, which we are not interested in. We've got this Android X package, which we are not interested in. And then we've got this COM, Mobisec, UPOS. And we only want to filter or provide those call graphs for these functions over here. Therefore, we provide our filter for this package name. And here we have the regular expression for this. The first char needs to be this big L, which is the type definition in Smiley. For now, there's a class name. In our case, it's not com elite, it's com/mobisec/. We can also provide upos in our case, but mobisec would be enough to only decompile and provide those control flow graphs for these classes in this package over there. All right, we can also see we have to install two additional dependencies. We need to have graph_with and py.dot installed. Let's do this real quick. So we run sudo apt-get install graph_with. Yes. And regarding to the py.dot, we stick to our Python 3 version because AndroGuard needs Python 3 and therefore we are also using pip3. pip3 install, upgrade those packages, py.dot. Okay, both have now been installed. We can now create our first flow graph. So therefore we go into apps. This is the upos challenge. And we create a new directory, I would say. Yes, we create a new directory. So we say AndroGuard decompile --help. And now we say AndroGuard decompile. Let's see. Our new directory is now upos_cg for control graph. Oh no, it's flow graph, therefore fg. Then we provide our format, which is png. And we want to limit it to the beginning, this way, of com/mobisec. All right, this should work. Let's see. Give one file to decode. That's right. We have to provide our APK, of course. This should work right now. Okay, it's starting decompiling this, and even for these least amount of methods, this might take a while. So I will be back if this process has been finished. All right, finally this process did finish, and this weren't that many methods. Now let's imagine if we have decompiled this whole application and created a flow graph for all methods. This will take quite a while, I guess up to an hour. So let's see what we've got here. I'm opening this in a file browser. And this one over here, upos_fg. We've got now com/mobisec upos. And here we've got now still those AG files. I'm going to show you this, how they look like. Let's see. This, for example. So here we've only got the decompiled output, like if we have done this with dex dump. This is just the output which is stored in there. It's pretty helpful if you want to go through this, but yeah, I guess we are not ready for this right now. We will learn on how to do this, but yeah, not yet. Okay, beside this, we've got now these pictures over here. Let's figure out where's our flag check. Okay, at the beginning, we've got this class name and then we've got this method name. So let's have a look back real quick. We can also use this one, which was not able to decompile it. Okay, we should have an fc file name with a check flag method. So it should be here. Let's see. Here we have this. So if we search for check, it's easier to find. I didn't see this one right over here. Okay, and now we can open this. I recommend you opening this with GIMP because this file is really large. You can see this. This is 32 MB large, which is ridiculous for a picture like this. And yeah, the best way to open this is using GIMP because otherwise you might run into trouble. So we open a new terminal over here and then we say GIMP and we use fc and I hit the tab button multiple times. And now we have to search it again. Oh, it's at the beginning. That's maybe the reason why I didn't see it. Okay, now GIMP is opening this file right now and we can see it's loading slowly. Let's see what we get at output. Okay, here we have now finally the output of this file, and if you zoom in you might think, ooh, this looks absolutely like a mess, all those lines over here. But you can also see the whole branch instruction and yeah, how ridiculous this challenge is. So if we scroll down, ooh, well, it doesn't get even better, and yeah, we can see this looks absolutely like a mess. But it's impressive how good you can deal with this file. So if we scroll down a little bit, ooh, it seems to get worse. And there we've got a huge blob. So let's figure out what this one is here. These are all Java exceptions. So if we end up here, we might be definitely wrong. And yeah, this is a good starting point because we know if we reach to this level, if we get to one of these, we are wrong. Therefore we can exclude all of them already. But let's figure out where's our solution. And already here we found this. So here's our solution. We need to get to this point over here. And this is really not that hard to find because you have to look at the end of this file and there are not that many blocks. So you have to go from right to left and then you finally retrieve this one. It could be also this one or this one, but that's all. It's not buried in between those over here because then we would have reached this block much earlier. All right, nice. So now we know where we need to go. And yeah, this is Smiley and we do not understand Smiley right now. But we can see we've got a green and a red line and we've got this if. We do not know that NEZ stands for not equals 0. So we just know, okay, there's an if statement and the green one is the right path and red one is the wrong path. But it doesn't even matter at this point for those two, because if we reach to this point over here, we already have our flag compared against this value. So at this point, we know if our flag is correct or not. Therefore, we can ignore all which is underneath this. And we can, graphically illustrate this by creating a new layer. So we click new layer. And you can see this file is absolute enormous big. So you might want to increase your RAM of your virtual machine to view this. Okay, now we've got our layer and now we can drag our pencil into this. I choose yellow because green, red and blue are already chosen. Blue is, by the way, a single path. So if we have a branch with true or false, we've got green and red, and blue is a single instruction, a single jump, this way. Okay, so now we can tell, okay, this one here, we need to get over here. You can adjust the size of the brush over there. So let's see, we make this a little bit smaller, maybe 8. Therefore, we can ignore this, and we can also ignore all those Java exceptions at the bottom. This means we have to go to this one. So let's see where we end up here. We've got this wrong statement leads to this one, and this leads to our exceptions over here. We can eliminate this completely. There we've got also an exception, and here we've also got an exception. And then we've got a true statement over here, and this one, and this one. Oh, sorry, this one we have to take care about. Interesting. This one over here, let me clean this up real quick. This one, yeah. This one got a back connection over here. So this block has the ability to go back this way until we hit our block. Okay, so we might have to take care about this block. The wrong statement also. So we have to take care about the wrong statement because this wrong statement can up in this true statement, and then we can go back to this one. All right, so this block is important for us, and this block is also important for us. You have to choose, I guess, different colors for this to eliminate things and accept them. So let's take red to eliminate them. I guess that's a better approach. Okay, so now we know this one. Let's figure out where we do get here. So here we can get over here. Therefore I choose the yellow part again. This block is important. And this block ends up here, which is this one over here. Okay, this one is also important. This one is not important. No. At the first look, this one seems not to be important, but we can mark this differently, that we have to take a closer look later on this. And by doing this, we end up on the final solution, and by tracing this back, this takes a while. But here at this block, you can already see the benefit of this. Let's see, so we've got this one over here, this one green. So here the true statement is important. And this means this one can be eliminated. This one is not relevant. This one, default statement, is not relevant. So we have to go to this one, this green one, then we have to go to this block, and then we have to go to this block. So at this block, we definitely know the false branch is the wrong branch. And so we can trace this back, and you can see we did not make that much progress. It's okay, I would assume. There's a lot of work still we have to do, but it's possible, or in my case, the only solution to do it in this way. Because if you stare at the Java source code and get all those curly brackets, it's a super mess on how to do this. This looks also messy, but if you try this challenge with this approach, you will be definitely able to solve it. All right. That's all about the call graph. I'm not going to spoiler further the solution right now. If you have any question about this topic, write me a message. I'm super glad if I get feedback on this. And otherwise, we have a last section until we get to this large chapter in our course, the Smiley part. And afterwards, then we will be able to understand what's going on there, what all these instructions mean, which is super ridiculous nice and gives you unlimited power in hacking Android applications. So I see you there. Welcome back, guys, to our final challenge for our reverse engineering chapter. In this one, I find this challenge pretty amazing because it will recap everything we have learned so far. Not only in this chapter, also in the chapter before. So therefore, let's have a look. So we are talking about the insecure bank application, which I really like. So the author of this one really appreciate all the work you have put into this one. This challenge consists of an APK and also a web server. So we have to set up a little bit stuff before. But don't worry, it isn't that much. What we have to do to get started with this one, first of all, we have to install it on our device. Okay, no problem. But then we are also having a web server which consists of Python, and therefore we require some modules to be installed first. So what we need to do next is we need to run pip3-r on the requirements.txt in the given directory. Don't worry, we will set it up together afterwards, but that you know what's going on over here. Okay, after installing all those requirements, we can then start our web server. And this is simply just in Python 3 AppPy. I have converted it to Python 3 because the original application is designed for Python 2, and this doesn't work on modern systems anymore because Python 2 is now out of date. Therefore, I have already ported it for you. Okay, after installing all those requirements, we can simply run this Python 3 app.py file. And then the web server is running, and the mobile connection or the mobile application can make a connection to our web server over here. These are the steps we need to do. Okay, now's the question. We are having different setups, and which setup we should use right now for this application. I mean, we've got our emulator, we've got a real device like this one over here, and we might have also this virtual machine, this x86 virtual machine. What should we use in which setup to do this right now? In my opinion, the best idea is using the emulator because this application has been designed to work as its best in the emulator. There's also some interaction with SMS and stuff like this, which might not work on the x86 virtual machine. You could also use your real device, but then please use a testing device. This application requires a lot of permission, and yes, this might be something you do not want to run on your own private phone, okay? The x86 virtual machine might also work, but we lack a few features, for example the SMS feature or other things. So in case if you're running the system or the emulator on your host system, please go for the emulator. The user experience it's absolutely fantastic. Even if you're using a virtual machine, you can still use the emulator because you do not need to have much interaction with this application. And last but not least, there's this testing device. Alright, now some safety notes. I mean, these points should be clear, but nevertheless, let's recap this over here. I mean, we are running Python code on our system, and we haven't written the Python code on ourselves. Therefore, we should have at least a quick look into this one. Nevertheless, we should always use only testing equipment. So a testing notebook, a testing VM, or a testing device. Otherwise, if you mix testing with your private stuff, this could be absolutely horrible. So you never know what is happening. Don't get me wrong, I trust the author, but these are general recommendations we should keep in mind and also following this guideline through this course. In my case right now, I'm using the host system, which is a testing system. Therefore, I can easily run the emulator on the testing system. In case if you still want to separate those things, you could use a virtual machine where you take a snapshot and where you select host only adapter. If you run this emulator on this virtual machine, it's super laggy, but it works. So it's not that nice, but you can perform all these tasks without having this running on your host system or without having a real device. In my case right now, I will run everything on the virtual machine, which will show that the user experience is not that nice, but it works there. So you could also do all these tasks without having a real device and without running this on your host system. Okay? All right. So now's the question what we are looking for. And the answer is everything we have talked about so far. So this challenge is amazing because it will recap everything we have learned so far. I have not made these topics regarding to this challenge. This challenge has been made regarding to my topics. So we are looking for insecure activities, broadcast receivers, and content provider services, login credentials which are stored inside there, and stuff like this. So this challenge is pretty amazing because it will reflect some real-world applications and their misconfigurations or coding errors. And therefore we now understand everything here to exploit them. For example, those activities, we are pretty familiar with them right now, and maybe you will find flaws where you can bypass certain features. So if you start another activity, it doesn't mean that we have successfully bypassed it already. We have to figure out if we can still do some task in there. Because if this application requires some setup, for example, there are some login credentials which needs to be decrypted first, and if we skip this part, then the application might not function correctly anymore. But this is something we have to figure out. Regarding to the content providers, I have a special task for you. Let's assume we have hacked into this application, which is a banking application, and we have performed some malicious transactions inside there. There's also a logging feature within the content provider, and we definitely want to hide our tracks. So maybe you will find a way to get rid of these log files in there, which would be absolutely amazing. Last but not least, there's something going on with the login credentials. So there is an encryption, and there might be also some additional login credentials. So things you should look for in real-world applications also. I have taken a quick look into this application and have played around with these things, but there might be tons of other things inside there, which I haven't seen so far. So unfortunately, we cannot talk about all of them because then the video might be 4 hours long and no one wants to watch this. But I will also provide you some additional hints or features in a separate cheat sheet where you can have a look into if you're stuck at this right now, okay? At least you should give it a try. So we are now doing the setup together and then you can have a look into this application. Alrighty? Okay, let's have a look. Alright, so here we are back at the Ubuntu VM and now let's do the setup really quick together. So you will find all these files in the attachment of this section. And these files over here. So that's the Python web server and this one is the APK for our device. Alright. First of all, we need to have an internet connection and we need to install all those libraries and tools that Python requires right now. So pip3 install-r requirements. And then you can see I have already installed them. Okay, now we can simply start this web server by running python3 app.py. As already mentioned, internet connection is not required anymore. Okay, this Python web server is now running on all interfaces we are having. So let's see. This means we are having no IP address or internet face running up on here and here. So where should this emulator now connect to? This emulator has its own network interface from our Android Studio. So there's some DHCP settings and the IP address is 10.0.0.2, I guess. So this is pre-installed in this application. This means on this interface we are having this 80808080 port listening right now, which is our web server, this one. And we can simply connect to this one. But to get this interface up, we first have to start our emulator. So let's do this. Emulator, and I do not know what's the name. So list avd, emulator, list avd, list ABDs. No, there was an S missing. Okay, that's the name. So emulator, and then add, and the name. Whoops, once again. That's not that fast anymore. Okay, now we have it. The emulator is starting, and we are already getting this node running in virtual machine. In another virtual machine, it's not a good idea because they have to share those resources. And even one virtual machine, is struggling with this one maybe, but we can see the Nexus emulator over here, it's working perfectly fine. So even in a virtual machine. Okay, here we have the device, and you can see, yes, that's well enough. All right. Now we need to install this application. So Android Lab server, here we have it in Secure Bank. Okay, the ADB connection needs to be established right now. Success. And here we have it. Perfect. I also recommend using this Nexus emulator because the other one are more powerful and require more resources, but we do not need a powerful emulator right now. We need some basic concepts, and that's good to go. Alright, starting this application, we can see a lot of permissions. Files and media, something pretty interesting. We have to take a look into the SD card because there might be some files stored on a public available directory. SMS, also interesting, contacts, phone, call log, and location. Okay, continue. And this application has been built for an older version. Okay, not sure what's running right now. I guess Android 11, but it works perfectly fine on this one. Okay, we can simply click OK, and then we should be good to go. All right, now if we open the web server, where do we have it? I guess it's this one. Yes. So let's put this on the left. Can we clear the screen? No, then we are running it simply once again. Okay. Now we are having this application, and here we are having in the web server. As an attacker, we do not have access to this log file over here because this is running on the real web server. We can only interact with the application on the device, but it's nice to see some debug log over here. Okay, let's see if everything works. Therefore, we should have, or we need to configure the web server first, but as already mentioned, if we click on these three dots, then we can see preferences. And here we can see the server IP is 10.0.2.2.80.80.80.80. Let's see, do we see this interface here? No, it's not a network interface within our Ubuntu VM. It's a network interface in the emulator right now. And this emulator is being provided, or this network interface, by the Android Studio. So we are having also this one running on this interface, which means if we click submit, then we can see save configuration successful, but we do not know if it's working. So therefore, let's try to log in. Admin. It lags a little bit, but for running it in another virtual machine, I guess it's fine. And I'm just using 8 GB of RAM. I guess that's not that much anymore. I grew up in a time where 128 MB was quite a big deal, but nowadays 8 GB, I guess that's pretty standard. Okay, we click login. And invalid credentials, so that's appearing here, and we can see user does not exist. Okay, perfect. This works perfectly fine. I mean, here we have now this information leak that the user admin doesn't exist, but this is happening on the web server part, and as an attacker, we do not have access to this one. All right, this is the whole setup. I wish you good luck with this one, but most important, have some fun. Okay, as always, I will do the solution video afterwards in the next video, and there I will provide you some hints if you get stuck at a certain point. So therefore, let's go, and I see you in the next video. Welcome back. So let's have a look into this one together right now. In case if you could solve this, then this is pretty amazing. And you can see those things we have learned so far, they also apply on real-world applications. I mean, yes, this is a challenge, and some of them has been configured in a really strange way. But these are things you should definitely look for also in real-world applications. So they still exist there. So let's have a look. Okay, we are within apps, Android Lab server. I've got the setup still ready, and we can still not log in. Okay, the first thing I like to do is using JADX GUI to open this application. Okay, so here we have it. And now within there, the first thing I like to do is having a look into the Android manifest. So here we can see what's going on. I mean, all those permissions, we have already seen them at the installation part, but yeah, write external storage, absolutely interesting. And the rest might not be that interesting. I mean, SMS, this is also something we should take a look into this. Yeah, read external storage and things like this. One thing I would like to mention over here is we are using just the Android system permissions. So there are no custom permissions which could open some things right now. So at least that's good for this application. Okay, then we've got this application part and we can see it's debuggable. Okay, we will learn or do this later on in this course. And we can also see allow backup has been set to true. So with the ADB, the Android debug bridge, we can create a backup and then we can have a look into those files if there might be some sensitive information in there. If this is enabled in an application, you should definitely do this to see what's inside there. Then we've got our starting point within those intent filters, category launcher and action main, which means this is the first activity that gets opened. And this is something I definitely want to take a look into. Starting an application can be done in several ways. So if you click on this icon, this activity will be launched. And there might be some interesting stuff. For example, most of the application checks if there is already some database creation. So if the database has been set up correctly. And for example, most of the applications do some setup first. The database, shared preferences, files, other stuff. And they have some checks. Has this been already done? If not, then do this. And then we have a direct reference to something maybe interesting in there. The other thing how an application could be started is, for example, via a broadcast receiver. This boot complete broadcast receiver. So after the system has been booted up, we can react to those events and then the application could be also started. Then we need to have a look into the onReceive method on this broadcast receiver. So this is something I definitely want to do, figuring out all these entry points of an application and have a look into there what's happening there. We can go down the rabbit hole. I mean, we've got a bunch of stuff on the left, but at least we should have a look into the starting point of this app. All right, then we've got activities, and we've got a lot of activities. 2, 4, 6, 8, 9, not sure about this one. I'm not good at counting. So here we can see we've got activities, and yeah, I just look at those names to get a feeling what's happening there. File pref activity, so something with files. Do login, okay. Post login, interesting, there are 2 separate activities for this login process, and even the launcher is a logging activity, okay. Interesting. Wrong login, also interesting. Do transfer, and this one, view statement. What do we need to look for in those activities? Of course, if they are exported, because if they are exported, we can interact with them. And we can see exported set to true. Over here, oh, there's a lot of stuff set to true. We've got post login, interesting. Do transfer, even better. So maybe we can simply open the transfer option and get some money from account A to account B. And things like this. On real world applications, pretty unlikely, but in this challenge, maybe. Then we've got provider and content provider, so some form of database access. Track user content provider. This sounds exactly like the challenge I have provided to you. So there might be some tracks about the things that the user does, and maybe we can delete those tracks. Then the user or the user which is looking at this log file doesn't realize that something happened in there. And we can see exported set to true. Amazing. Then we've got a broadcast receiver. We've got more broadcast receiver, but this one here, super generic name. Nothing, no clue what's going on over here. We can see that's the name, my broadcast receiver, okay. And the action is the broadcast. We have to take a look into this one. It's being exported and that's a possible attack surface from outside. So having a malicious application could trigger this one over here, but we do not know what's happening inside here. All right, then we've got additional activities. Change password, exported to true. Interesting. Then this one over here, these are things which I skip in a first view because here we can see the package name is com Android Insecure Bank. That's the package name over here. So that's the developer code. And here we can see we are within com Google Android. So these are core features of Google. and therefore they are just included into this application. AD activity, so maybe some advertisement or things like this. Yes, there could be flaws in there, but I would focus on the developer code itself. It's most unlikely that we find something critical in here right now. Maybe there's some critical flaw within the usage of them. So this could be still messed up. But if you have that much to do right now, I would recommend focusing on the developer code. COM, Android, Insecure, V2. All right, the rest is Google stuff. Okay, we skip this. So now let's see, we could start with the activities, and I would recommend having a look at the login activity at least. Okay. Oh, what catches directly my eyes is my shared preferences. Username, password fields, okay, we have seen this, and some basic 64-byte string. All right. So my shared preferences means we are having data being stored in a protected directory of this application. We need root privileges to reach this, and therefore I wouldn't count this as a security issue if there are some credentials inside there. Nevertheless, it's pretty interesting. Maybe there are some autofill credentials or things like this, because we have seen this button. And this one, autofill credentials. So maybe there are some generic or global credentials inside there. This is something this would be in finding. But having credentials, user credentials stored in a protected directory, I wouldn't count this one. Nevertheless, it's interesting having a look into this one. Okay, and then we've got a bunch of Android app development, which we do not understand right now. But that's not a problem, because we can look at those strings and maybe figure out what's going on. We've got this onCreate method. Okay, we know onCreate, that's being called when an activity is being created. So this is the layout of this application in this method, which means this part over here, maybe let's take a color. And this part over here defines the view of our activity over here, in this one. Because this is our logging activity, that's the entry point when we start this application, and here we have this onCreate stuff. Okay. So let's see, what do we have inside here? Get resource string is admin equals no, find view button, set visibility. Yes, sounds a little bit cryptic, but the things we get is admin no, set visibility to this one. So maybe there's a secret button inside there, and if we are having admin privileges, we see this button, and if we are not having admin privileges, we do not see this button. This would be my generic interpretation of this code right now. To be honest, I haven't looked into this one. I have looked into other parts, but this one I haven't yet taken a deep look into. But to be honest, this might sound absolutely interesting, because if this is an intent that gets be triggered, for example, if we click on this button and there's an intent happening, maybe we can fire this intent from our own without having this button inside there. So we could write, as we have seen this in the past in the activities, we could start an intent and provide additional parameters to this intent, and maybe we could create a user which has privileges or things like this without even having access or credentials for this application. Maybe. I'm not sure about this one. Maybe I will have a look into this one later on. Okay. Then we've got some other stuff, logging activity, perform login. Okay. On click, I mean, if we click on a button, then we perform a login. This is something we should investigate later. Here we're having create user. Okay. This sounds also pretty interesting. But this might be the button which is yes. So I guess that's the button that's not visible right now. Then we've got on click, fill data. All right. We've got a lot of exceptions over here, and having many exceptions, I mean, that's a good indicator to have some complex stuff where things could go wrong. This is often the case for cryptographic functionalities. For example, invalid algorithms parameter exception, invalid key exception, no such algorithms exception, bad padding. This points to cryptography. So maybe there's some kind of encryption and decryption happening with those credentials we are inserting here. This is just a well-educated guess. Reverse engineering some code is like, okay, we reverse engineer this, we make some guesses, and then we have to verify if our guesses are correct. So we do not know if this is the case, but we have to start somewhere. And yeah, this is my well-educated guess for this one right now. Okay, create user functionality is still work in progress. Oh, okay. Even if we can make and if we can trigger this function, there's no code behind this one. So it's not worth taking a look into maybe. Then we've got fill data. And here we can see all those exception once again, and we can see username and password, okay? Encrypted username, super secure password. So these are not, this is not username and password. We are within the shared preferences context. So here we can see we are having shared preferences, which is being referenced as settings. And now we have the method getString. GetStrings means the application is looking into the internal file, which is stored in the shared preferences, and gets those strings into this application back again. And we are now having some key value pair. So this one is the key and this one is the value, which means in this file we are having a structure which is encrypted username and super secure password, and then there are some values inside there. If we are not having values inside there, then we are defining these default values null. This is how this part works, which means we are going into a protected area of this application and we check if there are some values inside there and we store them in username and password. Okay. So let's see. If this username is not equals null and the password is not equals null, then we've got username base64 byte string. All right. So this is something we can understand. So we have this username fetched from our shared preferences and we are simply just doing base64 decode. The username is therefore definitely not encrypted as far as this goes directly into this function. So this part is not encryption, this is just base64. Okay, then let's see. So this one is now containing our username in clear text, this username base64 byte string, because it's being decoded over here. Okay, so let's see, where's this being used? It's being used over here. So we can see this is now once again a little bit Android specific, and this is why I recommend doing a little bit of Android app development. Then it's easier to follow along with this, because otherwise this might not be understandable right now. But let me try to explain this. So here we are fetching the references to those two fields. And this one here is an edit text, and this one over here, this one is also an edit text field. And here we are fetching the references of this one and this one. And then we are writing content into those fields. And we are writing the content which has been previously received from our shared preferences. So we write in here our username and here the password. And the password is AES decrypt string. So the password is encrypted in the shared preferences, but here we write the plain text. So this would be absolutely readable for us if we hit autofill credentials and if there has been some setup before. So if we log into this application, the shared preferences file might be created, which contains the last username maybe. And if we hit autofill, those credentials will be retrieved from this file. The username is only in base64 string, and the password seems to be encrypted. So these are the guesses right now we can conclude out of this one. We do not know this, that's just a guess. Okay, then we can see if the username is null or the password is null, no stored credentials found, and if both are null, then no stored credentials are also being found. Okay, this is something we could test. If we simply click autofill credentials, because we are in the method fill data, then we should get no stored credentials found, because username is null and password is null, which is the else case. Let's see. No stored credentials found. Okay, if we are inserting a username, for example admin, And if we hit autofill credentials, no stored credentials found. I mean, it's amazing because both are identical, but this one should be now this case. Because we have provided a username, the username is not null, but the password has been set to null, so we should be in this case. All right, it doesn't bring us further, therefore let's move on. Perform login. Here we can now see we are oh yes, okay. Here we can now see we are fetching the text from this one. This is this part. And here we are fetching the password. And then we are passing these two information via here. We are passing them to those two information. So to be more clear, the user will be here afterwards. And the password will be here. And we are passing this to the doLogin class. So within the doLogin class, those things are being compared. And yeah, there's no check right now. So this means our credentials are being checked in the doLogin class. It might be not the case, if perform logging is not being triggered here. So let's see. Perform login. Okay, we can see perform logging is being called over here, and this one is the logging button, which means we are definitely calling perform login, and afterwards they need some check if we have entered the correct credentials or not. This means the check happens in the doLogin class, pretty likely right now. All right, and I guess that's all. So there's a ton of stuff already happening in here. I didn't mention to go that deep right now into this one, but yeah, nevertheless, we have done it right now. And yeah, let's recap this real quick. We're doing some stuff with the shared preferences. This might contain our username and encrypted password if we are successfully logging into this application even once. Because now if we start this autofill credentials, we are getting no credentials found. Because we can see those needs to be fetched from those shared preferences, and there are obviously no credentials inserted right now. Okay, then we've got this really strange admin button, which appears if we are having admin privileges, which is super interesting because we are still in the login function over here. So therefore we are not having a user context right now. Interesting, but something we might want to investigate. And then yes, we've got the shared preferences, those things, and we can see the login class, doLogin class, is performing the credential stuff. So a quick look maybe before we go to the activities. Just a quick look. Let's see. Okay. Yes. Okay. There's a lot of stuff happening there, and this is something we might not want to check out. So if you want to investigate this, okay. But as far as I have seen this might be regarding to the web configuration. This would mean that those credentials might not be stored on the application. So we are having now a real-world application. This application, let me try to explain this differently. Yes. So this application is making a network request within the doLogin class, and the web server is checking if the user admin is available or not. This means those user information which can be used to log in are not stored on the device, at least not them which has been defined by the user. There might be some other credentials stored inside there, so some generic credentials, service account, operator accounts, generally user accounts, things like this. But not those user credentials which are normally used to log in. And this is perfectly fine because this is like real-world applications are handling this stuff. So the server is managing those user credentials. For example, if you register to certain applications, if you provide some username, email address, password, and things like this, those information will be sent to the server, and the server is handling this. In case if you want to log in, we need to have the real credentials because we could patch this in the application, but maybe then we lose the access to the server part. So those network requests might not take effect anymore. We will cover this whole process, this stuff in the man-in-the-middling part, where we talk about man-in-the-middling and network connection, and then we will have a look into this part right now. Okay, for now we can skip this. So if you want to bypass this, we have to figure out if there are some hard-coded credentials in this application inside here, which can be used to log in into this app. Those hard-coded credentials might also occur on the server side, of course. This can happen. It's not that most likely, but this could be the case. But this is something we definitely should take a look into. All right, so to bypass this part right now, I would go for the activity approach. And therefore, let's do this right now. So let's clear this up. Okay. Let's see. Okay, we're having the logging activity. We've got file pref, post logging, which has been set to export it through. You know what? Let's simply take this one and let's insert this in a new Visual Studio Code file. Okay, and now we can select activity. Then we can apply a regular expression. And then we can say exported equals true. Okay, then I hit Alt Enter and I copy them and paste them in here. So now we've got all those exported stuff. Oh, there's some characters missing here. Okay. So now these are the activities we can call. We've got post logging, do transfer, view statement, and change password. Let's try starting with post login. So can I set this on top? No. Then let's put this on the, let's put this on the right. And now let's see. Let's put this, yeah, let's do it in this way. Okay, ADB shell. We connect via ADB and then we are using the activity manager and we are using AM for activity manager and we are using start activity. Then we have to provide the component name. So let's see. Okay, it's not mentioned here. Then we might have it in the intent options. Yes. Category, nothing we are interested in. Component name, there we go. Okay, AM start activity -n, and then we have to provide the package name. The package name is this one. And then we have to provide our activity name, which is this one, this post login. Okay, let's start with this one. 3, 2, 1. Nice. Okay, I didn't expect it that easy, but it's pretty nice. And there's also this device is not rooted option. I'm not sure about this one. Let's see. Oh well, for me it looks like a rooted device. Yes. So can we? Yes, this device is definitely being rooted. So this rooting detection is just bad. I do not blame the developer. Maybe it's designed to work in this way, but this routing detection is not fetching our routing option right now. All right, so now we have logged into this application and this routing detection is also not affecting our device right here. Pretty amazing. Now let's see what we can do. Starting one activity gives us the opportunities to interact with the original activities because we are already in that sandbox context right now. So what do we have here? Okay, these are just those general options. Transfer. Let's see. From account. Okay, get accounts. Yes. Okay, this application seems to crash right now, I guess. Let's see. Yes. Let's check this really quick. Loghead. Okay. Do we have? Yes. I guess there wasn't crash. Let's see. Here we have a crash. Let's see if this is our crash. So let's scroll down. Transfer. Everything is working fine. Get accounts. Okay, I wait. Now get accounts. Yes. Get accounts crashes over here. The reason for this is if we log in, maybe we are having some kind of user context. And if you're now doing get accounts, this user context is not available and we might have a variable like null in there or stuff like this. Returning null when some string or some context is required might end up in this crash. So even if we can take or start this activity, we are not having a real advantage right now. Okay, let's try it once again and have a look at the other options. View statement. No, I do not see anything. Maybe we see something in the logcat. Oh, it's just logcat. View statement. Statement does not exist. Okay, maybe I have missed this part over here. So there's nothing in here. And change password. Okay. Here we can see we cannot select the username. This looks like a flaw. The change password option only provides a password field over here, new password. So we do not have to know the original password, which is absolutely bad. Unfortunately, right now we cannot select this username field, so we cannot provide which username or which password we want to change. But this might be something we could solve with those intents. So here we have this change password activity. We can see it on the title. Let's see what's inside there. So maybe we can start this change password. We can apply our intents, our username, and then we can change this password. So let's see if this generally would work. If this works, then we still have to find out what are valid usernames because admin is not available inside here. Okay, so let's see. Okay, do we have change password over here? Yes, here we have it. Here's the activity. So let's double click. And we can see this might be also something with some HTTP request. Okay, server IP, server port, get string. Yes. Okay, nice. Here we have it. We've got get intent. So if the change password activity is being called, we are having an intent. And this intent has some additional parameters, which is uname, which might be the username. And this username is a string. So we need to call this change password activity and we need to provide our intent, uname, with a string. And then this activity will open and we are having a username filled in here. All right. Okay, so let's open a new terminal. All right. adb shell am start activity -n. So our component name, our package name is this one over here. Okay, and the activity we want to start is this one. And now, whoops, without this. And now we need to provide this intent. Let me check really quick. Okay. Therefore, I have to take a look into the AM first. So let's see. How can we how can we provide this string in an intent? Over here, it's simply just extra key, extra string. Okay, we just need to use -e or -es for extra string. And then we can apply it. So let's keep this in foreground, make this a little bit larger. Okay. Now we're calling this change password activity and we want to provide uname and we want to provide, for example, admin. I mean, it's not working right now because we do not know a username, but this will start this activity here. Maybe that's, okay, no, that's not working this way. Oh, sorry for this. Okay, let's keep it in this way. Okay, this will start the change password activity and we are providing this username intent. How do we know that it's uname? Because within the activity itself, in the change password activity, we are having this get intent. So this is a keyword you definitely should look for if you reverse engineer activities or other stuff like services or broadcast receiver, that you check which data are being passed to this one and what happens with this data. Here we can see this is now the username, and this username set text, it's taking this username and inserting it here. And if we click on the button request change password task, it's being executed for this username. Okay, so here we can see post data. We are sending some network traffic. As already mentioned, we will analyze this in the man in the middle part. For now, we are just reverse engineering this. All right, let's see if this works. We could also go back, because this should work if we start this at the beginning. So can we simply click restart? Okay, now we are within the login. So let's open this one. Okay, we can see change password has extras. And there we go, nice. So now if we click change password, let's see, test. It won't work because there is no username admin, which we have already identified at the beginning. Entered password is not complex enough. Oh, that's also something we have to take care about. Let's see. The password things. Yeah, here's the password pattern. Okay, what do we need? Maybe digits. 620 special character. Oh, okay, we have to choose really complex passwords. Then let's do this. So test 1 2 3 4 exclamation mark. Does this work? No. What is missing? 6 to 20. Oh, there's no exclamation mark allowed. So then let's choose $. Okay, so nothing happens, but this is what we have expected. Maybe let's have a quick look at the server part. I mean, as an attacker, we do not have access to this one, but it will be interesting what's happening on this side. So let's see. Yes, we are getting error, and here we can see the password for the user admin, but we are getting an error. Yes, every time we click this, we are getting an error. So if we identify an invalid username, we could use this one over here maybe to change the password for this username, which is absolutely ridiculous, right? Yes, it is. But this is sometimes like the stuff works. I mean, this is now a network request, and we do not have to do this on the application side to call this with this parameter. Because after all this stuff, there is a network request which is being sent from this device to this device, and those information are being stored in this network request. So if we go into our man in the middle position, and if we fetch this network request, then we can modify those data, and we can simply perform this without having a mobile application. Already mentioned, we are doing this in the man in the middle part. Okay, nice. So this is how we can play around with those activities. I mean, you could also have a look into these, into this one. This is something we have already seen. I guess we have already seen all of them, yes. And some of them might work and some of them don't. Okay, so for this video right now, it's all. We will move on with the solution, of course, but I will separate them. In case if you are just interested in exploiting content providers or broadcast receiver, you can directly watch these separate parts, all right? So I'm looking forward to see you in the next video where we talk about content providers. Let's go. Okay, this is exactly the point where we did stop right now. And now let's have a look into the content provider. So what can we do with this one? Okay, let's close this. And then let's see. Content provider, this one over here. So we've got this track user content provider, and it has been exported to true, which means it's accessible from the outside world. This is our authority name, and I guess it's exactly the same, right? No. Oh, okay. It is the same. Yes. Okay, so let's have a look into this one. Okay, create table names, ID, integer primary key, auto increment. We've gotten table names and we've got fields. An ID, which is counting up. So maybe let's write this down. We've got an ID. That's the first row. Then we've got this name, which is the second row. Okay, good. Name, drawing with the mouse is a little bit hard, but yeah, this is our table. And the table is named names. Okay, this is our provider name. Perfect. And this is our complete database. All right, we already have all this information listed over here in these few lines. Now let's see, we've got matches. We've got track users and track users with a kind of regex. So, okay, this should work for both. We do not care about this one. And then let's see. We've got delete, get type, insert, on create query. So these are now all the things. We have this content resolver, which is asking to get access to this one, and these APIs will be returned back. Here's our cursor query. So this is our entry to this database entry. So we can do update, we can delete, we can do inserts and stuff like this. So it seems like we're having full control of this one. Yes, nice. Okay, then I would suggest, let's have a look what's stored inside there. Let's see. So ADB shell, and then let's put this on the right and this on the left. Okay, so we are having our content. Yes, let's make this a little smaller. Okay, and now we start with a simply query to see if there are already data in there. So let's see. Here we have it. Okay, ADB shell. That's not necessary right now, but then content query. Then we have to provide the URI, and the URI is the URL we have seen over here. So let's put this farther on the left. Okay, that's the URL. We want to fetch the information in track users. Okay, then let's see what's next. Okay, then we can define a projection and other things. But if we are not providing anything, I mean, we are just returning back the data which is being stored inside there. And that's good. So we can close this one, put this on the left, and then let's see. And we can see no results has been found because we have not logged into this application right now. Okay. Okay, so now's the point where we need some credentials, and I have planned it in this way to show you that it makes a huge difference if you test an application if you started from the beginning, or if you're testing an application which already has some content. In case of our activities, maybe you want to recap certain things if those features really does not work. Maybe there hasn't been some context inside this application, and this was the reason for all these error messages. Which means if we're having a customer application which is running on a real device and we have access to those activities content provider via our own application, then maybe we could read out or we could perform certain transactions. All right? Okay, so here we have learned it the hard way that if you test something, do it without content, but also do the exact same steps back again with some content. All right, the credentials for this application are shown here, and these can be used to log into this one right now. So therefore, let's do this. Okay, I mean, we are hackers, so therefore, let's do it this way. Input text Dinesh. So it's not capital D, it's lowercase d. And now input text, that's the password. Okay, let's hit login. Invalid credentials, interesting. So these are not the correct credentials. Then let's do it with check. Whoops, not here. Input text check. And here we're having check at $123. All right, this works. So not sure what's happening with these. Maybe they need to be activated or things like this, but we have to use check. Okay, I will rework my animation and only print the correct ones. So now we are logged in. So let's see, transfer from account. We simply hit get accounts. Okay, then we have the amount. Let's say we want to transfer 100. And let's see. Transfer successful. Okay. Do we have some view? I guess that's still the same interface. Okay, then let's go back. View statement. Message success from to amount. Okay, here we can see the transactions, and change password. Maybe let's also do it this one. Oh, we have to stay in the password policy. So I'm using input text test at $123. Yes, password successful, restart to perform this. Okay. And we can also see updated password from to. So we are receiving an SMS which contains our old password and also the new one, which sounds absolutely ridiculous, right? Yes, but that's how it is right now. So now let's click restart. Okay, and we also have autofill credentials. And then we can now hit login and invalid credentials, because that's interesting. The autofill credentials, it would be now pretty interesting if they are the old or the new settings. So let's see. Test at, oh, sorry. Let's do it this way. Login. Okay, so we can see the credentials has been changed, but it seems like that the credentials in the shared preferences are only updated after we have successfully logged in. So if we change the password, the autofill option doesn't work anymore because it contains the old password in there. Interesting design decision, but we are here for the content provider, so let's get back to them. Let's see, we simply hit the upper arrow key, and now let's see if there's something inside here. And there we go. We can see row 0 is named check, and row ID 1, row 1, ID 2 is also check. So this application logs every user that logs in to this app, which is amazing because we can fetch this and we can fetch these information from our external application, and then we can combine these to maybe change the password. Do you still remember the change password activity? Of course you do. Now we've got a username, and the attack vector would be the following. Our malicious app, this one over here, is using this content provider to retrieve the username out of this application. So now our app knows, okay, there is a username check inside here. And now our application can launch the change password, this change password intent with this username to maybe change the password of this user without having access to the original user credentials. Let's try this real quick. I mean, it's now related more to the activities, but this is done pretty quickly. Maybe we still have it here. No. So let's see, is it still open somewhere? Okay, here we still got it open. So now we are not using admin, we are using check. And to make this an invalid attack, let's reset everything. All right, so now let's open the change password with the intent check. Okay. And now let's see if we have changed the password. Ahead, and then we are using at $123. Change password successful. All right, and here we get the SMS. So now we know, okay, we can change the password if we just know the username. This would be an absolutely ridiculous flow. All right, we got this information from our content provider over here. And so here we have simply read out those information. Okay, so now let's try to hide our tracks. So let's say we are logging into this application. Whoops, we need to restart it first. So we are logging in at check with the password hacked at $123. Okay, now we could make a transfer to account So we are clicking get accounts to get the account of Jack, and we are now transferring it to this account. Was there already a success message? Yes, okay, here we have it now. Okay, so we've got now two logs. We've got the log regarding to the user login, and we've got this view statement. So to be absolutely rogue ninja, we have to manipulate both. But now we will only focus on this one right now, because yeah, this is the interaction with the content provider. Okay, so let's see, how can we delete our tracks? If we now query this once again, we want to delete this part here. And yeah, let's do this together right now. So let's make this a bit larger, and then content. So the help over here is absolutely amazing. So what we need is delete. We want to use content delete, then we're providing our URI, and then we have to use this bind with this binding. And this is a little bit complex, but there's also an example underneath. Yes, we do not have to use this bind. We could also simply use this where clause. Okay, so we are simply using this part. Let's copy this, and now we're just inserting the correct values. So we can make this a little bit larger. Okay. Once again, maybe let's fetch this information. Okay, so, and now we want to delete from the track users we want to delete where, and now the ID is equal 3. I'm not sure if we have to provide this in single quote in there, because that might be regarding to strings, but let's simply try this out. Okay, no error message. Let's see if this row has now been deleted. This one over here. Yes, perfect. So this is how we could hide those things regarding to this content provider. So we can delete entries, we can select, we can also insert entries. So maybe let's insert a new entry. Let's say Dinesh was the user which last logged into this application and had made this transfer. So let's see how this can be done. Okay, so content. And where do we have insert? Oh, here at the beginning, so that's why I missed it. You can navigate around with this one, usage. Here you can see insert, usage update, usage delete, usage query, usage call. Okay, so let's take this insert part. Let's see. Okay, we are taking this example, and then once again we are renaming it. Yes, here we are having this, which is a little bit more complex regarding to those bind things, but we can make this. Okay, so this is our old track, and now let's see. We want to use this content provider over here. And now we have to use this bind, and now we need to tell we need to tell what we need to add into this one. Okay, so we want to add a new entry into this table over here. And what we have to do is we have to insert a new row, and this row, the parameter we want to insert, has the name Dinesh. The first parameter, it's an auto increment, which means that it will be automatically being assigned to ID 3. This means we only have to provide the name we want to insert into this table right now. Okay? So this means we only need one bind. So the second one from the example can be deleted. Okay, and now the structure is relatively easy. First, we've got the column name. We can see the column name is name. Okay, perfect. Next, we've got s, which is the type and means string. And here we have now the string we want to insert. In this case, it's simply just Dinesh. All right, and this is how we can add Dinesh into this one over here. In case if we would have been multiple fields, then we would need to create multiple binds over here. All right? Okay, so let's see if this works. No error, that's good. And now let's see, track users. Okay, interesting. We can see Dinesh is being inserted over here, but that's not that rogue anymore, because Dinesh has now the ID 4. And this is the reason because 1, 2, and 3 got deleted, and now we have been assigned the value 4. So if we also want to be more rogue, we have to update this entry, which is also a pretty good exercise, because then we have done everything. Okay, so let's see. Content, how can we update this one? Insert update. So that's simple. Yeah, it's now the mixture of both, of inserting and deleting. All right, so let's take this example. And this one over here. And then we have recapped everything with our content providers. So we've got content update URI. And then we're taking this one. Okay, and now I clear the screen real quick, that we have it nice and cleanly. Okay, so we've got content URI, then we've got our database, then we've got now our bind, value, string, new value, okay? And then we've got our where statement. Okay, so this can be deleted. And now let's fill into this one. So our value, bind, value, string, new value. Okay, we want to update the name, the ID from type integer to 3, where the ID is equals 4. Okay, let's see. There's this one missing. Okay, no errors. Let's see if this has worked out. So let's query this once again. Yes, okay. There's now a little bit issue to the row, but we can see this entry has been updated. So within the log, we've got now ID 1, 2, and 3, and this one over here, that's the Nash. It's the user who has last logged into this one based on those IDs. All right. Okay, perfect. So this is how we can mess with this one around. Okay, so this is how we can delete entries, update entries, insert entries, or query entries within a content provider. There aren't that many more options, and I guess these are absolute sufficient enough to do this. Okay, so that's all from the content provider part. In the next video, we will have a look into broadcast receiver. So how to abuse this one to perform some amazing stuff. I will see you there. Okay, so we are still working on this mobile application, and we have already figured out quite a lot. Now, after activities and content providers, we want to have a look into the last component in this application, which is broadcast receiver. So we are only having 2 of them, where this one over here comes from some Google APIs where we do not want to have a look into. But this one over here, this has been developed or coded by the developer, and therefore there might be some flaws inside here. So let's see. It's being set to export a true, and we also got the Android name, the broadcast. So if you want to trigger this, we need to apply this action name over here. But first of all, let's have a look what's happening inside here. Okay. As already mentioned in the broadcast receiver part, if you want to analyze broadcast receiver, the only thing we have to look for is the onReceive method. This is the only part that can be triggered by us right now. And in this case, we're only having this onReceive method, which is performing all the stuff, which is amazing because we have full control over this method and all those parameters. Once again, we've got intent get string extra. So we're having 2 strings inside here, which means we've got a phone number and a new pass. All right, this sounds interesting. So here we can see if the phone number is not equal null, so if we're having a phone number, we are triggering this part, this code. Otherwise, we simply just get out of this one. Okay, this means we have to provide a phone number. The phone number, it hasn't to be a certain value. No. The phone number is irrelevant, okay, interesting, but we do not care about this phone number right now. Okay, so we can trigger this broadcast receiver, and this is taking two values, a phone number and new pass, okay. And now let's see what's happening here. If we provide a phone number, no big deal, we can do this. Then we are going into the shared preferences settings. So we are getting those, okay. We are going into the shared preferences. This username base64 byte string. So we are getting this username in this field, okay. Decrypt password, new crypto AES decrypt string, super secure password. Okay, we are fetching the decrypted password. So this part right now is going into the shared prefs and taking the username and also the password out into those two variables. Okay, let's see what happens next. Then we assign our phone number from here to here, which means this is now our phone number. And then we are having a message text, update password from, oh well. So here we can see this is the decrypted password which gets fetched from the shared preferences. So this is being returned back into this variable here. And this decrypted password is now being used in this message, text message, updated password from decrypted password. So this text message is doing something with the decrypted password, and it also claims that we are providing a new password, this one over here. Okay, and then, okay, now we are having the SMS manager, and the SMS manager is sending out this text message. Does it? System out print line for the change password. Okay. The ADB logcat is also being involved in this ridiculous function, but it doesn't print out any sensitive information beside the, what's the text phone number? What's this one? Okay, beside the phone number, okay, and the text message. Wow. So within the ADB logcat, if we change the password is being printed out into the logcat because we have this directly here. The decrypted password will be assigned to the text message, or it will be included in the text message. And here this text message is being printed out to the logcat. So this one is leaking the password in the logcat output. Okay, this is something I haven't looked into, but realizing right now by looking at this. Okay, amazing. And then SMS manager send text. Okay, then we are sending the text messages which contains the old password. But wait a minute. All right, interesting. This is why you shouldn't rely on names that has been provided by the developer. Do you recognize something interesting in here right now? What happens with the new pass? I will give you a moment to think about this. Okay, so we have seen we can trigger this broadcast receiver and we can provide a phone number and a new password. The application takes the information out of the shared preferences, the old password, in this part over here. Shared preferences, then we've got this, where is it, get string. Get string, here encrypted username and password. The username, by the way, is also not encrypted. We have already figured out that's just base64. Do not rely on those schemes. Okay, so it's taking out this information and it's placing them, at least the password, into an ADB logcat output and also within a text message sent via SMS. Okay, but the new password is not being touched anywhere. This means the password never gets updated in this whole construct, and then we are returning out. So if we trigger this broadcast receiver, the update process by the broadcast receiver, we are not updating the password. We've gotten information leakage, which is absolutely ridiculous because we can fetch the original password, which is also pretty fine, because if we are not updating it, then the old password still works, but we are not updating the password. This one here is not being used anywhere, only here within a text message string, but not within another function. We have seen that the update process works. So after applying a new password and resetting this application, we have to enter the new password. But this has been separated from the broadcast receiver. Okay? So the broadcast receiver is simply just a heavily information leakage if we can trigger this on our own. We cannot update the password, but we are still fine with this one because we fetch the old password. But yeah, this is why we shouldn't rely on labels like this one over here, this new pass label over here. We are not setting a new password, at least not here. It's being done, but not in the broadcast receiver. Okay, nevertheless, let's trigger this broadcast receiver because I would like to spam the smartphone full of SMS. We are also sending a lot of text messages. This could be a finding in itself. So we are providing a phone number. Yes, we are providing a phone number where we send this message to. Okay, now I realize this. We can provide the attacker phone number and send us the old password for this application. Oh yes, okay. Now I know how this works. Oh yes, this would be a pretty nice finding. So let's do this over here. Okay. What do we need to get? Within the Android manifest, we need to have the name of this broadcast receiver. It's this one. Okay, so let's see. ADB shell. And then once again, the activity manager. And here we have something like broadcast. Where do we have it? Here we have it. Broadcast. So we can send it to a specific user ID to only one application, or we can send this broadcast to every user application. In our case right now, I mean, as an attacker, we are lazy. So therefore, we simply send it to all. And then those applications can react to this one. So you can receive an onReceive method regarding to this broadcast event, and then you can also react to this event. But yeah, this has been already defined in our application we want to hack, therefore we're good to go. So yeah, that's all. We simply call broadcast. Default is, I guess, all. Yes, specified to send to all users, and then we have to apply our intents at the bottom. Let's do this. AM broadcast, then the package name, the component name. The component name is our package name. This one. And then let's see. I mean, I guess we do not have to provide a component name, to be honest, because this broadcast will be sent anyway to everything. But let's try this out both ways. I'm also not sure what's happening then. Okay, so we've got a component name, and then let's see. The name of this broadcast is this one over here. Okay. Okay, and now here we have to define the action. And the action is within the Android manifest. It's named the broadcast, okay? Yes, the action should be enough because that's the action that gets sent out to every application out there, and then these applications can react to this broadcast event. All right, but this doesn't hurt at all. But it also might work without having the package name. Okay, and now let's see, what do we have to provide? What intents do we need to deliver to this one? Intents, get string, we have a phone number and a new pass. Alrighty, so the phone number is in string, so we're using this one, extra key, string value. Okay, this is our string, and the value is, I guess we can add some quotes, but I guess this is also not required. So the phone number is, for example, 1337. Okay, that's the phone number of the attacker. I mean, the smartphone, I guess it's fetching all those SMS, even if it's not the original phone number. But yeah, it doesn't matter. And the other part was the new pass, which is not really relevant. Not relevant. To be sure that it is really not relevant. Let's select an one which also fits those requirements, that we do not get trouble with this one. All right, this is how we can trigger this broadcast. And now let's see if this works out. So can I put the smartphone? I guess I cannot keep it in foreground. Unfortunately not, so therefore let's put this on the left. Okay, so let's see. 3, 2, 1. Okay. I cannot see something in here right now. This might be all old SMS. So let's see if there's some SMS message regarding to this one. Messages. Yes, here we have it. That's the phone number. Okay, that's the phone number. So this is confusing me a little bit. We have to look up what SMS manager sent text message, if this is the phone number where it comes from or where it should send to. So maybe let's look this up real quick. Okay, now we've got send text message, and here we have it. Okay. Yes, okay. The assertion was correct. The first one is the destination address. And if you're not sure, you shouldn't make guesses if there are official documentations out there. So you can simply look it up, and that's the source address. Nevertheless, the emulator is receiving all messages because it's an emulator and you might want to test certain things. So therefore, this message would have been occurred at the attacker phone. And now we can see the update for this user over here. The password has been updated from hacked at $123 to work at $123. And now we know we have changed this password to hacked via our activity manager. So yes, we have changed this password, which is ridiculous. Now we have another way to interact with those passwords. But in this case, it might not be updated. We can verify this because we know the user to this password is check. So we need to figure out if works at $123 is now working with the user check. So therefore, we first need to restart this application to be sure that those changes has been updated. And then let's see, check, and let's see if the old password simply works. Okay, there's no history, so the old password is hacked at $123. If this works, then the password has not been updated. Yes, that's correct, because I need to insert text. Oh, sorry, it's input text, $123. I'm also a little bit excited right now, so let's see. Yes, okay, as expected, the password does not get updated. This finding is an information leakage. It's a pretty nice information leakage because you can define the phone number of the attacker to send the current password of the last logged in user, which sounds amazing. And yeah, this is how we can abuse this. We have seen this broadcast receiver is leaking the password. So it's not updating the password, but it's a pretty heavily information leakage because we can send this to any number we want to have. Nevertheless, even if we are not sending a password inside here, sending an SMS via a broadcast receiver, absolutely ridiculous, because we could send any phishing SMS or other stuff to other people from this smartphone over here. There could be also costs, of course, which occurs on the user side. So this whole example over here, I find this pretty amazing. And yeah, it's a little bit constructed regarding to this stuff, but you will definitely find things like this out there. Not exactly like this, but closely. For example, once I had an application which triggered a really important event via a broadcast receiver. So this broadcast receiver could be triggered by a malicious application, and then this event did some crazy stuff where the developer didn't thought about that also other people can trigger this broadcast receiver. Broadcast receiver is always worth taking a look into. All right, and this is how we can interact with them. Pretty easy, right? Okay, so that's all for those basic components. In the next video, we take a look into the crypto functionality. So we will have a look into those shared preferences and how we can easily decrypt this. And we will also try to hunt for hard-coded credentials, because this is something that can also occur, especially on IoT mobile applications. Alrighty? Okay, so I'm looking forward to see you in the next video. Welcome back to the last part of this video right now, and this is regarding to those login credentials. I mean, we have already figured out that things like Dinesh and check might not be stored in this mobile application because they are being used on the online side. Therefore, we do not have access to them. But nevertheless, I have often encountered some service accounts, operator accounts, which has some hard-coded credentials in an application, and they can be also used to interact with the web API or to manage certain things on this application over here. Okay, but before we go hunting for them, let's have a look into the shared preferences file and the encrypted credentials we have already seen in some code snippets over here. because even if this is not a finding, you will encounter this quite often, and it's nice to have a general approach on how to deal with things like this. And so therefore, let's have a look. Okay, so let's open this application. And we are logged in with the user check and the password hacked at $123, I guess. Okay, so we have seen these information might be stored in the shared preferences, and we can get access to those shared preferences if we're having root privileges. So if you're getting root privileges, we can see the device is not rooted, so this rooting detection is really not that good. Okay, that's good for us as an attacker. So let's see. Those shared preferences are stored in a protected directory, so the sandbox directory. We have talked about this in the application structure. So within data, com, Android, insecure bank. Let's see. Yes, here we have a lot of stuff. Databases. Let's see, do we have additional databases? No, I guess that's the only one which we have already seen in the content provider path. But now we're having this shared preferences. Shared prefs. Oh, we are still in the wrong, I'm still in the wrong directory. There we have it, shared prefs. Okay, let's clear this and then let's have a look. So now we've got my shared preferences, we've got insecure bank reference shared preferences, and we've got this web view Chromium Pref XML. So if we go back into this one, we have seen our first interaction with those shared preferences in the logging activity. And here we can see it's the file my shared preferences. This one is being used over here in this string. And this string, let's search for this one. No, it's not being used. Let's see. Okay, so this one is not being used, which is interesting. At least not here. And here we can see, here we're having my shared preferences. Is it the same string? Yes. Okay, maybe it's just a decompilation mistake that this string is normally being replaced with this variable, or the original code maybe really does not have a reference this string underneath, because they are identical. Yes, these are identical. Okay, maybe a decompilation error. Okay, but here we can see we are having this shared preferences file, and then we are getting those encrypted username and super secure password out of this file, which means this file should contain these two strings, encrypted username and super secure password, right? Absolutely. Let's see. My shared preferences XML. And there we go. Super secure password and encrypted username. And we can see there's a little bit of a mix up over here and also over here. But here we have now those values. We can see those equal sign at the end, and that's a good identifier to be base64 encoded. So we will encounter base64 encoding quite a lot during this course, and I will also keep explaining it more than once. The reason for this is you can skip certain videos, and then it's good to have those information. Okay, now's the question, how can we decrypt this password, this one over here? Because we want to have the plaintext value behind this, even if this wouldn't be in finding because it's within a secure environment and you need root privileges to read this out. So that's not a big deal. But let's say we want to understand how this is being decrypted, because then we can encrypt our own password and insert it over here, and we can simply override the login process with our password. So this would be also pretty nice. Okay, to do so we have to figure out what encryption is being used. So we have to go down the rabbit hole. So let's see, this password is being used over here. So it's being stored in password. Okay, then we've got if the password is not equal null, that's good. Then we are now in this part. Here we have the username, it's not encrypted, it's just base64 encoded. And the password appears over here, but that's not the password variable. The password is only being used in this field over here, in this line. Okay, and here we can see we are setting the text to crypto class, AES decrypt string, and then the password. So it seems like we're having an AES decrypted string function over here. But we do not know this. The developer can choose whatever he likes. We have to figure out if it's really AES decryption. Okay, so let's dive into this one. AES is a very common encryption algorithm, and I will provide you a bonus video where I go through all these important things you need to know about AES. So in case if you're not familiar with AES, have a look into this bonus video and then you might want to come back to this one over here. Alrighty? Okay, back to this one. So let's see if it's really AES. We are using this decrypted string function. So we have to take a look into this one. Okay, so here we are calling AES 256 decrypt. We are having an initialization vector maybe, we're having some keys and our base64 decoded string. Let's see where this function is. This function is over here. Okay, so now let's see. Yes, now we can be sure that we are definitely using an AES crypto function. Why? Because here we can see we are using Cypher get instance AES. And we can see the Cypher is not an own Cypher class. The Cypher is being used from JADX crypto Cypher. So that's the generic Cypher class from the Android system over here. This means we are using the method get instance, and if you are providing this parameter, we are using AES in Cypher blockchaining mode with padding. Okay, so now we know we are using AES CBC, which means we are having a key and we are also having an initialization vector. I will explain this in detail in the bonus video because I do not want to stretch this unnecessarily long right now. Okay, let's have a look where are those keys and where are those initialization vectors. So we are within this decrypt string function, and let's see. We are calling this function and we are providing the following parameters. This initialization vector get bytes, and also this one over here, this key. And then we are providing our, let's see, this is our base64 encoded string. Okay, nice. This means, let's have a look. This AES decrypt function is using initialization vector bytes as the first parameter and key, sorry, let's do not mess those colors up. Key as a second parameter, and this is our text bytes as the third parameter. So this is our text. This might be the key. Key, and this one over here is our initialization vector. To be 100% sure, we need to track these variables because the developer can also name them differently to do some obscurity. So security by obscurity. Okay, so here we can see these bytes are being used in algorithm parameter spec, IV spec. So here we can see if we look up this function, this is getting the initialization vector out of these bytes. All right, now we know this is definitely our initialization vector. This part over here. Okay, then let's see, key. Yes, here we are having secret key spec, and this secret key spec is returning the secret key, whoops, wrong color, as a byte array into this one. So this is our key. And last but not least, we've got this text bytes, Cypher do final, yes, that's the parameter where our crypto functionality takes place. So this is our string, our base64 encoded. So this one over here is our string, and this one over here, which has been fetched from the shared preferences. It's being inserted in a byte array, so we are inserting those raw bytes into this function over here. We have now everything together, and the easiest way to do an AES decrypt method right now is simply using Cyberchef. Cyberchef, it's an amazing tool to perform all this kind of tasks. And there's an online version, but also an offline version if you do not want to decrypt your secrets online, which is something I cannot recommend right now. So we take the offline version. Okay, to get the offline version, we simply have to go to the Cyberchef page, and this one over here. And then let's see, we can simply download it over here. So then we are having the web application running on our local system, and we can interact the same, but then we are not giving away those information. All right? Okay, so thanks for having also the opportunity to make this as easy as possible to do this locally. Really thank you, the whole Cyberchef crew. Okay, so let's see. Within downloads, we've got now, I've downloaded it twice. We simply extract this directory. That was not good. Oh, I hate when things like this happen. Let's get rid of this one. Okay. Cyberchef. Let's do it this way. Okay, then let's take it into our tools. Okay, and now let's extract it over here. Yes, of course. Now it's doing it this way. Yes, I know I have hit the wrong button before, but yeah, that's how it goes. All right, now we can simply use or start this HTML file, and the whole stuff is happening in the background via JavaScript. So we can use this offline. That's absolutely no problem. All right, so now let's do this, because that's pretty amazing how fast this goes. The first thing we need to do is we need to get those shared preferences string, the base64 encoded string, this one over here, but without this %. Okay, yes, that's the password. Okay, now we're having the input as a base64 string defined. The first thing we want to do, we want to decode it, because then we are having the raw bytes, and we can use those blocks on the left to simply drag and drop this in. So we say this one here is our input, and here we have now the output. And by dropping in the block from base64, we can see it's now being decoded. So that's the representation of this string over here. That's the base64 decoded string. And here we can see we have those dots where we do not know the real value behind this, because this is binary data and cannot be represented in this text form. This is why we have base64 encoded it. But our AES decrypt function works with raw bytes, therefore we need to decode it first. Okay, then we are using AES decrypt. And now we have to take care about a few things. Our input is not hex, our input is now raw. So we are now taking the base64 encoded string, we are decoding it, and we are feeding it into the next block, into this one here. So our input is raw bytes. We have seen this before over here. I also disable the autobake function, because then we are not getting 1000 errors that it could not decode the string with these parameters right now. Okay, now, I mean, if you want to stay to hex, then you could also use, where do we have it? Oh, we have to repeat it really quick. You could also do it in this way, of course. -n, okay. base64-d and then xxd-p. You could also insert those hex values, and then you could switch it to hex. But base64 is way easier. We do not have to convert anything first. All right, now we need to insert the key. The key, we have already seen the key as this one, this IV bytes. This one, this key, this one over here. And we can see this key is being referenced over here. This is the super secret key, okay. So this is our key, 1, 2, 3. Let's insert it here. And now the key is not in hex format, the key is UTF-8. So that's a basic string over here. Now we need to insert the initialization vector. So what's the initialization vector? This one over here. So it's simply just 16 times. Yes, okay. One thing we need to mention, this one is not a string, this is now a byte array. So we should also keep those types in mind. This means, I'm not sure, no, it wouldn't work if we provide those 16 zeros as a string, because a string, 0 in a string is a different value than a 0 in a byte array. Okay, so therefore we apply these as hex values, and this can be also easily done. Here we already have defined it to hex values, and now inserting 1 0 requires 2 zeros in hex. So this is 1 0 in hex. We can also see, maybe enable this real quick, invalid key length. Oh, that's interesting. Why is it invalid? Yes, so there was an error regarding to the key length, but the key length was probably fine. So by inserting 1 and removing it, we get the update that it's now correct. Maybe because I have disabled the autobake feature first. Okay, so now we can see invalid length got 1 byte. So here we can also see this one over here, 2 zeros, is simply just 1 byte, so 1 0. And we need to apply 16 of them. So let's copy this. 1, 2, 3, 4, 5, 6. I mean, we can also look at here until it matches, and suddenly our text appears. That's all we need to do. Amazing, right? The whole crypto stuff has been already implemented, and we simply reuse those functions. In case if you're not having CBC mode, we can also play around with these modes. ECB, for example, doesn't make any difference. CTR might. Yes, and CTR is the counter mode, so this is a complete different algorithms. Amazing. So now we also got this password over here. Okay, cool. This is how we can decrypt AES encrypted shared preferences file in under 2 minutes. The only thing we have to track down are those parameters. But I mean, if they are using those cryptographic functionalities, which every developer does, of course, because you do not have to reinvent those wheels, you can simply take those keywords, cipher init, do final, things like this, secret key spec. What else do we have? Cipher get instance. So if you're looking for those keywords in an application, then you easily identify all those AES encryption, decryption stuff. Alrighty? Okay, perfect. Last but not least, let's have a look, or let's go for a hunt on hard-coded user credentials. So we have to wait until the application has been decompiled over here. Okay, and what I would do right now is I would go down the rabbit hole regarding to all these login functionalities, because if you have a successful login, there need to be this comparison against a hard-coded credential. But we can also do it more easily, for example with user. And here we can see we want to skip everything which is Android support v4. And that's all. Case insensitive. Yes, this is what we want to have. Okay. Oh yes, we can see we've got a lot of pages over here. So yes. This is that's not a good option, but nevertheless we see it over here. Oh, that's interesting. Username, 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 and here we can see username equals dev admin. All right. Encrypted username. So we have to go down all those things. Sometimes they also do not, of course, compare it with things like user or password because they want to hide their tracks. Then I guess the best option is tracking down those logging functionalities, because there needs to be in comparison with those credentials, and there need to be in decision if these are correct or not. Okay, in this case right now we have identified this dev admin. And here we can see post data. So we are connecting, or we are contacting our web server at login and dev login. So we're having 2 logins, also interesting. By the way, this web server is running on this interface, which means if we go on 172.172.0.0 and then port 80, we can see the web server is also running on our local host. So this means if we go back, then we've got do logging the server port /login. Here we can see method is not allowed because we are making a GET request, but we need to have a POST request. So the thing that happens in the background, the mobile application is connecting to this web server over here and performs these tasks, which means this web server is of course publicly available. I mean, this hopefully not, but if you have a real world mobile application, this web server is publicly available. Then you can also, of course, fetch those network traffic and interact directly with the web application without having the mobile app. As already mentioned, we will do this in the man in the middle part. Okay, so let's go back. Now we've gotten another RP point, dev login. This is something we should take a look into. Okay, method also not allowed, so we need to provide post parameter. Let's see what's being sent. This one is HTTP post 2, okay? Do login, and if the username is equals dev admin for entity, then we perform our login. So there's no password inside here right now. Yes, so I cannot identify any password for this user right now. So can we simply log in with a username dev admin? Let's find this out. So let's open this one over here. Let's reset it. Okay. Dev admin. Let's see. I'm not providing any password, and nice. We are logged in. So this is a perfect example for hard-coded credentials. The developer might have used it for development and has forgotten to exclude them from the mobile application and also from the web server part. To be honest, I have encountered this 3 or 4 times within my last 8 or 9 years of mobile experience. So this doesn't happen often anymore. It depends on the type of application, I guess. But this is definitely something you should check out. If this works out, I mean, you got the pony under the Christmas tree. You got directly access to some developer functions or things like this. Okay. One last thing I would like to try out right now is if we restart, because this user might be admin. And within the activities, we have seen there was something really strange. And we've got this button, which might be visible depending if we are admin or not. And this is something I would like to try out real quick. So if we hit autofill credentials, yes, the dev admin appears, but there's no create user button. Nevertheless, the create user button has no functionality and it wouldn't work anyway, but I would like to try it out over here. Okay, so that's all for this challenge right now. I mean, there's a ton of other stuff which is included in there, and there might be additional vulnerabilities. In case if you have questions to any of them, then please drop a message into the comment section over here, and then yeah, I will get through this and answer them. Alrighty? Okay. So this challenge was absolutely perfect to recap everything we have learned so far. And if we recap what we have learned, I mean, this is already amazing, right? We can handle activities, content providers, broadcast receivers. We've got knowledge about cryptography already. We did identify hard-coded credentials and even more. But don't worry, we are not even being close to our final form. So we've got tons of other stuff which we go through during this course over here. There are some 2 really huge chapters, which is Smiley and Frida. Within Smiley, you will become an absolutely Android ninja, and Frida, it's the bad boy on top of it. So if you go through this course together with me, the whole course, then after absorbing this course, you will be definitely within the top 5 of your company regarding to Android application pen testing. I'm pretty sure about this one. Regarding to mobile penetration testing, Smiley is an ability that not many people have out there. So reading and writing Smiley it's not very common. And within the next chapter, you will see what we can do with Smiley. So Smiley gives us unlimited power in hacking mobile applications. Even if there are some really hardcore routing detections, we do not care about them. So with the Smiley, we can do whatever we want, and there are not many things that can stop us right now. Alrighty? Okay. So therefore, I'm really looking forward to see you in the next chapter, because this chapter has been mentioned to reading and writing Smiley. So we will learn Smiley in the next couple of, I guess, 45 videos. Alrighty? I'm looking forward to see you there. Welcome back, friends. Let's do a quick recap. For all of you who directly jump into this, let's figure out what we have done so far. We've got our SpacePing application, and we can download this from the official F-Droid store, but I also provide you a link over here that we all are using the same version. We have installed this application and we have made ourselves familiar with this. So if you haven't done this, please go install this application and have some fun while playing this. It's of course also necessary that we are making ourselves familiar with this game because we want to hack it afterwards. And having fun is definitely not forbidden in this course. Alright? Okay. So, after playing this game for a while, we did start decompiling it. So we figured out how to unzip an application, where are the difference between unzipping and the APK tool, and things like this. Then we made ourselves familiar with different reverse engineering techniques. We looked at Dex2Char, JADX, and also AndroGuard. And we also got a little challenge about identifying key components in this application. So now we know where are those player lives, where's our high score, where's this double shot, and where's this player shield, for example. We also got a challenge on modifying this application, but only on the resource part. So we changed the resource, this layout in this application, and built this application back again. Then we did take a look at signing an application, and this one might be important for you because the signing process has been changed on the Android 11 platform. Therefore, you might want to take a look at the signing approach. After signing this application, we did install our modified version, and there we could prove how those resources have been changed. So I added some fireballs, at least we call this fireballs. I'm not sure what this really was about, but yeah, some fireballs and also the player icon a little bit. You also did some amazing job on this, and yeah, congratulations once again to your first Android app hack over there. Alright, and this is now the point we are in right now. So changing the resources of this application was pretty easy because we can simply swap those pictures. But now we want to change the Java source code, and this is where Smali kicks in right now. In this chapter we learn how to modify this application by modifying or patching the Smali code. We also learned that we cannot simply adjust our Java source code and compile a new classes.dex file out of this. I guess we got about 6,000 errors, which has to be fixed first, and this is absolutely ridiculous if you try this. So therefore we are going to patch this on the Smali level. This is way more easier than you might think. What we do afterwards is we are going to change the player shield, for example. The player starts with this shield and the player is from this point on immortal. So the player cannot get hit or being destroyed by having this shield. We also do a lot of other amazing stuff. We patch routing detections, certificate pinning. We also learn on add new code into this application and things like this. So this is our base we are working on right now. We are now all on the same level. If you haven't downloaded this application, please do this. I have attached this in the section. And in the next video, we will make our first experience with Smali. I'm super excited about this and I'm looking forward to see you there. Welcome back. I'm super excited because now we are going to learn Smali, and we do this by hacking this mobile app game, the SpacePing application. Before, we are going to create little pieces of Android applications that serve a special task. For example, that helps us learning what are registers, what are type definitions, what values are in there, how does a function call look like, what are those parameters, return values and objects. So this is a little bit overwhelming if we do this all at once. Therefore we do this step by step, creating our own Android applications that are pretty simple and basic and where we know what the source code is like, and then we will figure out how the Smali code looks like. We are not going to start with a Hello World application because I never did understand the reason about an Hello World application. Most of the time there's already some stuff included there. We've got a string which consists of chars, which is an array. We've got a function call, parameters and things like this. We start with a little basic program that only consists one integer value, and this value is responsible for the player power. Then we figure out how all the stuff looks like, and in the next step we try to adjust this value to increase or decrease this player power. Alright, let's go. Let's switch to our Ubuntu VM and we are going to create our first Android application. Alright, here we are now at our Ubuntu VM. Let's write our first Android application. So we go into Tools, Android Studio, bin, and then we've got this studio.sh script, and we simply run this. And here we've got the entry point of the Android Studio. So don't worry, you do not need to know anything about Android app development. We are not going to write fancy, animated, complex layouted applications. We are just simply putting our Java code into this application and hit the compile button. That's all. Okay, let's create a new project. Here we've got our first overwhelming window. What do we have to choose right here? Well, we use the empty activity. We know what an activity is. It's simply a screen content. And you can select here between different screen contents. For example, if you want to have Google Maps included or a full screen activity or things like this. But all the other activities make this layout or the code more complex. Therefore, we stick to the empty activity. We can also choose no activity, but then we do not have this graphical output. So we stick to empty activity. That's good to go. Now we have to name our application, and I named this Smali1. Here we can see this package name. It's going to be automatically adjusted. Within language, we stay to Java and not Kotlin. Java is way more easier to handle this. And this one is important, minimum SDK. This means how backwards compatible your application should be. In our case, I guess our virtual machine is running Android 9 or 10, so we would have at least chosen this one. In my case, I choose back to Marshmallow, Android 6. You can also go further back. So for example, 4.4 is also no problem. Or 2.3 is not included right here, but 4.4 is working. By the way, if you're using your own device, then please make sure that you include at least your version of your own device over there. Otherwise, this application might not run on this device. Okay, then we hit the finish button. Now we get the main layout, and this might take a while. We can observe this at the bottom. Now it's indexing. Afterwards, there's a Gradle build happening, and yeah, we will come back after all the things has been finished. What do we have right here? Well, this is our famous Hello World application that is overwhelming, complex, and we do not understand anything about this, and we also do not have to do this. But nevertheless, I give you a short introduction. So here we have our main activity, and this activity extends this activity class. We do not care about this one. Then we've got this onCreate method, and this one is important because an activity has a kind of life cycle. So if you put your application in the background, then there's this onPause method that gets called. And if you get back your activity to the foreground, then there's this onResume method called in this activity stack. In our case, we've got this onCreate method, and this means if the application is going to be created, this method is going to be called. And this is definitely the case if we start this application and this activity appears on the screen. Therefore, we can treat this as our main function. So do not care about this onCreate and override stuff over there. We will take a look into this later on. Not in this chapter, but within the runtime analysis where we take a look at the activity stack. But for now on, let's just say this is our main function. And we do not care about this one, and also the parameter over there. We just put into our code over here if we want to run this code. Okay, that's all we need to know. On the left, we've got the structure of this application. So we've got the Android manifest XML, this one. And if you take a look into this, we can see, okay, no permissions. We can see our activity, this main activity over here, and we can see this well-known intent filter, which means this is our launcher activity. This is our entry point of this application. All right. Then we've got this resource directory over here. We are also pretty familiar with this one. And here, by the way, is this values directory that contains, for example, those colors which are regarding to our theme we are using. And those values gets compiled into this resources.arsc. Just here to wrap this up from the Android structure part. Okay, we also do not care about this one. We could now build and run this application because this is an application that's already finished. We can now simply hit the build button and we can create our first application without inserting any line of code because this is our blueprint of our Android application. To do this, we could say build bundle, build APK. And this might take a while on the first time because then all those things get compiled into this APK. And if we make a modification, then the compiler relies on some cache and this will be a lot faster. In my case, I've got this now over here, build APK generated successful. And if I click locate, we've got our first build over here. So we have built an APK without doing anything, which is super great, right? Okay, so now let's go back to our real approach. We want to learn Smally and therefore we have to do this step by step. And we start with our own Hello World program, which is an integer value. Okay, let me close this over here. All right. Now we go into this one and we create a new class. This makes this afterwards a little bit easier. We name this class, for example, player. And here we define a new value. We say int power equals 10. All right, that's all. We do nothing more. We just do this one. Now we hit build, make project. Gradle build is running. Okay, looks fine. Now we hit build bundles, build APK. You can always hit build bundle APK directly. You do not have to use make project first. Okay, now we go into this location and here we have our APK. Let's go with the Smally approach. To get these Smally classes, we have to decompile this application and we use the APK tool for this. So we stay in the same directory, right click, open a new terminal. And then we say APK tool, the app debug APK. This has been finished. We go into app debug and now we've got the Smally directory. Let's have a look into this now more in detail. We've got Android, Android X and COM. These two are regarding to the Android application build system itself. So if we go back, We cannot see them over here. And also not there, but these gets compiled into this application based on, But these get compiled into this application based on the things we are using. For example, we extend a class over here, and therefore we also need the code for this class. We do not care about them. We are just interested in the package com, app hacking, smiley, and then the player class. Let's see. We've got this directory com. And this one contains now app hacking and Google. So we stick to app hacking, smiley1. And here we have now all those smiley classes. Let's see if we can see our player class. Here's our player class over here. Nice. Let's open this file and have a look into our hello world smiley exercise over there. Okay, you can choose between the code editor, gedit or Vim. In my case, I'm using the code editor. So we can simply drag and drop this over here, I guess. Yes. And there's no smiley highlight over there, but we can use the Java highlight. That's well enough to get a little bit about this. Okay, before we analyze the smiley code, let me show you some neat tricks over there. So if we go back to the directory, we can also use JADX GUI. And we provide this app debug APK. And if we go into com, app hacking smiley1 player, we will find the smiley button underneath this. And if we hit this, we directly compile our code into smiley. So we do not have to use the APK tool to decompile this. But there's a difference. Let me show this to you. Let's put them side by side. So this is regarding to the decompiler, and those are different, and therefore we also get a different bytecode output. Both are, of course, this is regarding to the decompiler. The APK tool is using a different decompiler than JADX, and therefore we also get a different bytecode. Both outputs are, of course, valid. In my case, I like to stick to the APK tool output because this is a little bit more easier to read. I give you the solution about this one. Register means that the compiler named here that we've got two registers, and we can see them over here. We've got V0 and we also got P0. In this case, it only says we've got one local register, which is V0, and P0 is a parameter. So we provide a parameter at this point. The APK tool makes a difference between local registers and parameter registers, and on the right side, these get matched together under the whole topic registers. This might be a little bit confusing at the beginning. I'm absolutely understanding this, but I just wanted to show you that you get different outputs if you use different tools. We will stick to the APK tool output because this is a little bit more precise regarding to the naming of those. Okay? These outputs are different, but the result is the same. So both apps work in the exact same way. Last but not least, there's also a plugin for the Android Studio itself. So we do not need to compile this application with the Android Studio and decompile it afterwards with the APK tool. We can directly do this within Android Studio. To install this plugin, we go to File, Settings, Plugins, and then please make sure you have selected the marketplace over here. And then we search for Java to Smiley, this one. And then we hit Install. Please read carefully through the terms and conditions about this. And if you accept them, we can install it. And we click OK. Okay, now the plugin has been included into this IDE and we can use this. Sometimes you also have to restart Android Studio that this effect takes place. Okay, we click onto our player class over here and then we go to Build. And at the end we have now this button Compile to Smiley. Let's hit this. This takes a while. We can observe this at the bottom of this page. And after it's finished, we get a new tab over there. All right, and here we have now the decompiled Smiley code out of this Java class. We can see it's also using this approach like JADX does with the register part. So we do not split them up between parameters and local variables. We summarize them and put them into the register word. In my case, I do not like this approach very much because having the ability to separate them between Local variables and parameters make Smiley even more easier. Therefore, I like to stick to the APK tool approach. But if you have to do a fast task, then this can come super handy. You can write your code over here, and then you can simply hit this button and you directly get out your Smiley code over there. Alright, now let's analyze our first output of our Hello World application. So this Smiley output right here. We are going to analyze this on the slides. So I take this output, put it on a slide, and then we go through this. Let's switch back and have a look into this. Okay, let's do a quick recap on this. So we've got our application. We did insert a new class and we added this variable named power. We compiled our application and this was our starting point. Afterwards, we did decompile this application with the APK tool. And then we did end up with the Smiley structure. And the Smiley structure contains single directories, and these single directories are regarding to the package of this class name. So if we compare them against each other, we can see the com app hacking smiley1 is exactly the same package name over there. This is how our Smiley structure looks like, and therefore we can find this player.smiley class immediately. Okay, this is what we've got. Now let's take an analysis on our Smiley code. On the left we've got the player.smiley and on the right we've got the player.java. So the player.java looked like this. We've got our class int power. On the left we have the decompiled Smiley part. Now let's see what can we understand right now, and I will be absolutely honest with you. If I do mark anything that we do not understand right now, then please drop me a message underneath this box, alright? Okay, what do we have here? Well, let's take a look. Well, okay. No, that's also. Yeah, okay, I've got it. Can you spot this? Can you spot the value 10 maybe on the left side? But maybe if we strongly concentrate ourselves onto the player.java file, maybe we are able to identify the value 10 on the left side. So I give you a moment to think about this. Well, let's see. The value 10, it's definitely not there in this decimal value. Let's think about what we've got on the left side. We've got a bunch of really strange words. We do not understand this, but we've got an 0xa. And 0x, this might be hex. I don't know. Let's see. If we're using a Python shell, we can represent this value 10 in form of an hex value. So we open a new Python terminal and we type in hex 10. And then we get this 0xa. And the 0xa is also on the left side over there. So this might be our value 10. We do not know this right now, but it's pretty likely the case. Alright? Nice. We have understand our first part within Smiley. Okay, so this is a huge step. And by having this step, we also can do a lot of stuff right now, even if we do not understand all the rest of this. You will see this in a moment when we do our first exercise. But for now, I would like to finish this video because I do not want to stick that much together in this. We have taken a look on different approaches how we can get the Smiley code out of this application. We have seen some really fast techniques, for example JADX GUI, the Smiley button, and also if we want to write our own Smiley code, we can do this directly in the Android Studio. We write our Java code and then we use the Java to Smiley plugin. We've also taken a look into the difference of the decompiler regarding to the Smiley output. So we have seen some decompiler summarize those registers to one big blob, and others split them up between parameters and local variables. Then we have analyzed our first Smiley code and we realized we cannot understand anything about this, but we might have found the integer value represented in the Smiley code. And this is a huge deal. Okay, and this is also the point we stop right now. We do this step by step and we will increase our steppings further and further. For now, that's all. I'm looking forward to see you in the next video. Welcome back. I put on my training shirt and you might have realized in the real world I might be practicing not that much, but in the Android world I would be at least a Hulk, I would assume, at least. So now we are going to patch this application and I'm feeling pretty confident in my Hulk form that we are able to do this. We did not understand anything about the Smiley part, but let's figure out what we've got. Therefore, we need to switch to the Ubuntu VM and we also need to verify that the value 0xa is our corresponding player power. Let's open Android Studio. We go into Tools, Android Studio, bin, bash studio.sh. Whoops, there's an O missing. Okay, here we are now at our player class and we can see our power level is equals 10. Let's open the corresponding Smiley code to this. So we would have assumed that this 0xa is our player value, our player power. How can we verify this behavior? Do you have an idea? Please think about this for a moment. Alrighty, I'm pretty sure you got the solution. We simply go into our player studio code over here, and then we switch this value or change this value from 10 to 12, for example. Then we save this and we create our new APK. Afterwards, we check the Smiley code once again and see if this value has been changed. That's it. We can now also use JADX GUI because, yeah, the APK tool output is, in my case, much more easier to read, but regarding to comparing a single value, both outputs will be the same. So therefore, let's have a look into this. We click on Locate. Then we open a new terminal and we say JADX GUI app debug.apk. Then we go into our player class. We hit the Smiley button and we can see, yes, the value has been changed from 0xa to 0xc. Let's have a look. Python 3 0xc. This is the value 12. All right. We now know where our player value is. This one over here. This is our player power. Before we are patching this, let's make some sort of visual output, because otherwise we do not see if our player power has been increased. So therefore we go back into our Android Studio code. We go into the main activity class and we have to create a new instance over there. So we say player equals new player. Now we can access this player power field and we print this out in the system console output. Therefore we use system out print line and then we have to adjust this to add a string over here. So we call this player power equals, and then we concatenate this value. I know this player.power is an integer value, but it's working in this way. So we can concatenate the string with this integer value over there. Okay, now let's build this application back again. This time it's a lot more faster. We click on Locate. We click Open in a new terminal and we make our ADB connection to our virtual machine. Now we can install this application. In case if you get an error message over here regarding to test devices or things like this, then we have to adjust these -t parameter, this one over here. Otherwise, please have a look into the cheat sheet I have provided you. I've inserted there all ADB errors I've encountered so far. And if there's a new error, then please write me a message. I try to figure out what's the root cause and also provide an update to all members about this. Okay, now let's get back to the screen. So we get our screen here and we open this one. We can see this is our first built application. It's an Hello World application, but we didn't do anything about this Hello World part. It's a text field that's already inserted over there. And within the ADB logcat output, ADB logcat, we can now grab for player power. Nice, we can see our player power equals 12 over there. If we want to add this value or change this value right now, we have to do this process once again. And I show you a more easy approach within the Android Studio. Okay. To connect Android Studio via ADB to this virtual machine, we have to create a new configuration file over here. That's not that hard. We simply go on to Run, then we go into Edit Configurations, we opening up this templates and we click on Remote. Then we have to insert our IP address and port over there. Let's figure this out real quick. ADB Connect, this is the IP address of this virtual machine. And the port is 5555. This is the default ADB port. and that's all. If we click on apply, okay, then we can uninstall this application first and then verify if our configuration is working. So we hit uninstall, adb uninstall, app hacking smali1. In case you have chosen a different package name, you can find this over here in the Android manifest XML, this one. So this application has been successfully uninstalled. Let's verify this. Yes, it's not available anymore. Now let's keep this in foreground that we can see this effect. We click now on Run App. And if we do not have a device attached or a virtual device already started, it's automatically choosing this connection. And we can see it's directly opening over here. And we also have this logcat output over there. Nice. This is a little bit more faster. If you do this a lot, so changing, experimenting around this, this might be more handy to use. Okay. We can also search in this one for player power, and we can see, yes, we've got this 2 times over here. This one is the old version, and this one, or old version, this is the old application, and this one is a new application. We can see this on the timestamps. Nice. Okay, let's do a quick recap. We definitely know that this one over here is our player power. We do not know what this one is, or this one, this one, this one, this one, this one. We do not know anything in this file beside this value over here. We know this is our player value. In this case, it's now 0xc because we have changed this value. We also added some sort of visual output. And now we are ready to patch this application. We do this in a short moment. Before, let's do a quick recap on all these steps in a graphical way on our slides. And afterwards, we increase our player power and make it over 9,000. All right? Let's go. Let's switch back to the slides first. Okay, while switching back to the slides, I came up with a different approach or solution for this. Let's make this as an own challenge. I guide you through this whole approach how we patch in Smali application, and afterwards you can try it on yourself. I throw you definitely in the cold water and I do not expect this to work right now. Okay, so I've got no expectation that you can already do this. But I guess you will learn more by doing this in this way. We discuss the solution of course afterwards, and if you struggle or cannot patch this right now, this is absolutely no problem. As already mentioned, pure cold water. We've got our game application and this only consists of this output of the player power. So we do not have, or we assume we do not have the source code because we are hackers and normally you do not have the source code. Therefore we take this APK and we put it into our apps directory, and this is our base we are working on. We've got a random application pulled from the device and we want to patch this. Okay? Okay, so we've got our game application, and the first thing we need to do is we need to get those Smali files out of this application. We can do this with the APK tool. So we use the APK tool D command to decompile or decode this application and get back our Smali codes. Then we need to go into the player Smali class, and we can find this by looking at the package name. So you can also use JADX to take a look at the source code and navigate a little bit more easier around this. We've also discussed this point in the previous section, so maybe you want to rewatch or rewind this one if you do not remember this anymore. Okay, by looking at the player.smali class, we do not know anything about the syntax over here, but we have identified our 0x8 value, which is the corresponding player power. We want to increase our player power to be over 9,000. Therefore, opening up in Python terminal and figure out which value is over 9,000. And then take this hex value and replace it at this point. So the only requirement to this one is that the player power is over 9,000. That's the only requirement. Okay? Alrighty. Afterwards, we need to build back this application. So we use the APK tool B command to get our modified version. Then we have to sign this application, and we use the zip-align APK signer approach in case if we have to deal with Android 11 applications in the future. After signing this application, we can then use the adb install command to check this out. And after installing this application, we take a look at the adb logcat. And after installing this application, we take a look into the adb logcat, and then we will see if our player power is over 9,000 or not. And in case this is, then well, congratulations, you have done your first Smali patch, and this is an amazing feeling. Alrighty guys, I'm super excited how good this is going, and don't worry if you cannot do this right now. It's an experiment from my side if we are already at this level right now. If this is not the case, don't worry. We start at 0 and I will guide you through until we reach our hero class afterwards, that we become a super smiley ninja. Alright, now let's try this and afterwards we discuss the solution about this. Let's go! Hey guys, how you doing? If the answer is not that good, then don't worry. At least I wanted you to try to solve this challenge. Because by trying it, you will figure out what's unclear right now and you will learn more afterwards. This challenge was originally planned way later, so we would have learned a lot of more before we would face this challenge. So I do not have the expectation that you can already solve this right now. In case if you did, well, great. This is super amazing, really. This is really great. And if not, then let's have a look together. Let's check out how we can patch this application and increase our power level to over 9000. Okay, let's go. You might have noticed I pulled out my black hoodie, so you definitely know now it's hacking time. Let's hack this application. Before we can do this, we need the APK. So how can we get this APK? There are two possible ways. The first one is we are opening Android Studio once again. So we go into Tools, Android Studio, bin, and we run the IDE script. Okay, here we have now our IDE. To get this application, we can simply build it once again. So we go into Build, Build APK, and we hit this button. Then within the event log, we can find out when this build process has been finished, and we get also this notification where this window pops up after the build process has been finished. Okay, we can see it over here. So we can simply click Locate, and in case you did accidentally close this window, we can also check the event log, and here we can also click the Locate button to locate our APK, to get into this folder, this directory where this APK is stored. Here we go. Now we copy paste this one and we create a new directory within our apps, and we name this challenge smiley 1. Okay. The other way to get this file is we can get this directly from the Android Studio project. So within your home directory, if you have created this project, you can find them over here, Android Studio projects. In my case, I've got 2 additional projects. These are regarding 2 older challenges, and this one we have created together. So you should have something like Smiley1 or the name that you have provided over there. Then we can go into App, Build, Output, APK, Debug, and then we have this app over here. This is the same directory that gets opened when we click on Locate. Alrighty, this directory is super hidden, I know, and you have to find your way through this. You can also go into this one and search for APK. I have done this at the beginning when I learned how to write Android applications, because I never find this application in this directory over there. Alrighty, now we can close this one and this one and this one also. Okay, after cleaning up the desktop, let's go into the apps directory. Apps and then challenge smiley 1. So here's our APK, and we assume we do not have access to the source code because we are hackers and we do not have access to the source code normally. And we have pulled this APK from the device. Let's have a look into JADX, how this looks like. We open a new terminal, JADX GUI, and then we open this APK. Okay, our task is to increase the player power. Now we need to identify this value first within the source code. We can browse through those few packages, or we can hit the search button if this application will be larger in the future. So by clicking this, the application needs to be decompiled and indexed, so this might take a while, but then we can search for power. And here we get a bunch of output, because we can see this power is included in Android App Compat, in power management and all other kind of keywords. If we scroll down to the bottom of this page, we can see int power 12. So now we have identified this is our power level we want to increase. Alright, let's pull out the Android virtual machine and see how this application works. In our case, we know this is a super basic application, but let's try and see if it's still working. So we use screen copy. And ADB is not connected right now, so we connect it first and then we use screen copy once again. Alright, here we've got our Smiley 1 application. If we hit this button, then we can see our hello world appears in the middle, right over there. And within the logcat, we should get our player output. adb logcat, we grab for, we can find this also over here. Oh, not here. Within the usage of main activity, player power. All right, we can see we've got our player power 12. This is our normal value, and this one needs to be increased right now. Nice, everything is working so far, okay. If we want to change this value, we need to decompile this application. We need to change the smiley part, because this classes.dex file gets compiled or decompiled in those smiley files, and those smiley files can be recompiled into those classes.dex files. We cannot adjust this value over here in our Java code, so we cannot simply start writing this new value over there. We would have to include this whole project, and this means also those resources, layouts, and stuff like this. We've got an exercise where we have done this in some videos ago, and I guess we did end up with about 6,000 errors, so this would be ridiculous if we try to fix this. Therefore, we have to patch this in Smiley. All right. Oh, we keep this open because this can come handy later on. So let me minimize all of these windows. Okay, we open a new one over here, and then we use the APK tool. We say D for decode, or I say decompile, and then let's get out those smiley files. Alrighty, within this app directory we have the smiley structure over here. Where is now our player.smiley file? Well, we check this with JADX GUI once again. We can close this one, and here we can say this player class is within the directory com, AppHacking, smiley1. So we go to com, I keep this in foreground, AppHacking, smiley1. And here we've got this player.smiley file. Nice. So this file contains this Java source code over here. Let's open this in an editor. You can choose whatever you like. You can use a gedit, Vim, or in my case, I use Visual Studio Code over there because the syntax highlighting is pretty neat. So I keep this in foreground and I drag and drop this over here. And then we can also adjust the syntax highlighting. At the bottom, we choose Java. Yeah, it's not Java code, it's Smiley code, but the Java syntax highlighting works pretty well. There's also a Smiley plugin, a Smiley syntax highlight plugin, but I would like to stick to the Java because I do not like installing these many random plugins. Okay, in the last video, we've also figured out this one is our value. We want to patch this one, this value 12 right now. And the only requirement is that this value needs to be over 9,000. Therefore, let's choose a value over 9,000. We go into our Python editor. You can, of course, choose whatever you like. You can also do it in your head if you can calculate hex values this way. And let's see, I choose 9001 because, I'm lazy, I'm a hacker, and this would meet the requirements. Okay, this one is this value, 2329. Let's copy paste this over. We do not know anything in this file. We do not know what V0 is, P0, or the other stuff. We just replace some values. Of course, this would be a bad approach, but we will learn Smiley afterwards in the correct way. I just wanted to show you that Smiley is not that hard, at least for those tasks. Alrighty, we save this file. We close this editor over here. We can also close this one. And now we need to go back to this one. And this is our application which needs to be built back again. If we now build this back with the APK tool, those Smiley files get recompiled in those classes.dex file, which is our Java code afterwards. And by changing the Smiley file, we can also take our change into this classes.dex file. And this should take effect. Let's see. We open a new terminal. I guess there are, meanwhile 10 terminals opened, but we do not care about this one. So APK tool, B for build, and then we choose app debug. We can see those Smiley files or folders gets compiled into this classes.dex over there. Alrighty, we've got our APK. We've got this in dist, this one over here. Now we need to sign and install this. So we go into dist, And now we zip align this first and yeah, use the APK signer afterwards, because we want to also meet the requirements for Android 11 applications in the future. If we have to deal with them, this is the best approach to sign this application. So zip align -v for and this one. And we name this out APK. Verification successful. We've got now our zip alignment on this APK. If you have skipped the signing part, you might want to rewatch this. Because in this video I will explain why we use zip align first and then the APK signer, and where the difference and problems are regarding to an Android 11 application. Okay, now we want to sign this application with the APK signer. So we say APK signer, sign, and then key store alias or key alias. Let's check this out. I'm going to open this help. Key store key alias this way. I always forget this parameter. And then I guess dash dash key. Ah yeah, okay, those two. All right. So APK signer, assign this one, and we have an alias name. And then we use key store and also our key store over here. And our APK, of course. My password was changed. Yes. Okay, now the application has been successfully signed. Let's uninstall the original application first, because if we try to do this, we might end up with the wrong certificate errors. So therefore we use adb uninstall, then com app hacking smally1. You can find this package name also in the Android manifest XML within JADX GUI, for example. If we go into resources, Android manifest XML at the end, com app hacking smally1. I'm not sure if you have chosen the same name. In case you didn't, then you have of course to use your own package name. Yes, I guess now we can close this. Okay, let's verify that the application has been uninstalled. It's still open, which is pretty crazy behavior in my opinion. We also got our SpacePang application still open. Let's close them. Okay, it's not available anymore. We keep this in foreground, and now let's install this and see if we have a new power level. Yes, this one. adb logcat. Whoops. And we grab for power. Oh. ADB. I also choose the -e parameter in grep because this means case insensitive. So if the power would have been written all lower cases, then we will miss it if we do not provide this parameter. And yeah. So now we see we can also get this power management output, and this one is regarding to the old version. So let's opening this smally1 and let's see. Alrighty, we can see we have a new power level. We are now on the power level over 9000. So this effect has taken place, and this is super ridiculous amazing. You can do a lot of stuff with this, and maybe we take a look into the SpacePang application directly afterwards. Let's check. And maybe we take a look at the SpacePang application afterwards and increase the player lives immediately. And then we will start learning Smally. We will figure out what is this V0, what is P0, what is iGetObject, what is move result, and all this stuff. Alrighty? Okay. So in case if this worked for you, super nice. If you have any questions regarding to this patching process, then write me a message. I'm glad if I can help you out on this. And otherwise, I will see you in the next video. Welcome back, guys. In this video, we start learning Smally, and we do this step by step, and we start with a really important component, maybe the most important component. And if we have understand this one, then the rest will be also not that hard anymore. All right? Okay, let's go. Let's have a look at registers in Smally. So I pulled out my graphic tablet and we make some fancy drawings to explain this. Alright, before we dive too deep into this register topic, let's first have a look at a very basic function. Based on this, we analyze how the CPU is handling those those single instructions. And then we will figure out how registers work in Smali. Alrighty? Okay. And so let's say we've got the following function. We've got public, a function that returns an integer value. And this function takes two parameters and add them together. So we name this add power. And here we have our two parameters, int a and int b. And this function also has a local variable named sum. And this one is being initialized with 0. And then we have the sum, which is equals, now these two parameters gets added together and stored in sum. So, the sum is equals a plus b. And afterwards we return this variable, or this value in this variable, via return sum. Alrighty. This is a very basic function written in a high-level program language, but the CPU cannot handle it in this way. So therefore, this function is being compiled, and the compiler translates this high-level function into single instructions which can be handled by the CPU. So let's have a look into this, but don't worry, only on a very high level. Therefore, let's draw this line over here. Alright. So here now we have our CPU. This is our CPU. And this one has, of course, also some pins. Some of them seem to be not connected, and some of them, they could be shorted out. But yeah, this doesn't matter because we don't use them. Alrighty. So the CPU doesn't understand things like int a or int b, or also doesn't understand a variable named sum. What the CPU understands are registers. So a CPU has a register. And this one, for example, or this one, or maybe also this one here. And these registers are now some kind of placeholders for these values or these variables. In this case, for example, this register can hold the variable a, and this one holds the variable b, and this one holds the variable sum. If we're talking about smartphones, we are most likely having an ARM architecture. And an ARM architecture has registers named from R0 to R1, R2, R3, and also some other registers like the program counter, for example. Alright, now if we compile this code over here, then the compiler is translating these into singular instructions, and this will end up in the following. For example, if we call this function over here, the first argument, this parameter 1, this one will be stored in our register R0. So R0 is now holding A. B will be stored into R1. And regarding to the other parameters or registers, we do not have any other parameter. Therefore, these registers are not being used in our calling convention over here. The program counter holds the value or the address of the next instruction, but for now let's ignore this. So this is simply just set to the next instruction, which is going to be executed by the CPU. Alright. The sum will be afterwards also stored in a register, and on the ARM architecture, the return value of a function will be stored in R0. So afterwards, R0 is not holding A anymore, it's holding the return value, which is sum. This is how a CPU is handling these values or references. I mean, it's a little bit more complex, but on a high level, it looks exactly this way. Alright, but what if we run out of registers? For example, on the ARM architecture, R0 up to R3 are being used as parameters. So these registers hold the parameters of a function. But what if our function now has 10 parameters? Then the CPU is storing the first 4 parameters in those registers over here, R0, 1, 2, and 3, and the others are being pushed onto the stack. The stack is the program memory. So this one over here. This one is the stack. And this is then holding the other parameters. So they get pushed into the memory. That's the memory. You might ask yourself why I'm telling you all of this. And to be honest, I've got absolutely no clue. Just kidding. Smiley is acting on the same behavior. So Smiley is also using registers to store their values or variables. It's pretty identical to the CPU. But of course, Smiley has other registers, otherwise it would be absolutely ridiculous if Smiley would also use these registers over here. That's of course not the case. So Smiley has their own registers. And what type of registers? Well, let's have a look. Let's make a cut over here. So this is our Smiley corner. There we go. The output in Smiley depends on the tool we are using. For example, the JADX decompiler will summarize all these registers into one blob. The APK tool instead is splitting them up, and that's why I really like to use the APK tool. The APK tool splits them up into two parts. The first part is local registers. These are the local registers used in a function. For example, this one over here. In our case, we have int sum. This is a local register. Local registers only affects this function itself. So only registers which are being initialized or used in this function over here. The other type, do you have a guess what it could be? I'm pretty sure you do. The other type are parameters. And I mean parameters, yeah, that's not that hard. Parameters are simply just registers or values passed to a function. This one and this one, for example. Alrighty, in Smiley, if we are decompiling an application with the APK tool, these parameters are named from P0 up to P something. P0 is also a special case. So P0 is most of the time the this operator. So that's a really special register over here. Therefore, those parameters normally start at P1 and simply count upwards. So this one would be P2. Local registers, they are named with V. So in local registers, we have V0 and it simply counts upwards. In our case, we have a local register or a local variable named sum, and this one would be our V0 register. But registers are not only regarding to local variables, like in this case, for example, V0, which is referenced as sum. For example, this value over here, this value 0. A CPU cannot handle 3 tasks at once. A CPU will split up this instruction over here in several different instructions, and therefore the value 0 will be also stored in a register. This can be V0. But it could be also another one, for example V1. And this is not a local variable, this is a local value which is temporarily stored in a register. So to make this a little bit easier, registers are just some kind of placeholders for values. Alrighty, one important thing we need to remember if we are working with those registers is that those registers, if we initialize them at the beginning, it doesn't have to be the same at the end. Not just regarding to the values, also regarding to the variables. For example, if we extend this function over here. So at the beginning, we are initializing V0 with the variable sum. And then let's say we have some bunch of other variables. V1 is holding D, V2 is holding I, and so on. Afterwards, we are returning, for example, V1. Return, there's some letters missing, I guess. Yeah, there we go. Alright, so the compiler is now generating this code, and in a certain level, for example, in between here, the compiler might recognize I'm not using the variable sum anymore. This one is not going to be referenced or returned from this function anymore. Therefore, we can recycle this register. because also those registers are very valuable for the whole program flow. For example, regarding to runtime performance or memory usage or whatever else. The compiler tries its best to optimize this code as good as possible. And therefore, if the compiler recognizes, oh, okay, the variable sum is not going to be used anymore, then it recycles the register which is holding this variable. In this case, v0 might be recycled, and it might be initialized with a completely different variable at the end. For example, set. And now let's assume the program is not returning v1, it's returning v0 at the end. If we take a look at the beginning of this function, then we might think, oh, okay, this function returns the variable sum, but this register has been recycled, therefore overwritten at this point, and yeah, the program returns this variable set instead. So this is something we need to keep in mind. Therefore, my approach is to keep track of every register, and you will see this during this course. So I write every smiley line into some pseudocode line, what it does and what actual register is holding which value. By doing this, we can keep track of these registers and we do not lose control or get overwhelmed by all the stuff. In my opinion, this is the best way to learn Smiley, because if we have analyzed the program code, for example, this part over here, this program code, then we have reversed every single line which is in the Smiley code over here. And we do this during this course, and you will see, at the beginning it might be a little bit hard, but if you keep practicing this over and over again together with me, then you will be able after this chapter to reverse and also write your own Smiley code, which is super amazing. I promise this to you. If you keep on working together with me during the Smiley chapter and reverse and perform all these exercises together with me, then you will be able to read every single Smiley line, and you will be also able to write your own Smiley code. So you can patch an application in whatever way you like. Alrighty, so let's summarize this here real quick. I mean, we're at the beginning. So what is the key takeaway of here? Okay, so Smiley acts on registers, and if we are using the APK tool to decompile our application, the Smiley files or the registers are being split into two parts. One is regarding to local registers, and one is regarding to parameters. So local registers starts with V and parameters starts with P. Our parameters normally starts with P1 and simply upwards, P2 and so on. We've got a special parameter register which is P0. Let's write it over here. P0 is the this object most of the time. So in 99% P0 is holding this object. So for example, if you're writing Java code, we've gotten this dot. This is exactly the P0 register. Don't worry too much about this right now. We will learn this later on. Alright, what we also need to remember is if we are initializing or assigning a variable or a value to a register, this register can be recycled. So if this happens at the beginning, it doesn't mean that this register is holding this variable or this value at the end of this function. So it can be overwritten, but it can be also completely recycled. So instead of having the sum variable, there could be a completely different one in there. For example, the set variable. We need to keep track of this, and you will learn during this course how we can do this. That's easy. We simply reverse engineer every single line of Smiley and we write down what this instruction does. And then we do not lose the track about this. Maybe one last thing I need to mention over here. So in my opinion, the best way to learn Smiley is having an approach on our graphic tablet over here, but then also some learning experience on the slides. So we take this code, we modify it a little bit, and then we will go through this once again on the slides. So it might be sometimes a little bit frustrating if we go through a topic twice on the graphic tablet and also on the slides. But for me personal, and also the feedback I received, this approach is the best way to learn Smiley, because Smiley, it's all about practicing and repeating what we have learned and applying it to new functions. So by having this, it's sometimes a little bit boring if we discuss this twice on the graphic tablet over here and also on the slides. But you will see the progress on yourself if we do this and keep doing it. Okay. So sometimes it's also a little bit better to have it on the slides instead of some messy arrowing going around over here. Alrighty, and let's write this code, decompile it, and then analyze the Smiley part in there. Afterwards, we apply some patches and we will have a look at the modification on our slides. Therefore, let's switch back to the Ubuntu VM. Okay, here we are now at our Ubuntu VM. Let's write this function and have a look at a real-world application. So we're opening up Android Studio. Tools, Android Studio, bin bash studio sh. Okay, now let's go into this class and extend this method. So we go into player and we add here a new method named public int add power, and we provide 2 integer values. And then we've got this sum, which gets initialized with 0. Then we have sum equals a plus b and return sum. Okay, let's compile this application and then we have a look into this with the APK tool, and we also compare this with the JADX GUI. So we go to build APK. We also do not need to call this method because it will be decompiled, or it will be compiled into those Smiley files afterwards in this player class. Sometimes there's some kind of decompiler optimization that strips out unused methods, but in our case we should be fine. Here we have our APK. And let's make this more clean. So we add a new directory within the apps. Smiley1 method register. Rename registers. Okay. APK tool d registers. Alrighty, registers, Smiley, app hacking, Smiley1, and here we have our player Smiley class. Let's open this with Visual Studio Code. So I'm opening this directory over here. Then I go into this one. We close this one. Yeah, this is the old player Smiley. Yes, so we close this one. And now we drag this new into this. Okay, and we have seen we've got this underneath here. This is our new method. Let's have a look into this. Therefore, we switch to the Java syntax first. Okay, let's have a look into this. We've got a method public named add power, and we do not know what this one is over here. This is just distraction for us right now. We will learn more about this later on in a separate section, but for now we do not care. Okay, next we've got this locals1, and this is the amazing thing of the APK tool. The APK tool is splitting up our registers into locals and parameters. So let's open the source code and keep it next to us and then do the comparison over there. Therefore, let me open this. There we go. All right, so we've got our local register. A local register, in our case, v0, we can find this name over here, here, and here, can be some kind of placeholder, but it can be also a variable name within our Java code. So if we take a look into this, we can see we've got this int sum, a local variable over here. And this int sum is our local register, or is referenced by our local register v0. How do we know that this is the case? We can find this information here. It also starts with .local. So let's make this. From here over here. All right, we can see, let me clean those dots real quick. Okay, we can see we have our local register v0. And this one is now referenced by this label over here, sum. We do not care about this one. And now we know this local register v0 is a local variable in our Java source code in this function over here. And this variable is named sum. So sum is referenced by v0 as a local register. All right. So we know what this one means. Then we've got those 2 lines. We get rid of them. But here we can now see those parameters of this function. And we also got this labeling next to them. So this is the nice thing about the APK tool. We directly see, okay, we've got one local variable, in this case, variable, because we've got this label over here, and we've got two parameters. So we can also find them over here, P1 and P2. The label regarding to the parameters are next to them, always. So we can find them directly here. Regarding to the local variable, we have to go into the source code and figure out if this is a local variable or simply just a placeholder. Then we've got this one here. So let's mark this real quick. Those are clear. Yes. Then we've got this one here, and this is super nice. This is really nice. We've got this line 9, and this line 9 means we can go into the original Java source code and check what is at line 9. And we can find this over here. There we go. So we do not know what this const / something means. We get rid of this. But this one is referring to the instruction that is in our line 9 in our Java code. So if we take a look into our Java code, we can directly see what's going on right here. We've got int sum is equal 0. And this is exactly what this line does. We know v0 is our sum. And we can also see this one here, 0x0 is the hex value for 0. And here, by having this, we can look up simply the instruction and then figure out what this does. Or we can take a look at the original Java source code. But those line numbers do not always match. For example, in this case, if we open this application in JADX GUI, because we are hackers and we do not have the source code, we will have a different line number over there. Because the compiler has done some optimization and it's not storing this value in a separate variable, it's simply just returning this a plus b. And therefore those line numbers mismatch. But I would say regarding to real-world applications, those line numbers match at least for 90% of the time. So these are a really good indicator. They are not always correct or not always matching to the correct part, but most of the time they do. And if we get more and more practice within Smali, we directly see if those lines matches or if not. Okay, so we can most of the time rely on them. And this is super nice. Because putting them side by side, the JADX output, for example, or the dex2jar and the Smali code makes this whole reverse engineering process a lot easier. Okay, so we also know what this one means. Then we've got line 11. Let's have a look into line 11. We can also see we skipped line 10. Super nice. So it's always skipping those empty lines. It's like having assembly code with debug symbols. Even better in my opinion. So super nice. Okay, let's see line 11, this one over here. There we can see we are adding those two values, but okay, I mean we do not know what this one means. This instruction over here. We have talked about this one. So this is the reference to the local variable in our Java source code over here, this one. We can also write it the other way. v0 is referencing sum. I guess this is more accurate at this point. All right. So we do not know more about the add int instruction. I mean, okay, we can look this up and here we can see those two values gets added together, those two parameters, and then it's stored in sum. And that's of course what this instruction does. But we only want to focus on those registers. And this also helps us a lot because let's have a look into this. We can see we've got our v0 over here. Then we've got p1, oh, wrong color, p1, and we've got p2. So we know v0 is our sum. So we know sum. And we also know p1 is our label a, our variable named a. And a can be found here. The same for p2. p2 is b, p2. So we also got p2. And we do not know what this instruction does. But what we know is those three variables are involved in this instruction. And this is at least a super nice information, even if we cannot read the code on the left, isn't it? Unfortunately, there's a little bit of a downside to this, but this is not a real problem. We can handle this. If we reverse engineer an application later on, we need to keep track of this. In most cases, I guess in all cases, the parameter does not change. So P1 will be also or always referencing this variable. But our local registers might get recycled. So let's say we are using the sum variable here, then we've got a lot of code underneath this, and the sum variable is not going to be used anymore. Then it can happen that the compiler is recycling this register v0 and adjust a new value to this. So at the beginning, we figure out, okay, we've got our local swan. Local swan is a real variable in our Java source code. And here we are returning this value. So we didn't talk about this one, but yeah, let's say we are doing something with this register right here. Then it can happen that this register is holding something different because it's not going to be used in the source code, and registers are sources that the compiler wants to optimize and reuse. And then the compiler says, for example, okay, I'm using the v0 register to store another value in there. For example, the value 10. And at the end, we think, okay, we are doing something with the variable named sum, but we are doing something with the value 10. And this is something we need to keep track on this. We do not know right now which instruction do change this register, so we cannot know this right now. We only also want to focus on those registers. And now I'm maybe a little bit too deep into this topic. But I would like to provide you as many information as possible at the beginning that you learn as much. Okay? I hope this is not too overwhelming right now. So if you reverse engineer an application later on, we simply need to keep track of those registers. We simply write this down in this way. It's not sum anymore, it's now, for example, number. And then we are good to go to move on in the source code. All right. So we also talked about this one. And last but not least, line 13, we also do the same. So I pick up my red color and then we take a look into line 13. We do not know what return really does, but I mean, okay, this is exactly the same like within our Java code. So return means we are returning from the function, and we are also returning the value stored in the register we are going to return. In our case, we are returning v0, and v0 is holding our sum. It did not change right now. This is a short function and the register has not been recycled yet. But if you have a larger function, please keep track on this. And that's all. We do not understand the Smiley code, but if we look at the result right now, even by only knowing what registers are, we can figure out a little bit. This is a really good base we can work on. And from now on, we will learn more and more about Smiley, opcodes and things like this. And within a few sections, you will be already set up to understand your first complete Smiley program, which is super amazing. Okay, nice. Let's switch back to the slides and then we recap this once again. Because by repeating this over and over, you will learn this a lot more faster. Okay, so let's switch back. Okay, here we are back at the slides. Let's have a look into this. I did hide the Java source code. And let's talk about this one first. So take a look into the Smiley code and ignore all the rest. Just focus on what we've learned onto this register topic. Can you find out how many parameters and local variables we have right now in this function? And maybe you can think about this, how it looks like in the Java source code. This might be a little bit too much expectation from me, so don't worry, this one is not required. But regarding to the amount of parameters and local variables, this would be super nice if you could find this out. You can pause this video right now and think about this, and in a few seconds I will move on this point. So let's have a look. Welcome back, and let's have a look into this together. So we've got this one over here, locals 2. This means we've got 2 local variables, and we can also see those labels at the bottom. We've got a new label which is factor, and we've got our familiar label sum. So maybe we have now a new variable name in our Java code which is factor. This is just a well-educated guess, okay? Regarding to the parameters, let's have a look. We've got now P1, P2 and P3. it seems like I have added a new parameter over there. And the funny thing is, if we take a look into this line 2, those brackets, we can also see there has been an additional I in this bracket. And yeah, I guess we can resolve this right now and talk about this in the next section more in detail. This is the type of parameter we provide right here. And I means integer. So we provide here 3 integer values. Okay? But this is just a preview for the next section. So we didn't talk about this, and I didn't expect you to also identify this type right here. But it would be super nice if you have identified 2 local variables and 3 parameters. 3, this way, all right? Sorry for interrupting here shortly. So I don't want to confuse you, but I guess we should be pretty precise on this one. The line 3 .locals2 means we are having 2 local registers, v0 and v1. And afterwards, these local registers being assigned to variables. This is in line 12 and also in line 20 the case. Therefore, we can afterwards talk about variables, but at the beginning, we only have 2 local registers. These local registers can be also placeholders, so they do not have to be assigned to local variables. Alright, I'm sorry for the interruption, but I guess this statement is very important in this context over here. Now let's move on. Okay, let's have a look into the Java source code. How does it look like? Yes, we've got 3 parameters now, and we've also got 2 local variables. One is factor and one is sum. Let's mark them here real quick. So we can see, okay, v0 and v1. These are now our local variable. And do not get distracted by all the stuff that's around our variables and registers over there. We will learn about this by making our way through this Mali chapter. Alright? Okay. So this is what I wanted to teach you in this section. We have learned something about registers. We know there are local registers and parameter registers. And we also know a register holds our value in case of a variable name or another value. For example, the value 0 can also be held by a register. Register can also change during the function. So if we initialize and register at the beginning, like here for example, we initialize v0 with 2, it doesn't mean that this register is still holding this value 2 at the end of this function. It might get reused, it might be overwritten, or there's some arithmetic operation happening on this register that changes this value. Alrighty. In the next section we take a look at the data types, and then we can understand half of the program already. Okay, so I'm looking forward to see you in the next section. Welcome back guys. After those registers we need to talk about types, but this is not a very complicated topic. We just have to memorize or mesmerize this list. What list? This one over here. I also attached this in the cheat sheet. And these are the types we have in our Smali code. So we have seen this strange I letters in our source code, and this I means we've got an integer value. V means void, set is boolean, and beside all these basic types we've also got 2 a little bit strange looking types. The first one is regarding to the class name, and this one starts with a capital L. We have seen this a lot in the past, and we will also take a look onto this later on when we go through the SpacePing application and make ourselves a little bit more familiar with the Smali. So classes start with this capital L letter. Alright? The other type starts with this square bracket, and then we have this descriptor which describes what type this array is of. So in this case, if we've got a square bracket and then in capital B, we've got a byte array, and we can have all types of arrays. Alright? Okay, so keep this list close to you when you start reverse engineering Smali code, because this comes super handy. You will understand a lot of more of this code by having this list, those types definition over there. Let's do this for our application code we've analyzed before. So by having this list compared to us, we can now also determine those types. We've got, for example, add some power, and then we've got 3 times this capital I, which means we've got 3 parameters from the type integer. And after those brackets, we've got another I in green, and this one is the return value. So now we know 3 integer values are going to be passed into our function, and this function is also returning an integer value back. Alright, we can also see those capital I's after those parameters. And at the sum and factor we also got this type definition, but that's all. In this function there are only integers available. Alrighty, here we are now at our Ubuntu VM, and let's do some practicing within our SpacePing application. And therefore we go into our apps directory, SpacePing decompiled, because this has been decompiled with the APK tool. And here we've got our Smiley directory. I opening Visual Studio Code, and then I drag this whole directory into this editor. Yes, it's working. Alrighty. I go back and we open this application also with JADX GUI to have the Java source code next to us. Let's find some types within our Smiley code. We start with the Smiley code and then we check if our assumption is correct or not. So I opening this one, let's see what we've got here. This components, maybe this one is good enough, let's see. Circle bounds, yes. So I'm also opening or changing the syntax to Java, get out my graphic tablet, and now let's do some practical analysis. Okay, this one over here, I guess it's not that hard. We've got an instance field. This means this is a class field, but we do not know about this right now. What we are interested in is this F over here. And this colon and this F means we've got a variable from the type float. Correct. So here we have a class name. We can find this over here. Circle bounds. And this class name got some type radius, and this type is float. A variable named radius, and the type is float this way. All right, let's have a look into our Java code. So yeah, we can keep this over here, I guess. it's fair enough to see if we were correct. So we were in components, collision, circle bounds. Components, collision, circle bounds. There we go. Maybe I have to clean it up. Circle bounds, float, radius. Correct. Next one. What do we have here? All right, let's see what we've got here. We've gotten height and we've gotten width. And both are from type F. F is correct, float. So we've got float, height, and we've got float, width. Okay. Let's check also this one out. We've gotten V over here, and this is the return value because it's after those brackets. The V as a return value is also correct. Great, it's void. So this function is returning a void, and we can also find this over here. All right, next. Oh, let's prove this first. So JADX, rectangle. Yes, float, height and width. But where's our function regarding to the void? And let's have a look back. And this one is an init, and this means this is a constructor, but this constructor is not directly written in this Java code over there. So we will learn about this later on. I just wanted to point you out that we can also get this function return value over here. All right, power up. What do we have here? Coin Smiley, let's take a look into this one. All right, we skip this for now because there's something interested in there. Let's move on the alien. Yes, let's move on with alien first. I enable Java once again. Enable my pen, and let's go. So here we've got our label, and in front of this label we've got this public static final, and this is exactly the same text that's written in this class name. So just to show you this, we've got a public static final, final, and then we've got the sprite name over here. Alright, but something is missing. What is missing? The type of the sprite name. Let's have a look. We've got this colon, we've got this capital L. So This is our type definition, and this type definition ends at the semicolon there. Capital L means we've got a class reference. Which class? Let's take a look. We've got Java lang string. So this one is from the type string. So we can clear this one and we can adjust string. And we can also see that this string or this variable name is going to be initialized directly afterwards over here. So this string is here, and then we've got also this one alien. And the same for this one underneath. So this one over here, we've got also sprite name boss in this case. And then we've got also this colon L. We've got our class reference, Java lang string, and also our initialization. Let's do this. So we've got a sprite name. Sprite name underscore boss. And this is from the type Java lang string. So we've got a string over here. And this one is being initialized with alien boss. So this one over here. Alrighty, let's have a look. I mean, this was a little bit more than we did learn right now, but I want to provide you more and more information that we get familiar with the smiley slowly. Okay, so let's have a look. Let me open this one and let's see. Where was it in? Components alien smiley. Components alien smiley. This one. All right, we can see public static final string sprite name, public static final string sprite name, alien and alien boss. Nice. I was just too lazy to write this blueprint over here, what we've got also here. Alrighty, next, let's take a look into this one. And this one is super nice, yes. Okay, here we have a lot of nice stuff. So let's have a look into this. We've got a lot of instance fields, and instance fields are just member variables of this class. We will talk about this file format more in detail in a separate section, but let me point this out real quick. We can find this class name over here. So we've got a class, and this class is named color animation. In this case, it also extends this one over here, but we do not care about this one right now. I just write extends, but we do not care. Okay, and this class has now these members. For example, alpha animate. What is this type of this alpha animate? Let's have a look. We've got this colon, and afterwards we've got the set. What is the set? Correct, a boolean. So we know this one is a boolean. I guess I have to write this more clean. Boolean. Okay, next. We've got alpha max. So I'm not writing this down, but here we would have this one alpha max. We've got a colon f. We have seen this f before. F is correct, float. This one is from type float. All right. Oh, we do not have more about. We just have f and set. So these are all float, float, boolean, float, 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 boolean, float, float, and so on. Okay. So you can see it's not that hard, and we can already reconstruct some parts of the source code. Let's have a look into this, how it looks like. So we are in color animation. Color animation. Yeah, so our assumption was correct. We've got this class and an extending a component, but we do not care about this part here. And then we've got all those members, and we also have seen those types over here. All right, finally, let's do some more interesting. Let's see. We go back and then this one. Yeah, this one looks good. Okay. Enable Java once again. Get out the pencil. Let's go. So here we have our instance fields, and here we have frame duration, :f. We know this, type float. We also know this one, type float. But what is this one over here? We've got now a label named play mode. Play mode. But what is this type of this label? Let's see. We've got an colon and an L. This means we've got a class reference. Let's see how far this class reference goes. Up to this one over here. Okay, so we've got this animation, and afterwards we've got a $, and then we've got this play mode. So what is this? This $, is just a signal to us. This animation has an inner class, and this inner class is named play mode. This is most of the time the case for enums, or for example, if you extend async task or things like this. So if you have a class name and within this class name you have an inner class, then these two classes get separated with this $. Alright, let's take this topic real quick to the slides and discuss it over here. I guess that's way more easier. So on the left we've got a public class animation, and this public class can now have an inherited class, which is play mode, or also an enum type, which is play mode. Both of them will be addressed via the main class, via the animation class, followed by a $, and then the type. For example, the enum type or the play mode class. So let's split this up over here. We've got our main class, the animation. Then we've got a subclass, or for example, an enum type, which is play mode. Now, if you want to address this play mode, we have to address the main class, which is animation, followed by a $, and then we go into play mode. So then we can address the play mode class or the play mode enum type. In total, it looks like this one. Animation, $play mode. So this is the magic behind this $. This is just the reference to an inherited class or an enum type, for example. In this case, it doesn't have to be in class. It can also be, for example, an enum type. So we have to go into the Java source code to figure this out right now. Later on, we will learn how to deal with this. So let's have a look. Whoops. Okay. Where we are? We are in animation parameters. So animation parameters. Okay. We can see animation parameters has now this class animation play mode. We can double click on this in JADX GUI, and then we end up here. All right. We've got now a class named animation, and this animation has now an enum type play mode. And this is what we've got. So we've got animation, $, and then we've got this play mode. So in our case, we are having an enum type within our class name, and those get separated in this way. In the next section, we have some kind of quiz. So I prepared some examples, and then we have to figure out what are the parameters, what are the local variables, what are the types, and what is the return value. And by training this in this kind of quiz, we are getting better and better. And this is what is also important in Smiley, that you practice this stuff. Okay, feel free to browse around in this code and exercise a little bit with the type definitions and also with this parameters local variable stuff. Do not get distracted by all the other Smiley parts, and then I see you in the next section. Alright guys, welcome back. In this section we talk about the P0 register. This one is a special register that is holding our this object. Therefore we write a little piece of code and afterwards we analyze this code. And then we switch back to the slides and we will repeat this step. Because by explaining this in two different ways, we will learn this a lot faster. Alright? Let's go. Let's switch to our Ubuntu VM and then we write our P0 register code. So therefore we go into the Android Studio. Tools, Android Studio, bin, bash studio.sh. Okay, the IDE has finished loading. Now we extend our player class with a set and get method. We start with the get method. So public int get power. We do not have a parameter and we simply just return our power value. Return this.power. That's all. If we call this method, our power value will be returned. All right, let's build this application. And then we are going to analyze the Smiley code on this. The build process has been already finished, but I missed the window. Then I simply click into the event log. And here we can see, all right, locate, new terminal, and we decompile this application. No, not signing, APK tool D. There we go. Okay, we go into app, Smiley, com, app hacking, Smiley1, and here we have our player.smiley file. Let's open this with the Visual Studio Code editor. Code player.smiley. I'm also choosing the highlighting for the Java code. Yes, it's not a Java code, but the highlighting match. And there we go. This is our power method. Now I get out my graphic tablet and then we will take a look into this. Okay, let's recap what we already know. We've got a method, public get power. So we write this down next here. Get power. We do not have any parameters within this method. But this method is returning an integer value. Okay. I guess that's not bad. Now we've got a local register, and this one seems a little bit interesting. We can also find this over here and here. So we've got an v0 register, but we didn't have a local variable in this function, did we? Let's have a look back into this. So it does not have any local variable there. Why is there this v0 register? Let's have a look back into this code. Okay, let's have a close look into the next line, this one over here. And I'm going to clean all these dots. And this one also. So we do not know what this I get v0, p0 and this value afterwards means. We will learn about this in the next section where we have a look into Dalvik opcodes. For now I can tell you I get means, we've got this I get over here, then we've got a v0, then we've got this p0, which is, by the way, the reason for this section, our this. And what I get does it takes this value over here, so this power, and stores it into v0. And now it's clear why we've got this v0. Because if we take a look onto the right side once again, we are returning an integer value over here. But we cannot return, for example, this one. We cannot write this statement into the return value over here. Because if we take a look back into our CPU model, so here's our CPU. The pins are getting not even better. But we do not care about this one. But our CPU cannot understand this as it is this object. Our CPU needs to split up, or the assembly code needs to split up this into single instructions, and therefore it's generating a buffer for this value. And this is what v0 is over here. So our v0 is some kind of buffer that is holding or storing this value, and then it's returning this value in this register. So this one is holding our this.power, and afterwards the CPU doesn't have to use this statement over here because it cannot understand this one. It can simply say return v0, and this is now holding our power. Okay, so registers are not always regarding to local variables. Registers can also be some kind of placeholder for certain values or functions, return values, whatever. Okay, this is really important. If you see some locals, it doesn't always mean we've got also a local variable here, like for example int my power or things like this. It can also mean that the compiler has created some kind of buffer in form of a register, for example v0, and this one is then holding the value for this object over here. And this register can be returned afterwards. And this is a way that the assembly code understands afterwards. So by returning back this value in this register, the code can move on that point because it understands what registers are. Okay? All right. Let me clear the screen real quick and then we take a look into this P0 object. All right, we know P0 is a special register that is holding our this object. So we can replace this one rename this one to this. So if you see P0, you can rename this to this. Then we've got this colon, and then we've got our type definition of class, which is referenced by this capital L. What class do we have here? We have com app hacking smiley player. So our class definition ends at this sign. So we've got our player class. This is player. And then we've got this little bit strange looking arrow over here. And this arrow, you can think of this as a dot. So you can replace this as a dot and then okay, player dot power. And at the end of this, you can also see the type definition of this one, of this power level or this power variable. And this one is an integer. And to summarize this whole line, we can just make a little bit easier. So we've got our this, and then we can say dot power, and that's it. Because we do not need this reference. This is just regarding to the smiley object that it knows what this over here, this, it's really hard to, I hope you can follow by explaining this in this way. So this needs to be referenced, or it needs to be clear to the smiley code what type of object this is. And here we can see this one is a player object. Okay, but we do not have to use it in this way. We can simply say this and then treat this arrow as a dot. And afterwards there's this label or this variable name what's referenced. Okay, so this is the first explanation. Now let's have a look back onto these slides and explain it in a different way. And maybe if you have questions regarding to this explanation, I hope they will be answered in the next one. And if not, then of course, if you do not understand this topic right now, then please write me some messages, okay? So I'm going, insert this one into my graphic tablet and then we have a look back onto the slides. Let's switch back. Okay, here we have this method once again. We've got our local one, which is our v0 register. And we also got this p0, which is referencing to the player class. And after this arrow, we can see the player class dot power value. Why do we have this register right now? Because if we use this expression, we get this power. And if we are trying to return this statement, this is not working because we can only act on registers. We cannot act on direct objects in this way. Therefore, we are buffering the value of this object in a v0 register. And by having this value in this v0 register, we can easily return this afterwards. Therefore, we are having a local register, but we do not have a local variable regarding to this register. This one is some kind of buffer, placeholder to store this value of this power. And regarding to this power, we can separate this in this way. P0 means this object, so we translate P0 with this. And afterwards we can simply look at the arrow and then we can say this dot and the label after this arrow. In this case, this dot power. If we would only have this P0 power, we would not know which class we are referencing right here. Because this can be also a different class, an inner class or things like this. Therefore, the smiley code is also appending this, that it's crystal clear that we are using this object from the player class. And it looks a little bit overwhelming at the beginning, but if we split it up in this way, it will become, easier to read. And if you do this a lot, you will get practice and then you immediately recognize, okay, this one is this dot power reference and it gets stored into the v0. The storage with the iGet, this is what we learn next. We will have a look into Dalvik opcodes and then we can read our first programs where we add and subtract some values and we can also start writing our own smiley code. But we are not doing this for now. We will have some time regarding to this topic. Okay, we do this step by step. If you have any questions regarding to this object or this code over here, then please write me a message. And regarding to the iGet object, we will learn more about this in the next section. So I see you there. So registers are not always regarding two local variables. Registers can also be some kind of placeholder for certain values or functions, return values, whatever. Okay, this is really important. If you see some locals, it doesn't always mean we've got also a local variable here, like for example int myPower or things like this. It can also mean the assembler code has to create. It can also mean the compiler has to create a kind of buffer to store this value from the this object. It can also mean that the assembler code has. It can also mean that the compiler has to create a kind of buffer which stores this value and then can act on this. It can also mean that the compiler has created some kind of buffer in form of a register, for example B0, and this one is then holding the value for this object over here. And this register can be returned afterwards. And this is the way, and by doing this in this way, this is And by doing this in this way, we do not have to care about memory. And this is a way that the assembly code understands afterwards. So by returning back this value in this register, the code can move on that point because it understands what registers are. Okay? All right. Let me clear the screen real quick and then we take a look into this P0 object. So here we've got our P0. Let's have a look into this section, over here. Okay, P0 is our this. So if you see in P0 like this, you can also translate it as in this. So this is P0. And then you can imagine of a dot afterwards. If you see this colon, you can imagine of this dot. And now we've got our familiar type definition, this capital L. This capital L over here means we've got a class. And this class is referencing this object. So what do we have here? We have com app hacking smiley1 player. So this one is our player. This is our player object. This is our player object. And then we've got this one over here. Okay. Okay, let's have a look into this P0 a little bit more in detail because this is what the section is about. So let's have a look into this. Okay. Okay, let's have a look into this P0 object because this is also what the section is about. So I try to draw, that's not a really good rectangle. Okay, let's have a look into this P0 object because this is what this section is about. So we are now focusing on this part over here. Okay, so we've got P0, then we've got a colon, and then we've got our L. And this capital L means, okay, we have a class reference. In this case, we can see this class reference is com app hacking smiley player. So we've got our player class over here. Let me draw it this way. After this player class, we've got this strange arrow. Okay, let's have a look. Okay, let's have a look into this P0 object more in detail because this is what this section is about, right? Let me zoom in a little bit. Not this way, this way. Okay, so we are now focusing on this part over here. So we are now focusing on this part over here. Okay, we know P0, this one over here, is our this object. So you can replace P0 with this. Okay, now let's focus on this part over here. Alright, we know P0 is a special register that is holding our this object. So we can replace this one, or rename this one to this. So if you see P0, you can rename this to this. Then we've got this colon, and then we've got our type definition of class, which is referenced by this capital L. What class do we have here? We have app hacking smiley player. So our class definition ends at this sign. So we've got our player class. This is player. And then we've got this little bit strange looking arrow over here. And this arrow, you can think of this as a dot. So you can replace this as a dot, and then you know, okay, player.power. And at the end of this, you can also see the type definition of this one, of this power level, or this power variable. And this one is an integer. And to summarize this whole line, we can just make a little bit easier. So we've got our this, and then we can say dot power, and that's it. Because we do not need this reference. This is just regarding to the smiley object, that it knows what this over here, this, it's really hard to, I hope you can follow by explaining this in this way. So this needs to be referenced, or it needs to be clear to the smiley code what type of object this is. And here we can see this one is a player object. Okay, but we do not have to use it in this way. We can simply say this and then treat this arrow as a dot. And afterwards there's this label or this variable name what's referenced. Okay, so this is the first explanation. Now let's have a look back onto these slides and explain it in a different way. And maybe if you have questions regarding to this explanation, I hope they will be answered in the next one. And if not, then of course, if you do not understand this topic right now, even after, and if not, then please write me some messages, okay? I have to adjust it, then please write me some messages, okay? So I'm going, insert this one into my graphic tablet, and then we have a look back onto the slides. Let's switch back. Okay, here we have this method once again. We've got our local one, which is our V0 register. And we also got this P0, which is referencing to the player class. And after this arrow, we can see the player class dot power value. Why do we have this register right now? Because if we use this expression, we get this power. And if we try to return this power, the assembly code cannot do anything with this argument or with this instruction, because at least this isn't cut. And if you try to return this cut, and if you are trying to return this object, this is not working because it registers. And if you are trying to return this cut, and if you are trying to return this statement, this is not working. Because we can only act on registers. We cannot act on direct objects in this way. We have to store them. We have to store these values into registers. And therefore, we cannot return this whole object. And therefore, we cannot simply return this P0 object, this object. Cut. And therefore, we cannot simply return P0 colon L app hacking smiley 1 player semicolon arrow power. Okay, So this object cannot be returned in this way. Therefore, we are buffering the value of this object in a v0 register. And by having this value in this v0 register, we can easily return this afterwards. Therefore, we have a local register, but we do not have a local web. Therefore, we are having a local register, but we are not. Therefore, we are having a local register, but we do not. Therefore, we are having a local register, but we do not have an. Therefore, we are having a local register, but we do not have a local variable regarding to the. But we do not have a local variable regarding to this register. This one is some kind of buffer placeholder to store this value of this power. And regarding to this power, we can separate this in this way. P0 means this object. So we translate P0 with this. And afterwards, we can simply look at the arrow. And then we can say this dot and the label after this arrow. In this case, this dot power. In case, if you look at the Smiley code, you have, if you would only have this P0 power, we would not know which class we are referencing right here. Because this can be also a different class, an inner class, or things like this. Therefore, the Smiley code is also appending this, that it's crystal clear that we are using this object from the power class. That we are using this object from the player class. And yeah, it looks a little bit, overwhelming at the beginning. And yeah, it looks a little bit overwhelming at the beginning. But if we split it up in this way, it will become, easier to read. And if you do this a lot, you will get practice, and then you immediately recognize, okay, this one is this dot power reference, and it gets stored into the v0. The storage with the iGet, this is what we learn next. We will have a look into Dalvik opcodes, and then we can read our first programs where we add and subtract some values, and we can also start writing our own project. And we can also start writing our own Smiley code. But we are not doing this. For now. We will have some time regarding to this topic. Okay, we do this step by step. Alrighty. So if you have any questions regarding to this object, please write me some messages. I will of course get them back in touch. Alrighty, if you have any questions regarding to this object, then feel free to cut. Alrighty, if you have any questions to this object, then write me a message, of course. Alrighty, if you have any questions regarding to this object, then write me a message, of course. And and otherwise, I'm looking forward to see you in the next section where we are going to learn a little bit more about those Dalvik opcodes. And by having this table reference, it will become easy. If you have any questions regarding to this object or this code over here, then please write me a message. But I guess by doing this and practicing more and more, it will become more clear to you what this whole instruction does. And regarding to the iGet object, we will learn more about this in the next section. So I see you there. Welcome back. In this section, we will take a look at the Dalvik opcodes. So this one is super interesting, and maybe we are able to understand our first program after this section, our first complete program after this section. Let's have a look. In the last section, we have taken a look onto the following program. So we have done our typical analysis. We have identified parameters and return values, in this case 0 parameters, return value integer. We have also learned more about the P0 object, and why we do have a local register even if we do not have a local variable over there. Alright. What we did not learn is more about the iGet instruction. And the question of course is, what is this iGet instruction and what does this iGet instruction? And how do I know that this one is taking the P0 value, storing it into V0? Well, I also got some help on this one. And the help I've got is the Dalvik opcode instruction set. And this is a kind of list full of instructions and the corresponding description to what this instruction does. I couldn't find an official documentation, which is in my case super ridiculous that there isn't one out there, but I have found a super amazing site. And this site has most, maybe barely all instructions and the corresponding descriptions to them. And this site I really want to show you right now. So I switch to my Ubuntu VM, then I go into my browser of choice and I search for Dalvik opcodes within Google. And this one over here, I do not want to pronounce this name because it will be definitely wrong, but really thanks to this one who has put this website online. So this is a nice list of all these instructions over here. And you definitely want to bookmark this site right now because you will use this a lot. I also looked them permanently up in this list over here. And let's have a look into the iGet object instruction. The iGet instruction. And here we can see we've got iGet, vx, vy, field ID. And there's the description to this. Reads an instance field into vx. Instance field is our this.power. And by reading an instance field into vx, we are reading this power into our v0. And it doesn't have to be v0, of course. Therefore, it's this x parameter over there. It can be also v1, v2, v3, and so on. And we can also see the instance is referenced by v0. So this description is amazing because it directly or immediately tells you what this instruction does. And the author didn't stop by doing this description. The author also puts in an example on the right. Without this website, I wouldn't have learned Smali. And therefore, I'm really grateful to this author. Okay, let's do this once again. So what does iGet does? We take the right part and read it into the left part. So the left part is holding this value afterwards. That's all. Nice. Let's get back into our example, this one over here. Let's take this list and see how far we can get in understanding this function over here, add power, because we haven't looked up those instructions yet. And what we do is we take a look at the Smali code, we figure out our parameters, return values, and then we will try to complete the puzzle by looking up the missing instructions. Okay, let's see how good this goes. So I'm going to build this application once again in case I did modify it in any way so that we are using this code. All right, already done. I delete this directory over here and we do this once again, APK tool D. Okay. This has been also finished. Then we go into app debug, Smali, com, app hacking, Smali1, and I open a new terminal over here. We can close this one and I'm opening the player.smali file. Alrighty, let's zoom out a little bit. Enable Java. And also just focus on this one over here. Alrighty, here I've got my graphic tablet and now we analyze the Smali code. We will slowly do this step by step and we will reconstruct the whole Java code. Afterwards, I show you a different approach, the way I like to reverse engineer this code. But for now, let's keep it to restoring the Java source code. Alright, let's do a little bit of a recap. What do we already know? So let's go. Okay, so we've got our method. This method public add power. This is our method name. So we write this down next to this, add power. This method has now two parameters. Those two. Both are from the type capital I, which means we've got two integer values. And we can also find those labels over here if you take a look into those two. These are our parameters. And the first one is int a and the second one is int b. next we've got this one over here, the return type, and it's also returning an integer value. Therefore, we can write this down over here. And now we've got our function prototype. Pretty nice, right? Next, we've got this locals one, sorry, this way. And this means we've got a local register. We doesn't know if this register is just a placeholder for a return value of another function, or for example for an instance field, or if this local register is used for storing a variable. If we go down a little bit, we can find this one over here. And this means our local register v0 is a local variable with the name sum. And this sum is also from type integer. Okay, so let's write this down. We've got an int sum over here. We do not know if the sum now gets initialized with a value or if it's holding in value. We just know these information at this moment. Okay, then we've got our two labels, parameters. And what I like to do is I like to keep track of this. So we know int a is p1 and we know int b is p2. And we also do this for the label sum. So this label over here, this local variable sum, is referenced by the register v0 right at this moment. This might change later on if this register gets reused because this label is, or this variable is not going to be used further, then this might change. But for now we know v0 is referencing the label or this variable sum. Okay, let's move on. Okay, so we did understand this part, also this part, this and this part. Now we've got this one over here. Let's focus only on this one right here. This is a new instruction, a new opcode. So let's look this up, or let's first have a look into this. We've got a const /for, then we've got v0, 0x0. Okay, now let's look this up. Okay, here we are at our Dalvik opcode site. So we are looking for const /for. And here we've got the description. Const /for vx, lit4. This lit4 looks super strange. But if we read the description, we know what lit4 means. Puts the 4-bit constant into vx. So we've got a value over here, for example, the value 2 or the value 4, and this value gets moved into this register vx. We've also got an example on the right side. So let's have a look into this one. We have this const /for v1, then we've got this hashtag, and then this integer value 2. So we can represent numbers in Smiley with a hashtag, then we can write the decimal value, or we can write 0x, the hex representation of this value. Okay, and what's this? And this is the bytecode. So this is the hex code, and if we represent this hex code in binary values, these are the ones and zeros that execute this instruction. Const for v1, hashtag int2. So this is moving the value 2 into the register v1. Alright, not that hard for this instruction. Okay, let's get back. So let's do this once again. This instruction, we've got const /for v0, 0x0. So we are now looking only at this instruction, and we do a further explanation on this. We are moving 0 into v0. And if we get back to the reference, the Dalvik reference, our v0 is referenced with vx, and this one is referenced with lit4. So therefore we also know how to read this. Okay, regarding to lit4, let's take a look onto this. So we are moving 4 bits into the register v0. 4 bits, we can represent them in this way. 1, 2, 3, 4. Those 4 zeros gets moved into v0. Why do we move 4 zeros and not 8, for example, in whole byte? This depends on the compiler. So the compiler tries to save as much as space or memory as possible. And in this case, we can see the register is being initialized with 0, and 4 bits representing this value is enough. So the compiler optimized this code and used only 4 bits to initialize this value 0. Okay, let's have a look into this instruction once again and more in detail. I mean, you might think, wait, there is more? Well, let's figure this out. Alright, if we take a look back into the description, these two are referenced with vx, and this one is referenced with lit4. But what about this lit 4, those 4 bits? This is a little bit annoying or confusing. Let's have a look into a real example. Let's try to store the number 10 into this register V0. The number 10, this one over here, 0xa. The hash sign is a comment in Smiley and it's being automatically generated by the APK tool. So this one is only for better readability. This does not affect the code itself. The value 0xa is being translated into 10, and that it does not disturb the code itself, a comment is being appended by the APK tool. So we can completely ignore everything after a comment, but it helps us to read this code a little bit easier. Okay, to get a view onto the bits, we need the binary representation of this value 10. We can do this by splitting this up. So we've got 2 square 0, 2 square 1, 2 square 2, 2 square 3, and 2 square 4. This one is 1, 2, 4, 8, 16. So if you want to represent the number 10, we have to add 8 plus 2. And therefore, those 2 bits are set and the rest isn't. This is the binary representation of the number 10. And if you take a look into this, we can see, yes, this number fits into 4-bit. So we can also store the number 10 with this instruction over here into the register V0. Okay, and now let's try to store the value 20 with const /4 V0, and then we've got 20, which is 0x14. This is 16 square 0, which is 1 times 4, and 16 square 1 times 1 plus it's 20. Okay. Yes. Okay, let's do the binary representation of this value 20. We do the same approach. 2 square 0, 2 square 1, 2 square 2, 2 square 3, 2 square 4. We've got 1, 2, 4, 8, 16. And here we've got 16 plus 4. Therefore, we've got this bit set, this not, this is set, not. All right. Here we can see we have a problem. If we try to store 4 bits and the value 20, this does not work. If we stick to our 4 bits, we will store the value 4 in our case into V0. So afterwards, V0 would be 4. But it might be important that the value V0 or the register V0 is holding the value 20, and 4 is not equals 20, right? Basic math. Therefore, the compiler throws an error, and we get a message that we cannot use or we cannot store this value into a 4-bit register. We have to extend this register, and I guess the next one is 16. So in our case, it would be const 16. 16 has now a lot of additional bits over here. And const 16, this works out. We can store the value 20 into our V0 register with this one. So if we write code, we do not care about this because this is something that the compiler does automatically. But if we want to patch this application and we want to increase this value over here, then we have to take care about this. And then we can figure out what's the next possible instruction for this, for example, const /16, or we can simply use const. Because const as a default is set to 32-bit. So if you encounter a const /4 or const /16 instruction, then think about this value, and if you need to increase this furthermore, replace also this instruction, not only the value. So by switching out those value over here, replacing this, for example, with 0x14, this will not work because const 4 bits cannot hold this value. Therefore, simply remove this one over here and we are good to go. So I guess this instruction is now clear, isn't it? There we go. Let's clean up this a little bit. Okay, so we talked about this instruction. What does this do? Just kidding. Let's have a look. We've got our int sum. Int sum is referenced by v0. In this case, we are moving the value 0 into v0, which means we are moving the value 0 into our sum variable over here. And I like to keep track on those registers. So I would also write down v0 equals 0. Okay? So we initialize our sum with the value 0. This is what this instruction over here does. Alright, so we also understand this one. Then we already talked about this one. There we go, we have a new instruction. This one over here. Before we look up the Dalvik opcode, let's have a look into this. So let's write this down. We've got an add int v0, p1, p2. Okay, so we have 3 registers at this instruction. And this one, yeah, I'm pretty comfortable to say what this one does, but let's figure this out. Okay, back at the opcodes, let's see. We are searching for add int. And here we can see add int vx, vy, vz. Calculates vy plus vz and puts the result into vx. Alrighty. Calculates vy plus vz. So these two gets added together. And the result is stored into vx. Okay, I guess that's also not that hard. Let's have a look at the example over there. Adds v3 to v2 and puts the result into v0. Okay, it's exactly the same. Okay, so let's have a look back onto our code. So we split this up once again. And then we say, okay, p1 gets added together with p2. And the result of this gets stored into v0. Let's replace those registers with the original labels. Okay, so let's write this down in a mathematical operation. So we've got v0 is equals p1 plus p2. This is what this instruction does. Okay, now let's replace those registers with our labels. We know our v0 is sum. Therefore, sum equals p1 is our a. A plus p2 is our b. Okay, this is what this instruction does. Let's clean this up and write it down, yeah, more clean. So this one over here is sum equals a plus b. Okay, so we also got this one. And finally, there's our return v0. We also know what this one does. It's returning our v0, which is referenced or assigned with sum, the label sum. And yeah, there we go. We have restored the Java source code out of the Smiley code. Isn't this ridiculous nice? In my opinion, it definitely is. So it's super nice to write this down in this way. We can reconstruct the whole Java code, and this will help you learning Smiley more and more. In my case, I'm not a real fan of writing this down in the original Java code, because we can simply take this function and decompile or recompile this into Java, and then we can see, okay, this is the Java code corresponding to this Smiley function. In my case, I like to write this down in a little bit different way, because we are not interested in those Java functions, or at least in those Java namings. We are more interested in which register is holding which value, because we want to patch some values to improve our power level, improve our gold items and things like this. And this needs to be done on register level. So we cannot simply tell sum is now equals 40. So it's not working in this way. Therefore, we have to go into the Smiley code onto the left, and then we have to patch the register, which is exactly doing this step within the initialization or something else. So now I'm going to show you my approach. It's pretty the same, but I label this a little bit different. So let me clean this up and then we have a look into this. Okay, so don't get me wrong. This Java source code is amazing, and if you like to stick to this one, of course, do this. I'm now going to show you my approach, and this is just my personal reference. If you like to do this in the same way, then feel free to go also into this labeling. But if you like to stick to the Java approach, absolutely no problem. You just need to know or just need to be able to reconstruct the code out of the Smiley function. So let's see how I would normally write this down. I start with the same approach. Method public add power. So here's our method add power. Then we've got those two parameters, and I would not name them A and B. I would name them P1 and P2. I like to stick to the registers. So in my case, I would have named this int P1 and int P2. Then yes, return value also integer. We are good to go. Just a small difference regarding to the approach we have done before. Okay, then I also move on with the next line. But in this case, I do not care about this locals one, because I'm doing this for one instruction after each other, and I'm not going into this one and look this up downwards because I do not care about this label. Let's see if we do not care about this one, how the approach looks like this. We can now go from top to the bottom, each instruction after each instruction. Okay, then we have those parameters, and yeah, we already got those two. And of course, we can also use those labels over here. So we can say this one is A and this one is B. Not a big deal, but normally I do not care about those labels. Okay, next we've got this one over here, and we can write this down exactly as it is. This value gets stored into V0. And normally I do not like those hex values. So I would write down V0 is equals 0. Okay. Next we've got this label over here. And here we can see, okay, this V0 register has now this label sum and this is from type integer. So I would write this down as a comment over here, but I would like to keep track onto V0 and not the label sum. So I would write down int sum this way. Then we can move on with the next one. Here we can see, okay, P1 gets added to P2. And this result is stored into V0. And we write this down exactly as it is. V0 is equals P1 plus P2. And last but not least, we are returning this register V0. Okay, and this is the way I like to do this, because by looking into this code, we do not have to substitute those registers with the labels or things like this. We can directly see, okay, we've got our P1, for example, over here. We've got a P2 over here. These two gets added. This means we've got a new value here in this register, and this will afterwards be returned. And here we initialize this register. So by doing this in this way, it's more clean for me, but this is my personal preference. If you like to resubstitute those values and stick to the Java code, feel free to do so. Okay, regarding to which approach you are using, this should be always the same. So take a look into the Smiley code and go through this line by line. And instructions that are unknown to you, please look them up. The Style-Pick opcode table is super amazing, and I'm doing this most of the time. I also encounter a lot of new instructions, and I look them up in the description. Maybe I write some little programs to understand some complex instructions, but afterwards, yeah, I know what they do, and then I write it down in the following way, as you can see here in this pencil drawing, this one over here. And by doing this in this way, even a complex Smiley code gets split into single pieces, and we can understand and write this down afterwards. It's pretty amazing if you take a look onto the left and now realize, wow, you understand every single instruction already in this Smiley code. And before you started this course, you might have even not known Smiley. So this is a huge step already, and we will get further and further within this chapter. All right? Okay. In the next section, we will extend this program a little bit. We will add new variables, maybe new functions, things like this. And by doing this, we will also repeat the steps over and over again. This might be a little bit boring, but by repeating this, you will get more and more familiar with Smiley. And after some point when it makes click, you stare at some Smiley code and you realize, wow, I'm able to read this Smiley code in there. Freaking amazing. Believe me, you will have this moment. All right, so I'm looking forward to see you in the next section. Welcome back. In this video, we want to take a look at the file structure of a Smiley file, because we digged directly into this file and yeah, we didn't talk about the structure itself. So this is something we want to do right now. And you will see this is not really complicated. We've got the structure most of the time, I guess 95% of this time. So let's have a look. In the first line, we've got our .class public, and then we've got this capital L, which means we've got a class reference. And this one ends at the semicolon. So we've got our class reference to the player class. Okay, this was not really hard. In the next line, we've got this .super. And this means our player class is a subclass from this one over here. In this case, it's Java-lang object. As another example, if we take a look into our main activity, our .super class would be activity because our main activity is a subclass from this activity class. All right, so also not that hard. Next, we've got our source, and this one is player.java, but I guess all said about this one. All right, then we've got this hashtag at the beginning of the line, and this is some kind of separation. Okay, I guess I need to be a little bit more exact on this one. The hashtag simply just means a comment, and therefore the text is being ignored, the text behind this hashtag. This is not an instruction, this is simply just a text. This text has been created by the APK tool to support us in understanding the file structure. It is also being used to reference some values. For example, we have some hex values and directly behind them we have a decimal representation after a hashtag. This means the APK tool gives us some information about static field, instance fields, private and virtual methods, and also tries to help us in converting hex into decimal values, which is pretty nice. So to summarize this, a hashtag means a comment, and in this case it is some kind of separator, but only a visual one, not a technical one. Alrighty? So we've got several hashtags for different meanings over there. But between those we often have something called annotations. And these annotations are inner classes. If we're using inner classes within our player class, the smiley file needs to have this reference. And this is what this one is for. In our case, we do not have an inner class, for example, an enum or something like this. We will take a look into our SpacePang application to also get familiar with this one. All right. Next, we've got this static fields, line 6. And the static fields starts with an hashtag. Underneath this one, we've got all static fields within this class. In this case, we only got one static field, which is lives. It's from type, correct, integer. Next, we've got this instance fields, also starting with an hashtag. Now we've got all our class variables. In this case, we've got power and shield. So you see, I've added some new instance variable over here. Next, we've got a new hashtag, and this one starts with direct methods. And this one is regarding to private methods, static methods, and also constructors. Regarding to static methods, this is a little bit special because the Dalvik bytecode has a certain reference for this one. So we do not find static methods in there. In this case, we can focus on constructors and private methods. Okay? And finally, we've got this virtual methods, which means we've got our public methods over there. And that's all. This is the whole smiley file structure. And yeah, if you get familiar with this, you can navigate even more easier around this file. For example, if you look for a certain instance field, you go up into this file, check out this hashtag sign and see, okay, here I've got all my instance fields. Pretty nice. Okay, I guess I need to be a little bit more exact on this one. The hashtag simply just means a comment, and therefore the text is being ignored, the text behind this hashtag. This is not an instruction, this is simply just a text. This text has been created by the APK tool to support us in understanding the file structure. It is also being used to reference some values or types, like we see this over here, after a hashtag. This means the APK tool gives us some information about static field, instance fields, private and virtual methods, and also tries to help us in converting hex into decimal values, which is pretty nice. So to summarize this, a hashtag means a comment, and in this case it is some kind of separator, but only a visual one, not a technical one. Alrighty? Okay, perfect. So let's pull out our SpacePang application and navigate around a little bit in this file and also have a look into an annotations declaration. Let's go. All right, here we are at our Ubuntu VM and let's check this file out. So we go into our directory, apps, SpacePang decompile. I mean, it doesn't really matter. Oh, it does matter We use the APK tool approach because the JADX output is a little bit different and we want to look at the Smiley code. So we need the decompiled version of the APK tool. Let's do this once again together that we have the same state. So APK tool, D, and then space pane. Yes, then we go into this directory and I open the whole directory with Visual Studio Code. There we go. Okay, we also open it next to us with JADX GUI. Then we have the Java code, which is a little bit more easier for us to navigate and yeah, read this code. So space pane decompile, JADX GUI, and this one. All right, so let's find this player class. We use this one over here. It needs to be decompiled and indexed. We also use this class field. I guess this class field is enough if we use only this one. Then we do not have all this distraction. We've got this in components player. All right, and let's put or open this in the Smiley code. So we've got the E, components, player Smiley. And I get rid of this one and we enable Java, even if it's not a Java code. All right, here we go. So let's go through this file once again. Okay, here's my graphic tablet. Let's dive into this. So we can see line 1, line 1, this one over here. We've got our class public, then we've got this class definition L, then this ends with the semicolon. So we also got this player class definition. But this time we have a different package name because we are within a different application. But this is our player class, this one over here. Okay, next we've got the super, and this one nice. We've got now a different one. This means this Artemis component is our base class, and our player class is the subclass from this. And we can see this over here. We are extending this class. This is what this line means. Then we've got our source player Java. Okay, we already talked about this one, not that hard. So next we've got this annotations. And this starts here and it also ends here. What do we have right here? We've got annotations Artemis, annotations pooled weaver. And this seems to be a class. Can we find this class over here? Yes, we are importing this class here at this line. So the Smiley file needs to have a reference to this class, and this is what this annotation does. Next, we've got this one over here. We've got Dalvik annotations member class, player $state. We have already talked about this $sign, which means this one is our class, player. This is our separator, this $. Or let me draw this in a different color. And then we've got this inner class in our player class, which means state. So this is our inner class. Let's see where we find this class over here. Here. So we are having a reference from a different class in our player class. And yeah, this is what we've got over here. So if we take a look into this class, therefore let me toggle the screen real quick. There we go. Okay, it's within this class right here. So here we define this state, which is an enum, and we have this enum directly in our class. So this can be an inner class, a complete new class, or an enum, for example. This also affects this enum. And this is why we have this one over here. This player $state. Okay. I'm gonna clean this up real quick, then we can move on. Yeah, this is all for this annotation files or this annotation description over here. We've got our two references. We've got this pooled weaver and we also got our state. Okay, next we've got static fields. We can see this with the starting hashtag over here. And we've got static fields, default lives, sprite name shield. And these are over here. So I also clean this up real quick. And then I need to drag this a little bit to us. Okay, public static lives, this one over here. And you can see they also start exactly the same way. Public static final default lives. public static final, okay, we've got this int over here, default lives, but this int is within our type definition here. And we also got this value 5. We also got this over here and here. These are our 3 public static values, which are within this one over here. Then we've got a new hashtag, this one. And this signals us now those static fields are at the end. We've got new fields, in this case instance fields. We've got 3 instance fields. 1, 2, 3. Let's have a look. We've got them over here. This is an instant field, public int lives, and this is one score, and here we have our state. Exactly like we've got this over here. Cool. These instance fields also end up here, because here we've got now our direct method. Direct methods. Do you still remember what they are used for? Of course you can. Direct methods are used for private methods and constructors. In this case, let's see, we've got this constructor init returning void. We do not see this constructor right here, but it's of course available. The developer has not created a code for this, but if this object gets created, there needs to be a constructor, and therefore this is automatically added. We cannot find this over here, but it's still there. We can see this in the Smiley code. So we already know more than the Java code. Super nice. Okay. We can also see this private and constructor methods ends up here. And here we've got our virtual methods. Virtual methods are, correct, public methods. And yeah, if I scroll down a little bit, we can see those virtual methods starts here and they end up here because we do not have a new hash sign or hashtag. This means we've got 2 public methods, isState and setState. This one and this one. Nice. And this is the whole file structure for this Smiley file and also for all the other Smiley files. Let's have a look at another example. So let me see what we've got. The sprite looks interesting because I can already see this $sign, which means we have an inner class or an enum over here. Let's have a look. Okay, now we are not opening the Java code. We are doing this only in the Smiley code, and then we will compare this afterwards. So I can increase this a little bit. Let's go. All right, let's see what we've got. Line 1. We've got class public, our class reference, capital L. This one ends at the semicolon over here. The name is sprite. So we've got a class named sprite. Class sprite. And this class has a superclass. So we've got a subclass from component. We are extending this one. Extends component. Okay, then we've got this annotations, and we've already seen this in the Smiley code over here. So at this point, let's see what we've got. We are importing this one over here once again. Okay, next we've got this member classes. So this one is an inner class. And this inner class is named layer. Can be an inner class or also an enum type. We can find this out if we take a look into the Smiley code later on. For now, let's keep this as an inner class. So we simply say we've got a layer. And yeah, this variable name, let's call this also layer. Okay, then we've got a lot of instance fields over here. And we do not have a static field. So this class only has instance fields. And this one has A, B, G, this inner class, and string, and these are floats. Okay, some funny names, A, B, G, R, and so on. These are all those variables. And finally, if we scroll down a little bit, we've only got this direct method, which means we only have a constructor, nothing else in this class over here. So we can see direct method, and this one is the constructor. So this class, which is named sprite and is extending this component, sorry. Let me scroll up a little bit. This class now has all those this instance fields over here. So we've got an float A, we've got an float B, and so on. and we do not have any methods. So no methods. But we have a constructor, this constructor over here. And this one is initializing all those values. This one, by the way, is super interesting. This looks really ridiculous at the beginning, and we will learn about this later on. So this is a floating point number, and your computer does not store floating point numbers in a way you might think if you haven't heard of floating point numbers before. So this one gets stored in some, really interesting way. We've got a bit which is representing the sign, if it's positive, negative. Then we've got some bits for the mantissa, and then we've got some bits for the exponent. And this is what this strange value is over here. But we do not really have to know this, because we can also take a look at this one, and then we can see, okay, this is the decimal representation of this floating point number. In this case, it's simply 1.0. Whoops. 1.0. Okay, that's just as a notice. We can also look this instruction up, const high 16 v0. And let's do this real quick. It's a little bit off topic, but yeah, let's do this. So I really hope you have bookmarked your Dalvik opcodes. And let me get rid of this one. So we are searching for const high 16. There we go. Puts the 16-bit constant into topmost bits of the register. Sounds complicated, but we are just taking the 16 bits of this value or of this constants and puts into our register. So if you would have a value which is represented by 20 bits, we do not care. We only take the top 16 bits out of this and puts it into this register. So we are losing some decimal values over there. Okay, this was a little bit off topic right now, but if you encounter this, do not be afraid. What I like to do in this way is I go into this and I see, okay, const high 16. So we are putting 16 bits into our v0 register, and we do not care what this one is. So we get rid of this, and there we go. Okay, v0 is 1.0 as a floating point. That's all. That easy. All right. Okay. Yeah, we have cleaned the screen a few times, but nevertheless, let's get back to the Java code, put them side by side and see if we, were correct on this one. I mean, you can go back in the video if I was wrong, but let's see. All right, now they are side by side. I'm also super interested about this because I did not prepare it in this way. I like to do these things, on the fly. Let's see. So we are in DE, fgrvik, spacepang, and then components, and then sprite.smiley. Yes, I would say we were correct. We were correct. We've got only those values over here. We've got this constructor, which is missing. We've got no further methods, and we've also got no static fields. And we can also see our, the things we include. This one over here, and this is this class, our super class we are extending. Nice one. Okay, cool. By the way, if you are interested in this enum types, because let's have a look. There we cannot find this. And this is why we have these annotations. We can now check sprite layer, and within sprite layer we should see a reference to those values, background default effects. Let's have a look. There we go. Okay, let's make this a little bit bigger. Also enable Java once again. Here we go. So again, let's do this once again. I know it might be a little bit boring, but practicing this means learning those stuff. And even if you just watch, you will learn something new. Okay, we do not go that deep into this. We've got our sprite layer. So we've got our inner class, sprite $layer. And now we've got these annotations. We can see our enclosing class is sprite. This is now our main class in this case. And then we've got our inner class. This has some access flags and a name, which is layer. We do not care about those access flags right now. So we've got our name layer. So we've got sprite $layer. And then we can see, okay, this one is now from type inner. If you would have an inner class, this would be referenced here. Okay, and here we can see those labels. So we can see, for example, this one, actors, background, default, effects, overlay. This is how we can identify what we are dealing with. And this is why we have these annotations in our Smiley file. Okay, once again, let's open this Java code side by side. We go into our layer, sprite layer. This one, yes. And here we can see them. Background, actor, default, effects, and so on. Okay, we do not dive into this deeper because this will be a little bit complicated if we take a look into this. So here you can see, okay, this looks interesting. I'm pretty sure if we go this step by step, line by line, we will be able to reverse engineer this part. But we are not doing this right now. We keep these things simple at the beginning and we will increase the tempo later on. All right, that's all for this topic right now. This topic was about the file structure, and we have seen what those lines mean, that we've got separations between those hashtags, and also what this annotation does. During the reverse engineering process of this file, we have seen we understand this file better and better. We get those external references, we get inner classes, and also have a nice separation between instance fields, static fields, private and public methods. Okay, in the next video we take a look at our player.smiley file, the extended version, and we will do a reverse engineering process on this one together once again. And then we will have a quiz where you can practice this on your own. And afterwards we will patch our SpacePang application so that we will not be able to lose this game anymore. Alright, I see you in the next video. Welcome back. Let's do another practice exercise. So I have extended our player smiley file a little bit and now even more, because we already talked about those floating point numbers, so I added one to get also practice on this one. Okay, let's go. Therefore I switched to the Ubuntu VM and I have attached you the file as an APK to download. I've already got this over here in our downloads directory. This one, and I put this into apps, and let's make a new challenge. Practice Smiley. Okay. Let's decompile this with the APK tool. And then we will have a look at the Smiley code, and afterwards I show you the original Java code, and also if you take a look into JADX, what's different. I guess there is something different regarding to optimization of the compiler. But let's see this at the end. First, let's reverse engineer this application. Okay, so we've got this over here, practice Smiley. I'm opening this whole directory once again within Visual Studio Code. There we go. And here we have our player.smiley. We change to Java and we keep clicking these annoying pop-ups. And here we go. I'm going to make a screenshot of this, put it on my graphic tablet, and then we will analyze it there. So I see you in a few seconds. All right, here we've got this file right now, and you can see this file is massive. But we do this step by step, and we go through this each instruction after each other. We also include what we've learned in the last video. Therefore, we do not dive into a method over here. We start at the beginning of this file. And by going through this file, we will reconstruct the Java source code out of the Smiley code over here. Therefore, let's go. What do we have here? We've got our class public, and then we've got this capital L, which means we've got a class reference. This reference ends at the semicolon over here, which means we've got a class named player. Let's write this down. Class player. All right, then we've got the superclass over here. The superclass is Java Lang object. This means our player class is a subclass from Java Lang object, but we are not extending a certain special class over here. This means we are already at the end regarding to the class definition. I guess I wait with the end because we might scroll down a little bit. All right. So we also get this one, and this one is simply just the name player.java of the file. So this was the header, not that hard. All right? Okay, then let me choose a different color and we make our way through this one. we've got our hashtag over here, which means we've got a new separator. In this case, static fields. So now we've got our static fields for this class. And we only have one static field because here at the end, we already have a new separator regarding to the instance fields. Okay, let's see what static field we've got. We've got public static lives. This is the label. So our static field is lives, and lives is from type integer. Okay, we can simply write this down exactly the same way. So we write this down as public static int, and then we have lives. All right, we can see no register, no initialization value. So simply just this public static int lives. Okay, next, let's have a look over here. Here we have now our instance fields. And we've got two instance fields. One is power and one is shield. Power is from type integer and shield is from type? Correct, Boolean. Also, let's add these information. So we've got int power and we also got Boolean shield. All right, then we get to this one. These are all our instance fields. Next, we've got the direct methods, which means we've got constructors and private methods. In this case, we skip this because this constructor contains some object references and we didn't talk about this one yet. We will learn this in a few sections, but for now, let's skip this because I guess we still got lots of stuff to do. Okay, so these are our private methods. We do not have a private method. We only have this constructor, but we skip this. Okay, then I need to scroll down a little bit. Let's do it this way that we can still see our instance fields and yeah, therefore we just add our code now underneath. Okay, what do we have right here? We've got now our virtual methods, which means we've got now our public methods. Our public method is named add power. So we've got a public method add power. Add power. This method add power has now 3 parameters. New color, this one. We've got 1, 2, 3. All from the type integer. Okay, but now let's stick to the register labels. So in this case, we are using P1, P2, and P3. We know our P0 is reference for this object. Therefore, our parameters start with P1. And by keeping or sticking to the register labels, we do not have to look things up in the code. Therefore, we can execute each line after each other like the CPU does. Regarding to the parameters, yeah, of course, we already got them here. But regarding to the local variables or local registers, we would have to look them up if we want to address those labels immediately. And this is something we do not want to do. My approach when I do my Smiley reverse engineering is I go through this each line after each other. And yeah, let's try this out here. All right, so we've got 3 parameters, all type integer. So our first one is int p1. Next one is int p2. And then we've got int p3. Okay, and we can also see this one over here. We've got the return type from type D. Do you still know what this capital D is? Correct, it's double. So we are returning a double value here. All right, we already got our function definition over here based on 1 line of Smiley. Isn't this amazing? It absolutely is. All right, now we've got this locals 5. And this is exactly what I was talking about. In our case right now, we just take as node, we've got 5 local registers. 5 local regs, which means we've got register from V0, V1, V2, V3, and also V4. because we start counting with v0. We do not do this in the parameter tabs because p0 is a special register reserved for the this object. All right, so we got this line also. We also got these, and yeah, if we want to, we can address those labels here. So we can say P1 is A, P2 is B, and P3 is factor B, and this one here is factor. Okay, let's do it in this way. So then we've got this one, and this one. Now we've got our first real Smiley instruction. Yes, I would call this way. So we've got const /for v0 0x0. Do you still know what this instruction does? So this instruction stores the value 0 into v0, but it only stores 4 bits of this value in v0. In our case, it doesn't matter because 4 bits of 0, 1, 2, 3, 4 is still equal 0. But we are limited to 4 bits. In this case, we cannot store a value, for example, like 20 in this way. We would have to adjust this const over here, this /4, to something like const /16 or remove this part 4 if you want to override or patch this application, this instruction here. Okay? All right. For now, let's get rid of this one. So there we go. And we simply write this down, what this instruction do. We've got v0 is now equals 0. Okay, next one, we've got this over here. And here we can see the register, this v0, is now being addressed as a variable. And this variable is named sum, and it's from type integer. Okay, we make this node over here. So we've got a sum, let me clean this up real quick. So, all right. So we've got sum from type integer. So we've got int sum, and sum is equals 0 based on this instruction before, this one over here. All right, and by doing this, we do not have to look this up first. So we go through this each instruction after each other. Slowly progress through the Smiley method over here. Okay, and this is the approach I like to do. So go through this instruction after each other. And therefore we stick to those registers over here. And we take notes of the Java code on the right. All right. Next, we've got this const -white v1. Then we've got this really strange looking value, but we also got this hint over here. So we do not know what const -white does. And this is something we have to look this up. Regarding to the first section, we know this value gets stored in v1. This value gets stored in v1 over here, in this register. And this value is represented by this strange hex representation. This is a floating point number, and therefore, yeah, we have our signed bit, we have our mantisse, and we have our exponent. We do not care about this because we've got the value right here. But what does const -white do? Because this is important that we look up instruction where we are not sure what they are doing. This might affect our result in this register later on. So let's have a look. Therefore, we go into our Ubuntu VM. And I really hope you have bookmarked your Dalvik opcodes page. So let's see, const -white. And put the integer constant into vx and vx plus 1 registers, expanding the integer constants into a long constant. All right. What this does is, let me check something quick. Okay, we have to take care. Let's see. We've got this lit 16. In our case, we've got a const value. Let's see. Do we have other const byte instruction? No, okay. So let's get back. And yes, okay. It's within the description. There we get this crystal clear. So we've got const -white v2, and then we've got our long variable over here, or our double variable in our case. And here we can see we are putting 64 bits into vx, because otherwise we would have this -32 declaration at our instruction over there. Okay, so now we know we are definitely putting 64 bits into our register VX. In this case, it's V1. There we go. All right, so let me clear this up a little bit. So, okay. So we can make this as a node. 64-bit, at least this value here, into our register V1. Okay, let's write this down. V1 is equals 2.3, and we do not care about this one over here. And okay, yeah, that's all we know for this instruction over here. And the next one, we can now see, okay, we've got V1, and V1 is now also a variable named bias, and it's from type double. So we've got a double bias, and this one is 2.3. So we also got these two. Then we've got our add_int instruction over here. Add_int. And what add_int does is it takes P1, adds it to P2, and stores the result into V3. So we've got a V3 is equals P1 plus P2. And here we can see we haven't used V3 yet. Therefore, let's keep this open for now. Next, we can see V3 is still not referenced as a variable. But we do not care about this because we go through this code each instruction after each other. Therefore, if V3 is never being assigned to a variable, we do not care. We are just interested in the value or the command over here, what this instruction does. And in this case, we know we are adding A plus B and store this into V3 in this register. And this is why I like keeping the approach or sticking to those register values. You do not have to bother about, oh, does it now become a variable or not? Might it be? Might it not be? Who knows? We don't care. Okay? So let's scroll down a little bit and move on in the code. What we've got here, we've got now mul-int, and yeah, this instruction is new. It's pretty clear what this instruction do, but anyway, let's look it up, because then we can be sure and we do not make dumb mistakes where we have assumed that this instruction is doing the following thing and at the end it does something else, something different. Okay, so let's look this up real quick. I mean, it's super fast. Okay, if you have your to type your password, it takes a little bit longer, but it's still super fast. So we're looking for multiply int, this one over here. Multiplies, we set with wy and puts the result into vx. Oh, I think I have encountered something. Yes, this one over here seems to be a mistake. This seems to be a typo. I would assume this might be vy. But nevertheless, this website is amazing. Okay, let's write this down. So we've got vx equals, then we've got vy multiplied by vz. Regarding to a multiplication, I guess regarding to the arithmetic operation, yes, it doesn't make a difference if we multiply this with this or vice versa. So if we swap those parameters, this doesn't really matter. But I'm pretty sure it should be in this order. Let's see what we've got here. Yes, okay. Here we also got this typo. And yeah, we do a multiplication from two registers and store the result into vx. All right. That's what this instruction does. And good that we looked this up, because then we realized there's a little bit of a typo over here. So let's get back. Okay, we are multiplying v3 with p3 and we store this result back in v3. Let's write this down. So I'm gonna make a slight note where we are in this code over here. v3 is equals v3 multiplied by p3. We can now also do some fancy math and replace v3 over here with this, but yeah, let's do not do this. So we do this each instruction after each other and we execute and insert our values later on in the exact same way, okay? So please do not try some math operations and get rid of parameters or values. All right. So next, what do we have? We've got end local v0. This is interesting. I guess I also didn't recognize this variable in this way right now. But this seems to be the end of v0. So we are not using v0 at this point anymore. Nice. And for me also super interesting. What's also nice, we can see this register v3 gets now reused. We get now v3 aligned to sum. Super interesting. And we also see this integer type over here. So of course we do still have our int sum, but now our v3 is going to be referenced with sum. Okay, and at least at this point, I mean, I didn't prepare it in this way, but it's nice to see it over here. But at least at this point, I would be super confused if we stick to those variable names over here. Regarding to the registers, I mean, we do not care. We move on with our code and we really do not care about if this v3 is now sum or v0 is sum. We're just interested in the values these register holds. And therefore, I really like this approach regarding to sticking to those registers even more. Okay, so let's move on and let's see what we've got. Next, we are adding int lit8. So we know this is 8-bit. And we are adding v3. Nice. We are adding v3 with -1 and we store the result back in v3. So what we've got here is we are not adding two values, we are subtracting values. And I'm not sure why the compiler has chosen this instruction, because there's also an subtract int, I guess. Let's look this up. Yeah, it's just above this instruction over here, subint, calculates vy minus vz. So this might be regarding to compiler optimization. The compiler or the program might be faster if it adds -1 instead of using the sub instruction. Super ridiculous, but okay, this is what the compiler does. It's funny to see this in this way. All right, so let's write this down. v3 is now v3. We can write this as plus -1. And now we have our fancy math operation here. But for me, this is a little bit confusing. So let's do this in a different way. Let's write this as it is. All right. Okay, next we've got a new instruction. Ooh, what might this be? No one knows, I guess. So we've got div-int p1, v3, p2. So you see, with those registers, it's now getting a little bit, let's say, complicated or confusing. But if we insert our values afterwards and go through this step by step, you will see it's not that hard to execute this code afterwards on our paper. So let's see this instruction first. Okay, div-int. There we've got the correct order. Yes, result. All right. So divides vy with vz and puts the result into vx. Let's see, div-int, we've got p1. So we are at this instruction right now. p1 is equals v3 divided by p2. And we can try to insert our labels over here. So let's see. p1, I have to scroll up. p1 is a. a is equals sum, because sum from this point is now in register v3. We can also write this here. Sum is equals sum minus 1. Okay. We were at this point. Sum divided by p2. p2 is b. Okay. Yes. All right, next we've got this instruction, XOR-int. XOR, let's look this up. XOR-int. And here we can see we've got this to address. We are not looking for this one. we are looking for this one. And let's get rid of this. Calculates Vy XORed with Vz and puts the result into Vx. Okay. So we've got V0. V0 is equals V3 XORed with P1. In this case, V0 is now, let's scroll up a little bit. Also interesting, we can see right now we are using V0 as a register. But at this point, we have switched from V0 to V3 for the register or the label sum. And this means we have now a new free register, this one over here. This one is now reassigned and newly reused. So this is a whole new register over here. Therefore, we cannot make a label for this over here. Again, this is why I like sticking to registers and not always try to adjusting those variable names, because in this case we do not have a variable name for this one right now. We know this one is sum and we know this one is A. Was this A? Yes. Okay, so we know this one is sum and this one is XORed with A, but we do not have a label for this one right here. So we have to move on in the code. So the CPU simply executes this command sum XORed with A and stores the result into V0. By the way, if you do not, or if you are not familiar with the XOR instruction, I have attached an own section within the cheat sheet of this course document. So within there, I describe some XOR operations, what XOR does and why it's really useful and helpful to understand XOR. Because XOR is used a lot regarding to cryptographic functions, strange cryptographic functionalities, which are written by the developer itself, and also regarding to assembly, for example, for clearing out registers and things like this. So the instruction itself is not that really complicated, but it's super nice if you understand or if you know about the tricks you can do with XOR to get some cryptographic keys back and things like this. Therefore, please have a look at these slides, and I might be also creating an own bonus section regarding to XOR. All right, please look this up in the material. Also in the bonus video, I'm pretty sure I create this one. And if you have questions anyway, then feel free to write me a message about this, okay? All right. Okay, yes, interesting. So now we've got end local v3. So our sum variable from type integer is now finished on the register v3. It's not anymore holding the sum. This is what this instruction do. And here we can see restart local v0 sum from type integer. So here we can see we are reusing this register v0 as the sum variable. This means v0 becomes sum back again. All right, and at this point we know, okay, this one is also sum, but a little bit different. So this one in this case is some kind of placeholder. So we've got a placeholder for sum, and afterwards we recycle v3. So this register gets recycled. And then we create our sum over here for v0. Okay, if you stick to those labels, it's getting a little bit complicated. Let's clean this up. And let's write this down as the instruction tells us. So we've got this one over here. Okay, this was this part. And then we've got return local v0 to sum. This one is this part. But these are not real instructions, so we do not make progress within our code right now. Until, so we also got this one, yes, until we go into this one, because now we can see int to double v3 v0, okay. So let's check what int to double do. Int to double. converts the integer in Vy into the double in Vx and Vx plus 1. And this Vx plus 1, by the way, this means if the value doesn't fit into one register, we are using 2. So let's say we are using V3, then this will be V3, this Vx. So V3 is Vx, or vice versa, let's say it different, Vx is V3. And then we are also using Vx plus 1, which means we are also using V4, the register. And I guess you can find this, let's see, in the description. Yes, here you can see this plus 1 means we are using 2 registers to store this value. For example, if we have a larger value which is going into a smaller register, then we split this value up into 2 registers, for example. Okay, so what do we have right here? Our instruction says we are converting V3 to V0. Sorry, I have to look this up once again. Converts the integer in Vy. So this one is the integer, 2 and double. Okay. So this one is the integer, and this one is the double afterwards. Yes, this makes sense. Okay. And let's try to write this down. This is a little bit hard. Let's see. So this one is int and this one is double. So we've got V3 is double V0. Okay. And this means V3 is also from type double. But let's not write this over here. Let's write this downwards here. Okay, so this should be, this should be fitting. All right, and then we've got this return byte V3. Let's see if we also find this instruction over here. Return dash byte. Return with double or long result in and so on. Okay, so we are returning V0 and V1 in this register, in these registers, and this is just the return of a double or a long value. So we are returning V3 over here. All right, and this is our code. If we get back on this, so this is the method add power. This is what add power does. And we can now simply insert some values over here. And then we can go through this code over here and check what's the result at this point. Let's see, maybe we do this. Yes, we make this or we do this for the next section. And there I also show you then the Java code. We execute this method with the values we are inserting right here. And then we have a look at the Java code. What the Java code puts as a result out of this function and also what we got out of this function. And yeah, let's take some values already that you can start practicing if you want to. As values, let's see. We take for a 1, 3, 3, 7. Yes, these are our values we are inserting or which we are using to call this method. 1337. 1337. Yes. Let me get rid of this pink. So let's write this once again. 1337. I hope it's working in this way because I didn't check the code regarding to overflows or things like this, but I'm not sure what we are doing with B. So B is P2. Let's check this code really quick. We've got P2 over here. We are dividing, okay. So therefore, if B would be 0, this would be bad because we cannot divide by 0. Yes, but the rest looks fine. Okay. Yeah, so this seems to be a nice exercise. And before we do this, let's step back a little bit, take a look at the picture and see what we've done. We have reversed a more complex Java code based on Smali. So we reconstructed the Java code out of this. And this is pretty amazing in my opinion, because we already start learning Smiley and we can already resolve complexer method names or method tasks over here. So in my opinion, I'm super impressed where we are at this moment right now. And I hope you feel the same. Otherwise, don't be worried, we increase the tempo later on, so we will do even more fancy and advanced stuff. But for now, let's enjoy this moment and insert those values, some kind of exercise work, and afterwards we go through this together. Have fun and I will see you in the next video. Welcome back. In the last video we have suddenly reverse engineered a more complex function. And now we want to insert real values. Afterwards we adjust our Java code and we will execute this function with these values and we will figure out if we have reverse engineered this function correctly. I didn't prepare this in this way, so I'm also super excited if this works out. So let's have a look. Okay, here we have our code. This is a more clean version of the code we have reverse engineered in the last video. It's the same code, but it's a little bit more clean. I try to improve my writing style that it does not get that messy in the future, okay? Alright, so we also have chosen some certain values for those registers. I mean, we just can influence these parameters. All other values will be calculated by itself. So let's see. We've got P1, which is 1, P2 is 3, and P3 is 7. We are now going to emulate this function and execute this with these 3 values. And then we will figure out the return value over here. And afterwards we execute this function in our Android app and see if these values are equal. If this is the case, then congratulations. We have reverse engineered our first more complex Smiley application. I haven't prepared this, so I'm also a little bit excited on how good this goes right now. Let's have a look. Okay, so V0 is at this point 0. That's okay for us. V1 is at this point 2.3. Alright, now we've got V3, and V3 is now P1 plus P2. 1 plus 33. 1 plus 33. Okay, this means we've got 34. Alright, so let's see. We've got now V3, and V3 is 34 multiplied with 7. Alright, this might take a while. I will see you in a few seconds. Oh, never mind. So do not care about this one. Okay, so I have calculated V3 and V3 is 238. Was not that hard, to be honest. Alright, next we've got V3 and this one is now 238 minus 1. Let's see, yes, we can do this, 237. Alright, then we've got this one over here. Let's see, P1, which is 1. But it seems to simply get overwritten at this case. Okay, so we are not using this 1 over here. Then we've got V3 divided by P2. So we overwrite P1 over here with 200, no, what's V3? V3 is 237, that's correct. Divided by 33. All right, so give me just a second, I will do this again real quickly, just in my mind, and then we will come back. All right? Okay. For this case, I had to use the calculator, but so we could have done this on our own, but it's a little bit faster. So, okay, what do we have? We've got 7, 18, 18, 18, whatever. Okay, so P1 is, different. 7, 18, 18, 18, and I guess 2. I guess we shouldn't that be accurate on this one. Alright, then we've got V0. V0 was 0, we haven't used V0 so far. Okay, so we are reusing V0 at this moment. And this means V0 is now V3. V3 is still 237. Oh well, I knew there has this point where something goes wrong. Let's see how 207 XORed with this value, how good this goes. Alright, this needs to be done in our terminal because this will be a little bit messy otherwise. Let's have a look. So let's take this value over here, Python 3. Yes, that's a list, nothing we want to have. All right, we have to use the dot. 237 XORed with this one. Yes, this is not working because we are using an integer and a floating number. I assume that this does not work. Let's see. I would assume, yes, the CPU or the program will execute this statement. It will cut off those floating point numbers. So at this point we cannot use floating point with an XOR. I was pretty curious about this, but maybe if we have two floating point numbers, then we can get the bit representation and we can do the math. But in this case, if we have int and float, then those floating point numbers will be cut off. And this is our result, 234. Okay, so 7.18.18.18.2. But in this case, this will be cut off anyway. So pretty good that we haven't been that accurate on this one before. So it doesn't really matter at this point. Okay, now our V0 is 234. And this will be also the return value over here in form of a double. That's it. Our function will return 234. All right, so we will have a look into this in a moment. But for now, I want to show you something because I struggled at a point a little bit. And this point was this one over here. Why? Because we've got P1 equals something, and P1 is a parameter and we have a value in our parameter, the value 1. So this confused me for a second, but by looking at this code I realized, okay, P1 is now being assigned a new value. This means the value 1 will be overwritten at this point. So we are not using the value 1 in this register anymore further in this code. We can see P1 has been used over here. There we have this value 1, sorry, let's do it this way. And afterwards we are also using it here, but here we are overriding it with this value. V3 divided by P2. So we do not have a statement something like this, 1 equals V3 divided by P2. Because the 1 doesn't matter at this point. We are reassigning this variable or this register over here. So we get a new value into this, and this value will be overwritten. All right. Simply just stick to the code as it is. And then you cannot make a mistake. I mean, okay, this is a really dumb message because you have to know what you're doing there and you also have to know what this instruction means. But if you overthink these functions and you bring on your own intentions on what this instruction does, then we will make mistakes. Therefore, simply just stick to the instruction as they are in each line. And then, we cannot make a mistake. Okay? Okay, so let's look this value up, and otherwise I have to re-record this video and find the error which is in there. I really hope it is correct. So let's see. We've got the return value 234. Let's have a look. Okay, here we are now at the Ubuntu VM back again. We can see the math calculation over here. So let's open Android Studio. Tools, Android Studio, bin bash studio.sh. All right. So the GUI has been finished loaded, and let's have a look in the player code. And this is now super exciting. I will overlay our code with this one over here, that we can see what our reverse engineering approach looks like and how the real code looks like. All right, there we go. This was the function. And this is what the original code looks like. Let's have a look at our code. All right, looks pretty good so far. The only difference might be regarding to the brackets and this multiplication factor. This is done in one line, but I mean, our CPU instruction also splits this up, or the assembly code also splits this up into several instructions. Therefore, Pretty nice, pretty good job. All right, let's execute this code, and then we will know if our manual reverse engineering approach was as successful as our code analysis. Let's have a look. I'm also pretty excited. If I have to re-record this video, and yeah, if we have made an error, of course I will let you know about this. So let's see. We've got our player object already. So yeah, we can simply use player add power. And then we have to insert those parameters 1, 3, 3, 7. All right, and we need to print this value out. So we are using system out once again. Print line player smiley power equals, oops, this way. And we need this bracket at the end. Okay, let's make our connection to the virtual machine, our virtual device. Connect that. Okay, now let's run our application. So we go into run app, and please make sure that we are using the remote configuration. Within edit configurations, we can go into remote, this one over here. And here we have to enter the IP address of our system, and we also need to change the port to 5555. The default port in this config is 5005, but this one is the default ADB port. Okay, after doing this, we can click run and run app. We can also open our ADB logcat output, and yeah, there we go. Okay, one slight mistake. I will be absolutely honest to you. We are returning in double value, therefore we are not returning 234, we are returning 234.0. I guess, okay, to be honest, this was my mistake, okay? So I take the blame for this one. We have to make sure that regarding to the return values, we are also as accurate as possible. I guess, or I'm pretty sure this doesn't make a difference, or it might be. So regarding to type confusion or things like this. So for example, if we have an int and we rely on this, that we are having the number 234, but in real time, we've got the number 234.0, which is double, then we cannot mix them up together later on in our code. So, okay. As already mentioned, I take the blame on me. This was my error. I'm super happy that I do not have to re-record this video right now. And yeah, I'm even more happy that we have successfully reverse engineered a more complex function based in Smiley. So yeah, we didn't look up or even didn't look up the code once. This one over here. And if you take a look at this, this is a pretty amazing job. We are at the beginning of this chapter and we have reverse engineered this function. Okay, so you can really be proud of yourself. And yeah, this is a good point to move on with a little quiz. I mean, this quiz will be now maybe a little bit too easy for you, but nevertheless, we do this quiz and afterwards we patch our SpacePing application. We can now already enable some nice features. And yeah, I'm super excited to do this afterwards. But first, let's have a look at the quiz. All right, I see you there. Welcome back, guys. It's time for the next belt, the orange belt. And this challenge is a lot of fun because now we are getting back into our SpacePing application. So we will apply our patch into a real-world application, into a real-world game right now. We have learned already that much, then we can apply this, even if you're not feeling comfortable to do this right now. So therefore, let me give you some hints. So at the moment we are having 5 lives, and for a player like me, these are way too few to play this game, to reach a level which is comfortable for me right now. Therefore, I would like to increase them. And my hints for you are the following. Simply just use the APK tool to decode this application. Then use your reverse engineering approach to identify the variable, this instance field where these lives are being used, generated, created, something like this. There might be many values out there and you can try different approaches. You can patch them one by one or you can patch all of them at once. Both approaches should work. Do not go too high. Simply just use a value, for example, instead of the value 5, which is the default value, use a value like 6 or 7, because you may encounter some problems in there. Afterwards, save this file, use the APK tool to build this application back again, zip a line and sign it, and then try it out if it works. The last thing I would like to give you on your way right now is the value 5. And this is the default value for our player lives. So maybe it might be useful to search for values like this if you have identified the smiley file which is containing our variable. But think about this, the value 5 might not get stored as a decimal value. It might be hex, who knows, and therefore you might have to look for some additional characters in front of this 5. Alrighty? Perfect. Okay, so now let's go. Let's do this challenge and don't be too afraid. If you cannot solve this, absolutely no problem. We will go through this afterwards step by step. And I will provide you additional hints on points that might be challenging right now. So therefore, at least try to solve this challenge and afterwards we will go through this step by step. Alrighty? Perfect. And therefore, I would suggest let's go. Let's start increasing those player lives to a little bit higher number. Let's say 6 or 7. Don't go too far right now. Just increase them a little bit. And afterwards, you can try going too far. Alrighty, let's go. Welcome back. So this challenge was really not easy. It's a real world application and there's a lot of stuff going on in there. If you have solved this challenge, really congratulations. You definitely deserve your orange belt afterwards. And if you have struggled a little bit, also absolutely no problem. We go through this challenge right now and we do this step by step. You can pause and rewind this video on a certain point and I will also provide you some hints. Maybe you only missed a single piece to solve this challenge. This is why I like to provide these hints, because with this hint you might be able to solve this challenge and it's really just a little hint. So you might have done this if you would have spent several hours or even 1 or 2 days. You will get to this point investing that much time if you start reverse engineering real-world applications, but for this course right now, it shouldn't be necessary. Therefore, it's good to go, take this hint and then try to solve it once again. Okay, so let's have a look. Okay, here we are now at the Ubuntu VM. Let's have a look into the app. So I've put mine into apps, spacebar decompile. And the first thing I like to do is I like to get rid of old projects. Because if we have modified this version in the past and we are patching it now once again, then we might run into trouble. And this happened to me a lot in the past. Therefore, I learned from this and we start with clean projects over here. All right, then we can decompile this one. APK tool D. Whoops, and the spacebar application. We go into this directory and we open the whole Smiley directory within Visual Studio Code. There we go. Okay, now we can minimize this one. This word is really hard for me to pronounce or to say it loud. So we want to reverse engineer this application first, because what is our task? Our task is to patch the player lives from 5 to, let's say, 7, for example. Therefore, we need to identify this in the Java code. Of course, we can do this in the Smiley code, but good luck on this one. So we go one directory back, and I use JADX GUI on this one right now. You can also go for the dex to jar and JD GUI approach, but for me it's now easier to run it in this way. All right, so let's see. We are looking for, so we use the search function over here. The code or the app gets decompiled. Okay, and now we can enable, for example, field and disable all the other fields over here. Field means we are now looking for the variable name. We search for lives or a live. Live would be the better approach because we've got here lives and also the value live somewhere. Okay. Can we sort this? No, never mind. So here we can see we've got player.lives. All right, we also have this default lives and the attribution or the name live seems to be irrelevant. So we are searching for lives. There we go. Now we've got the player game screen and the player class once again. And let's first look into the player class. This looks promising. We've got our player, we've got default lives equals 5, and we've got an instance field also lives equals 5. This has to be our lives value in our program code or in our application. Nevertheless, also take a look into the other one. In this case, it's game screen. And here we can see, all right, protected final int lives equals 3. We do not have 3 lives, therefore we can skip this one. We are starting and having 5 lives, therefore this is definitely not going to be our correct value. It's super interesting, or at least it's strange that we have these many lives attribution or these many lives variables, but yeah, we are having a real world application. So this is what we have to deal with. Okay, so put this side by side now. And then we go into the Smiley class. We've got the EF-JADX spacepan components and we've got our player class. So the EF-JADX spacepan components and this player class over here. I keep clicking these annoying windows and we enable Java. Let's extend this a little bit. Yes, I guess this is good to go. We have talked about this file already in the past, so we are not going through this once again. We can directly see this once over here. Public static final default lives equals 5. So this value needs to be patched, or we want to patch this value to 7. Okay, now we have changed this from 5 to 7. But we've got this one over here also. So we also need to patch this one. We can look into the player code over here and see if we identify this. Yes, we can see this right here. Line 39, let's see. Okay, we've got no line attribution over here. So this one seems to not match over here. This is also good to know. We cannot rely on this one all the time. But for now we can see we are having this value 2 times. 5 here and 5 here. So if we are looking in this code for 0x5 once again, we only have this one left. So this has to be this value. Let's patch this also to 7. That should be, right? Okay, so let's save this file multiple times. Then we can close this. We keep this open. And we build this app back once again. APK tool B. This one over here. Let's see if the build is successful, because if we patch the Smiley code and we make a really hard mistake, then the app won't even build, because the compiler figures out, okay, this will not work and therefore throws an error. In our case, we have built this application, which is a good sign, but this doesn't mean we have applied this patch correct. We can still have some errors on the runtime of this app. So if we are putting values into strange registers and things like this, and on the runtime this happens and does not work, the app crashes. But nevertheless, building an app successful is always a good sign. Okay, so we've got this now within our dist directory. Let's make this a little bit bigger. Okay. And now we are using zip-align-v for this one, and we create a new application which is now zip-aligned on 4 bytes, which is named out APK. Verification successful. Nice. Now we use the APK signer, this command over here, to sign this app. We use the password change it, or at least I have chosen the password change it. There we go. This is our out APK file. Now let's make our connection to our virtual machine. ADB connect. Connected. Nice. Let's get the screen over here. There we go. Let's see. We have an app already installed. And we can try to overwrite this file, or we can simply uninstall it. In my case, I uninstall this, because this is the most clean way of doing these things. So let's see. ADB uninstall def-jadx.spacepan. Yes, the app disappeared. Now we can install our out APK. All right. Let's start this app and see if our patch was successful. The app is loading, that's also good, because we can still have crashes, but for now it's looking promising. We click start and oh, that's bad. At least the app is working, which is a good sign, but we can see we still have 5 lives. Why is this the case? This can have different reasons. The first one is we did fail on our patch. The second one is, this is just a display. So our lives are now really 7, but the display is showing still those lives 5. These might not be synchronized. These might be 2 different type of values. To find this out, we have to die 4 times once again, and if we lose the game, then we didn't really patch this application and the screen was correct on this. And the final case is that we've patched this player lives value, but this one is not going to be used in this code. This code is using a different value. And to find this out, we have to take a look into this code once again, but now a little bit closer. Okay, so let's close this one over here. And let's get back into this code. So let's open this once again. Okay, so we've got these 3 variables, but none of these seems to be our lives value. I mean, this one can be theoretically still be possible, but it starts with a value 3, so I also don't believe in this one that this is the correct value. Now we have to extend our search. We do not look for fields, we are now looking for the real code. And here we can see, okay, we've got our components player. This one is not the correct value because we have patched this from 5 to 7. This one also, we patched this from 5 to 7, no effect. This one is value 3. Yeah, let's skip this for now. If we do not make progress on this, we might come back to this one. But for now, let's skip this. Next, what's this one over here? Entity factory create player info lives equals 5. If we take down a look, this seems to be the last value that gets initialized with 5. So let's have a look. All right, here we have entity create player world, and we can see this code looks like it's creating a player. We've got the position of the player. We can also see the sprite name of the player. And we have also this one over here, player. We are creating here a new player object named info. And this info lives gets now overwritten. Oh, that's the case. Okay. So we have our player.lives, and these player.lives got patched to 7, this one over here. But now when we create this object, it gets overwritten. Therefore our patch did not take place because this 7 gets overwritten at this point with the value 5 back again. That's pretty strange, isn't it? Yes, this is definitely strange, and I'm also not sure what's the reason for this. I guess the developer has created this player class to use it as the intended way, that the developer uses this player.lives as an initial value. But after writing this code part here, the developer has chosen, okay, let's make sure that the player starts with 5 lives. I'm not sure what I have initialized. This might be some thinking process why this could happen in this way. But nevertheless, we have to deal with this. This is also no blaming regarding to the developer. I'm really thankful that we have this amazing app to keep practicing on. And you will encounter this also in tons of other applications. So you do some reverse engineering process, you identify this class over here, this player class, and now you know, or you think, okay, this has to be our value over here. We've got this player has lives, and this lives value is 5. This must be our value. And afterwards you patch this and encounter, it didn't work. Because it's get overwritten here. This is what you encounter a lot. Therefore we have to dig a little bit deeper, or like other people keep saying, we have to try harder. Alright. So let's go into this class and figure out where this value is and try to patch this value. We put the side by side once again. Oh. Okay, yes. We have closed this one, and this was good because we are also cleaning up this version. We have modified this player object over here, this lives and this lives, but we do not want to patch or add an additional patch on top of this right now. If it fails, we can try patching all those values afterwards. But I like doing single task patching, and this is also what I recommend to you, because if you patch 2 or 3 things at the same time and you get an error, you do not know where the error occurs. Therefore you have to go back and do it once again. And by doing this, yes, it's at the beginning slower, but at the end we might be faster. Okay. So let's clear this up once again. Then we use the APK tool D. We go into this directory and we open the Smiley directory within Visual Studio Code. Putting those side by side, Keep clicking those annoying windows. Not yet, okay. DE, FGAPIC, and we are within, let's see, Spacepang services. Services, and then Entity Factory. Okay, now there are those annoying windows. We enable Java. There we go. Okay, and now you might think, wait, what? This file is ridiculous massive. Are we ready for this one yet? So let's step back a little bit, because this is now really massive. But we do this step by step, and we have to remember what we've learned. First of all, click this away. Okay. So we've got the file structure, and the file structure is the same. Let's get rid of the distracting part. So let's go through this real quick. This is our class. We do not extend an additional class. And yeah, this is the file name of this class. Direct method means we are having private methods and constructors. In this case, only this constructor. All right. From this point until the end, we seem to have only public methods. Public static or simply just public methods. Our create player method is public static and returns an entity. Let's try finding this method. And we can do this by searching for create player, for example. Okay. And here we can see method public static create player. This is our return value, Artemis entity. This is correct. This is this one over here. And we provide a world object as a parameter. All right. We have identified our method, and now we only look into this part of the Smiley code. We can delete all the rest, but I do not recommend doing this because we have to add this afterwards and this will be a mess. But if you want to, get rid of the distraction, copy out all this from the beginning, from here, dot method till the end of end method. And then you have sliced this piece of code out and it will be a little bit easier. Okay, I would suggest let's try doing this. So we make a new file. Okay, there we have our create player method. It still looks massive, but let's remember back again to our first Smiley patching approach ever. This might be the single piece that's missing for you if you haven't solved this challenge right now. So let's recap this a little bit. Let's have a look into the code. Okay, we are looking for this one over here. This is our player object info, and this player object has a name or this variable, this instance field lives. We have patched this one, but here it gets overwritten with 5 once again. Now, what can we do to identify this within this code? Yes, we can search, for example, for info, but then we also find all these other info values here. Next, we can do the same approach like we did on our first Smiley patching. We can search for the value 5. The value 5 is not going to be used within this code anymore. So by having this value 5, we might be able to identify this line of code. And then we do not have to understand this line of code. I guess we do. I'm not sure about this one. We will see this later on. But we can do this exactly the same we did in our first Smiley patching. We simply change the hex value out of this. And then we have applied our patch. We build this application back again, sign it, install it, and check it out. Okay? So in case this was your missing piece to solve this challenge right now, I know this challenge was really not easy, because if you try to make your way through this will be super hard. But I have structured this course in a certain way that helps you to solve these further challenges by getting back on this approach we have learned. And this is also the approach that helps you on real-world applications. This is why I have structured this course in this way. So if you couldn't solve this challenge yet, please try this approach right now. And afterwards you feel super great if you have patched this app. Yes, you got a little bit of a hint, but let's do not call this hint. This was just a refresher from what we've learned already, okay? So please pause the video and then you can rewind this after trying this once again. And for all the other people, I will move on right now with the challenge. So let's see. Okay, let me get this back. So we are looking in this method, and now we are looking for the value 5. Not over here, we are looking over here for the value 5. 0x5. We only got one hit. Nice, let's have a look. All right, we've got our local v2 info. Nice, This is now not a variable name, this is now our instance name over here. But who cares? We found our instance. So nice, this one is our player object. Great. This means we are putting here the value 5 into v7, and here we can see v7 gets put back again into v2, which is our player object. I mean, I guess we talked about this, but not in detail. Nevertheless, we do not care about these instructions because this is our value 5, this one over here. Let's patch this. Okay, if we patch this here, it doesn't make sense because we have to patch this over in the real Smiley file. But let's have a look once again here. We can see .line 80. Let's have a look at line 80. Oh, well, nice. We also got the exact line number where we are initializing or overwriting our lives object. We can also navigate using this line 8 number. But please do not rely on this. We have seen this in a few moments before that this is not always accurate. In this case, we are taking this because it seems to fit to our code. We verify if we are really in this line right here by looking up and downwards a little bit. Okay, guys, super nice. Now we can search, for example, for this whole instruction over here. Okay, so we're looking here for, okay. To make this clear, here we have copied out the method, only this create player to get, all this distraction away. And then it's also easier to search for this value 5, because here we can see we are not using this value 5 anymore. Let's close this one, that it's not that confusing. Here we are now at the original Smiley file in this entity factory Smiley. And we have used the string from the ones before to identify this value over here. Now we can patch this to 7. We save this file. I use the shortcut, but to make this sure, okay. And now we can close this and we get back to our process, building this app, signing it, and so on. APK tool B. Okay, let's see if we get build errors. No, that's good. Then we go into this directory. Now in dist, we can see we do not have an out file yet, so we have cleaned this code correctly before. I zoom in a little bit. We are using zip align. Verification successful. Now we have this out APK, which is the zip aligned version of this one. And now we are using the APK signer to sign this app. Change it as my password, and I made a typo. Change it. All right. Now we can install it. adb install out APK. No, not yet. We are uninstalling our first version. Okay. So therefore we use adb uninstall. Yes. And now let's get back the screen copy. Let's see. All right, looks good. adb install out APK. There we go. We start this app. No errors. Super good. Start. Amazing. We have changed the lives from 5 to 7 right now. I mean, this is not a big jump. And this can be also a false positive right now. As already mentioned, we can have our player lives and the lives within our display. To make sure that we have now 7 lives, we need to die 7 times. And if the game ends afterwards, we know our patch has been successful. We can see, okay, life is already increasing. Nice. Super nice. Okay, but this was not the real task. Let's try to modify this value and get our lives up to 999. We close this one. So let's get back to this one. We open the Smiley directory once again with Visual Studio Code. And we directly jump into the last location where we've been. We now know this line 1417 is our player lives. Let's make this 999. The value is this one, 3E7. Okay. Let's save this and build this app once again. Oh, we are getting an error. Let's see. 999 cannot fit into a nibble. Could not smiley file. Okay, interesting error message here. Okay, regarding to this error, what does this mean? We are trying to put the number 999 into a nibble, and a nibble is a 4-bit value, but 999 does not fit into 4 bits. That's absolutely correct. Let's see, why do we have this case over here? So we go back into the Smiley directory with code Smiley. Okay, if you struggled at this point, absolutely no problem, because Smiley is really hard. And if it's the first time for you acting on those registers and think about the space that those registers provide, this is super hard. It also takes time. It took me quite a while to learn this, so please do not get frustrated. Let's think about this together right now. And afterwards you can also pause and rewind this video once again to solve this challenge. What does this line do? We've got const/4 v7 and then our 999. This value did work. But this one right now does not work. So where's the difference? Yes, of course, regarding to the value. But what is the problem here? And therefore we need to fully understand this line. Let's look this up. So I'm opening my web browser. And I'm opening this one. And let's have a look. const-4. Oh yes, absolutely clear right now. Puts the 4-bit constants into VX. Oh well. Don't worry, I made this mistake so often and I still do make this mistake. So this is absolutely no problem if this was your struggle point at this challenge. So now it should be clear. This one -4 only moves 4 bits, but the program now realizes, wait, I've got way more than 4 bits for this value. Therefore, it throws an error because the compiler noticed, oh well, I'm going to throw away a lot of numbers and this might be not intended. Therefore, I do not move on. I rather print this error that the developer can check this once again. Alright, so what can we do? We can check if this value fits into 16 bits. Let's do this. To check this out, we can do a simple math operation. So 2 times 4 means this is the range we have for 4 bits. 16, that's correct. So if we do this on the paper, let's get out the graphic tablet really quick and then we do this together. Okay, here we are now at the graphic tablet. Let's have a look. So 2 square 4 means we are having 4 bits. And 4 bits seems to have the range 16. Let's check this out. So 4 bits means we've got 2 square 0, 2 square 1, 2 square 2, 2 square 3. This means we've got 1, 2, 4, 8. If we add all those values over here, we get the value 15. But we start counting from 0. This means we've got 0 to 15, which means we've got 16 values. Let's find out how many bits we would need to store this value 999. We can do this on the paper. Therefore, we have to extend this schematic over here. So here we have 2 square 4, 2 square 5, 12, 1024, 2048. Alright, at this point we already have enough values to store this value 999. To not always do this on the paper, we can also use Python for this. So within the bin function, we can insert this value 999. And then we can see, okay, these many bits are needed to represent this value 999. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we've got 10 bits. This one over here. Alright, therefore these 4 bits, if we only store these 4 bits in our value, sorry, this was a little bit bad drawing. So if we only store 4 bits into our register, I guess it was V7, but this doesn't really matter, then the program now encounters, oh well, what is happening to those bits? Are you really sure you want to do it in this way? I guess not. Therefore, I throw an error. Okay, so that's the point behind this const/4 and the error message. Let's get back to this one. And now we know, okay, 4 bits are not enough. If we check this, we can use const/16. This will work. If you want to be a nice hacker and also be resource efficient, then we use const/16. In my case, I do not care about those resources. We are just talking about a little bit of bits. Therefore, we use this one, which means we have the full range from 32 bits. Const, and we remove simply this. This means the default value is 32 bits. And now we can save this. We close this one over here. Okay, so then we go into this directory upwards, and let's see if we can now build this application. APK tool B, space ping app. All right, we can see the build has been successful. Great, the error has gone. We cannot rely on this if we successfully patch this application yet, but it seems like to fit the Smiley requirements in our code right now. Nice, let's have a look. So we go into this directory, dist, and here we can see we haven't cleaned this up yet. We now just have to make sure that we are using or that we are deleting the old version and using the new version. So let's get rid of this one. Okay, and now, now we can zip align this one, correct. We sign this application, change it, okay, and then we use adb install out apk. No, we uninstall the original version first. So adb uninstall def space ping, yes, and let's see. Okay, no app available anymore. adb install. That's correct, because we are using the out APK. So you can see you can make a lot of mistakes if you're not absolutely focused on this one. I tried to install this version, which is the build version, but not the signed version. We have signed this app, and this is this one. Okay, so this also happens to me still a lot. Also super annoying things like forgetting to save the Smiley file. Okay, a space ping. And let's see. Still no errors, pretty good sign. Ooh, okay, still no error. There we go, we have 999 lives. Super great. If you have done this, congratulations. So you have already patched a nice mobile game. And this was not that easy, to be honest. If you would have done this at the beginning of this course, this would be overwhelming. But splitting this up in these single steps, we are now able to patch this application. And you know what? You can also change your score over there already. You can find this in the same class. If you want some bonus challenge, go for this. Apply some high score that no one else is able to reach. Okay? So, have fun about this and congratulations. You well deserve your orange belt. Have fun with this, and in the next one we take a look into if blocks. Okay guys, let's talk about if blocks. Let's have a look at the following control flow graph that we have created for our game application. These red and green lines, these are our if statements. Why are these so important? Because they dictate the program flow of our code. Let's have a look at our player lives. We have modified this value from 5 to 999. But if we get hit, we lose a life. And if the lives are equal lower 0, we still lose the game. This decision is one of thousands included in our code. By taking control over the if conditions, we are taking control over the flow graph of our app, and you will be impressed how many cool things we can do with this. In this series, we will learn how if blocks works in Smiley, and we will use this knowledge to modify our game even further. We will also have a look into other real-world applications. For example, we will patch our first routing detection based on an if statement. The last section is regarding to methods and objects, and this is the missing piece to not only take fully control over the application, no, we are also able to insert our own code, and this gives us unlimited power in hacking mobile applications. So I'm super excited about this, and in the next video we directly start with our new topic. So I see you there. Welcome back. Let's have a look into if blocks. We start as always. We take a look at our pseudocode, then we write our own code, and afterwards we analyze our code. So therefore, let's go. Here's our pseudocode, and we've got our player object. This player object has lives, and yeah, we patched this value to 999, which was super amazing. Well done. But next, we've got this collision detection. So our player gets hit by an alien shot, by an alien boss, whatever. The player loses a life. And now there's our if check, our first if statement. If the player has now less than equals 0 lives, we lose the game. Otherwise, the player will respawn and waits until the player gets hit again, or until the player wins the game. So this is our circle, our function code, our flow graph over here. Now we're going to code this, but only on a high level like we've described this over here. And then we create our application and we take a look into the Smiley part. How this control flow works, how these if statements are being prepared in the Smiley code. So let's have a look, let's go. Okay, here we are now at our Ubuntu VM and let's code this application real quick. This time we have to do a little bit more Android app development. But feel free to join me on this, we code this together. But don't worry, you can also just lean back and watch me coding because I will provide you the app afterwards. This is not an app development course, this is an app hacking course. I want to give you some insights in the Android app development that you can do certain things. For example, writing little pieces of code that help you further in analyzing apps or things like this. But yeah, as already mentioned, you can also just lean back on this and watch me coding, okay? Feel free, whatever you like. So let's go. We go into Tools, Android Studio, bin bash studio sh. Alrighty, the IDE is loading. I will see you in a few moments. We are back right now. This was the last project we worked on, the Smiley one, and you successfully reversed this method over here. Congratulations once again to this one. This is really a great thing and you did a good job on this. For now we want to separate them, so we create a new project. We go into File, Close Project. Then we click Create New Project, Empty Activity, and I named this Smiley 2. Language Java, and I go back to Marshmallow, yes. Finish, and this might take a while until the Gradle process has been finished. So I will see you again in a few moments. A few moments later, we are back again. All right. So the first thing we want to do is we want to create our player class. We go into com app hacking smiley 2, right click, new Java class. And we name this player. Oops. All right. Okay, let's give our player some power level. So int power equals 10. Now we need an additional instance field. We need our lives for this player. So we've got 5 lives. All right. Now we need to simulate that our player gets hit. We can do this in 2 ways. We can write a whole application with nice music, fancy animations, and lots of explosions. Or we can do this in the lazy way and simply put in a button, and by pressing this button our player gets hit. I'm going for the lazy hacker approach, the button way. But feel free to code your own application game to simulate this task. It's up to you. So what we're doing is we create a button in our layout, and by pressing this button, the button calls a function, and this function simulates that our player got hit by an object. Let's write this, the method for this. So we've got a public void. We do not need a return value for this. Get hit. I think this describes it in the best way. So if our player gets hit, we lose a life. And this dot lives minus minus. Okay. Now we need to check if the player can still play the game. So if we have more than 0 lives left, if this dot lives is greater than 0, we can move on. Otherwise, we lose the game. Or let's say I lose the game because it wasn't your fault if you get hit. You lost. Okay, let's also make this capital. This looks good. Now we need to introduce a new instance field because we need to put some code in here that doesn't blow this application up and makes it unnecessarily complex. In my case, I choose a Boolean state and we initialize that with true, and we say if the state is equals true, we can move on. Otherwise, the state is false and I lose. All right, so this state is equals false if we lose the game. And here we can set it once again. It wouldn't be necessary, but it doesn't hurt. Okay, this method looks fine for me right now. For you also? Okay, nice to hear. Now we need to place our button in our layout, and we have to do this in the main activity. Because here we have an activity is some screen content, therefore the screen content has a layout. We can find this layout within resources, layout, activity main. So this layout is described by this XML file over here. We can go into code and then we have the XML structure. It looks a little bit complex and overwhelming, I know, but we will do this together. If you are still coding with me, otherwise just lean back and enjoy the show. So here we've got our text field and let's make a change. Let's call this Hello Udemy. If we go back, we can see this text field over here has now changed. Hello Udemy. All right. Let's make this a little bit more, hacking style. So Android background, I provide a new background color. Let's make this black. Background equals and then 0, 0, 0. Okay. If we go back, it's black. As our text, therefore we have no visible text anymore. Let's make this text white. We can choose add color slash white, or we can also put in FF. By the way, let's get back to the add color stuff. So if we choose this one, we can see the text is white, and the add color is our resources.arsc file. So we find this in values, colors, and here we have some defined labels. We can also choose this one, for example, which looks even more hacky. So let's do this. Yes, there we go. This looks now super hacky. Okay, let's increase this text size a little bit. 30 dp. There we go. Okay. All I've done was not really necessary, but it makes the app a little bit more, looking nice to me. So now we go for the real part. Let's introduce let's place our button in there. We can find this in common, button, and we simply drag and drop this in. Now we've got this, this alert. This view is not constrained, which means we have different smartphones with different resolutions. And this button now gets placed anywhere. It depends on which resolution you got, so it's floating around in our layout. And this is something we do not want to have because sometimes this button might be out of our screen and therefore we cannot click this. We want to align this button under our text over here. And we can do this with simply drag and dropping from this point to this point. It's floating around for a moment, but keep clicking, then it will stick to this. Okay, now the button is directly under this, but it's not mentioned where. Is it more left, more right? It's definitely not centered. To center this button, we click on the right side and also drag and drop this over here. And we do this for the left side once again. And now we can be sure, okay, this button is now centered. This constraint layout is, it's not that new, but before it was way harder. So I'm pretty glad they introduced this one. Okay. Let's go back in the code because I do not like if those elements stick that hard together. So Android margin top, 34 dp. dp, by the way, is dip and it's some kind of pixel, but regarding to the resolution. So dip means no matter what, 34 will be 34 on all screen resolutions. It's like pixel in a better way. Okay. There we go. This looks now pretty nice. Let's get back in the main activity. Okay, now we need to connect this button to our method. And this method needs to be defined over here because this method has the knowledge about this button. This button is placed in our activity main layout. Therefore, we cannot use this method over here, getHit directly, because this method does not know that this button exists over here. Okay? So this is our layout file, and here we create now a new method, public void, and simulate collision. Oops. There we go. And here we can now call our player got hit method. Okay, to connect the button to this method, we have to do some Android internal stuff. The first thing we need to do is we need to apply or add this view as a parameter. So we add this view as this parameter, and this view will be later on our button that gets connected to this method. I do not want to go too deep into this because this is not an app development course. I just want to show you these things that you can write your own applications. The approach is always the same. So if you want to simulate or test some things, this can come super handy for you. And yeah, it's a little bit complicated, but we will go through this together right now. So we've got our view over here, and this view is now the button, but the button doesn't know about this right now. So we also have to tell the button that, if we click this one, the button should trigger this method. This has to be done in the activity main. Therefore, we go in the button tag, and here we say Android on click. And now we can use this function over here. Okay, so if we click this button, this method will be called, and this one here is our button that we get, that we get the on-click event listener combined together with this method. Yes, it's a little bit complicated, and this is why I also want to show you this right now. Because if you start with Android app development, this is a little bit tough. In my case, I struggled a lot. Even by simply changing a simple text in our application, this was super hard for me. So we've got our button connected right now. Let's create our player object and call this method. So player, new player. And here we can now call the player got hit, get hit method. Let's change this. Okay. If you press this button, this method gets called, and this method simulates that our player got hit. Oops. All right. This will work, I guess. I didn't test it right now, but I'm pretty sure it does. But we need some kind of visual output for this, otherwise we cannot be sure. And this is where this text field now comes in. If we go back into our activity main, let's close this one, that it's a little bit easier. Let's use this text field over here to display the actual player lives right now. Yes, that's a good idea. Okay, we go into this one and we create a new text view over here. Okay, and this text view needs now to be connected to this one over here. And therefore we go into this one. This has an ID. It's called text view. And now it's like within JavaScript. So we are calling a method that finds this ID, and then we can assign this text view over here to this text view. And then we can use this object to print out the text or make other things. All right, let's do this. We need to do this in the onCreate method because this one is creating our layout. We need to get the reference over here. So text view equals, how do we get this reference right now? There's a method named find view by ID. And here we have to provide a resource ID. This resource ID, in activity main is this one over here. And this one is referenced by the resource class. So to find this, we have to use the resource class .id, and then we've got our IDs in our layout, because this resource class keeps track of our IDs in our layout. We want to have our text view, therefore we click this text view ID. Okay, to be honest, this is also complicated. Yes, but let's do this once again. So we've got our text view over here. This text view is in this layout, and this text view has an ID. We are creating a new text view object And then we are using this object, or we are assigning this object, this text view in our layout. And we can address this with r.id and then the ID of our element we want to address. To be 100% sure, we should typecast this. I'm not sure why there's no error message over here. And I'm also not sure if this is nowadays still common, but when I did start Android app development, we had to typecast this. Okay, now we've got our text view. This is our object and it's connected to our layout text view. We can simply write text view, set text, and now lives. And here we provide our player.lives. That's all right now. This is our Android app development crash course regarding to assigning objects and changing text of text views. It's a little bit off topic, but this can come super handy if you want to play around with this. Therefore, I would like to include it in the course here. Okay, let's build this application. All right, we click locate. Here we have this app. Let's make our ADB connection. Already connected. Okay, let's install this app. And now we get the screen content of our virtual machine. There we have this app, Smiley 2. We started. Hello Udemy. Now we simulate that our player gets hit. Nice. We are only having 4 lives. 3, 2, 1, 0. And we also get negative because we didn't yet do something with our player state value. But that's okay for now. We want to analyze or learn something about if statements, and that's enough to do this. Okay, let's have a quick look into this. And in the next video, we do a deep dive on this if statement. So APK tool D. So here we have the files and we can see we've got a multidexing. This might be regarding to the far backwards compatibility of this application, but this doesn't affect our reverse engineering approach. Our class might be within this or this. I would go for the classes.to first. Classes underscore. Whatever, you know what I mean here. All right, here we've got this app hacking. Let's see. I'm opening this now with Visual Studio Code. Smiley 2, player.smiley, there we go. Here's our class. Let's enable Java. All right, we've got our player class. We've got a superclass Java lang object, our instance fields. We do not care about the constructor. This is our method right now. And here we can see the first new line. If dash less equals 0 maybe, v0 and then this condition. We also have a goto and things like this. In this video, I wanted to show you how you can write simple Android applications that helps you simulating certain tasks. And this can come super handy if you want to play around with smiley functions. It was a little bit off topic regarding to the whole development process, but I guess it's helpful for you. Therefore, I included it in this video right here. Okay, that's all for this video right now. And the next one, we take a deep look into this file. So I'm looking forward to see you there. Welcome back. In the last video, we did some type of prototyping to write a small Android application which can be used to train certain topics. For example, if statements. This bonus video focused on the app development process in Android on a very high level. It can be useful to know these things, but they are not required for this course over here. This course is about Android application hacking, and this is exactly what we are going to do right now. In this video, we simply reverse engineer the application we have written in the last video, and it is therefore not required to watch this bonus video. All that this application is doing is simply just reducing our lives by 1 if we press this button. You will find this APK in the attachment of the section and you can simply download and get into this video right now. Therefore, let's go. Okay, let's have a look into this code over here, because we want to keep practicing Smiley as often as we can. And we do this together right now. So we will go through this together and we will learn new instructions and figure out how the if statement works. Therefore, let's go. So let's see what we've got. We've got our virtual method. This means we are having a public method over here, which is labeled getHit. This is our method name. Let's write this down. GetHit. Okay, we can also see this method does not have any parameters. Nice. We can also see the return type is void, so we are not returning anything. That's also nice. All right. There we have our function prototype. Already done, one line of smiley code. Nice. Next, we've got locals too. This means we are having two local registers, but we do not know if these are variables or placeholder for certain values. We do the top to bottom approach, therefore we go through this instruction after each other. We do not look this up right now, so we just keep this in mind, okay? We've got two local registers, okay. Next we've got I get v0 p0. Okay, we know p0. p0 is a special parameter. This is holding our this object. Okay, let's see what this instruction does. We have faced this many times right now, but anyway, let's look this up to be 100% sure. It also doesn't take that much time. You will see this. So let me switch. There we go. We have our Dalvik opcodes over here. And we simply search for this instruction. I get vx vy field ID reads an instance field into vx. The instance is referenced by vy. Alrighty. We go back. So we've got an instance field over here, and we can find this instance field after this arrow, which means our instance field is lives. We've got this dot lives. This one over here is just regarding to this object that we know it's from the class player. So this is a player object. Okay, so this is what our p0 is holding. And this value gets now put into v0. And let's write this down. v0 is equals this dot lives. Okay. This, or the p0 register, let's say the p0 register is the only one I like to replace. Otherwise, I like to keep sticking to the original register values. So next we've got const /for v1 0x1. We are putting this value into v1. And we are only putting 4 bits because of this /for. But this doesn't matter here because the value 1 is 0, 0, 0, 1. Okay, so let's write this down. What this line does is it initializes the register, our second local register, with the value 1. Alrighty, then we've got sub-int to address, and we only got 2 registers. I mean, it's clear what it does, but anyway, let's look it up to be sure where the result is being stored. Is it here or is it here? And do we subtract this from this or vice versa? If we are not 100% sure, simply just look this up. So we are looking for sub-int. This one has now 3 registers, so we have to add this one. Yes. Okay. Calculates vx minus vy and puts the result into vx. Okay. So we are calculating this minus this, and the result, let's do this minus this, and the result is being put back again into v0. Okay, so we are having v0, let's switch back, is equals v0 minus v1, which means if we replace now our v0 with the reference over here, so v0 is holding our this.lives, this one. This means our v0 is now equals this.lives minus v1, and v1 is 1. So minus 1. Okay, this is what this line over here do regarding to the setup of the registers before. Okay, next we've got I-put v0 p0. So we are putting this value over here into our instance back again, our instance field lives. Anyway, let's have a quick look to be 100% sure. I-put vx puts vx into an instance field. The instance is referenced by vy. Okay, we have to take care. I get reads from right to left, and I put this one reads from left to right. Therefore, we are putting this value now in p0. Here we are fetching the value from p0 into v0. So if you're not 100%, okay, you get this point. All right. So let's see. This means we are having P0. And this dot lives is now equals V0. And V0 is this dot lives minus 1. So at this point we are just reducing 1 or subtracting 1 from this dot lives. Okay, let's put an input that we know. This is not an instruction, it's just a reminder for us that we are subtracting 1 from this dot lives. Okay, now finally we've got our if statement. Let's have a look. Let's put a dramatic color for this on. So we've got if dash less, maybe less equal, and then this one is 0, maybe. V0, and then we've got this one. This looks strange over here. All right, let's have a look into this. So we look this instruction up first. If dash less equals yes. Okay. Let me scroll down. There we go. Checks Vx and jumps if Vx is less or equal. We've got 0 squared 2, but having an 0 squared anything is still 0. So I'm not sure why it's pointed out in this strange way over here, but this means if Vx is less or equal 0. And afterwards we jump, and we jump to this one over here, the target. Here we can see an example. If less equals 0, V0, okay. And then we jump to this one over here. Jumps to the current position plus this offset. All right. This looks even more strange in my opinion. So let's get back to our code, that we do not get too confused. Okay, the first thing we need to do is you need to read this out loud, and we need to read this in the following way. The first one is if V0. That's the first read. And then the second read is less equals 0, then jump to condition 0. Okay, if you read this out loud in this way, we can write it also down in the exact same way. Let's do this. If V0 is less equals 0, then we jump to condition 0. All right, let's clean this up real quick. Okay, let's find this condition 0 right now. So we've got a colon condition underscore 0. Let's scan. Scan. There we go. Here we have this one over here. Okay, so if this condition is true, we jump from this one to this one over here. We move on at this part in the code. And this is super amazing because this is now our branch. We're having our code, and this code has some branch, true and false. And yeah, by going to the one branch, we are skipping the part of the other code. And this is what we are doing right here. We are skipping this code over here right now. We have to move on in the code. Maybe we will come back to this one. But for now, we are just skipping it, okay? All right, so this is also our true condition. Let's put this true. So if this statement is true, which means this is our true condition. Okay, then we move on over here. Let's see what we're doing afterwards. So we've got our if statement, and now we are putting the value 0 into V0. Okay, so V0 is equals 0. And now we've got an input boolean. This is interesting because our value 0 can have multiple meanings. It can have or can be used as the number 0 or as a boolean statement. A boolean statement or a boolean state is, for example, true or false, these two states. And in this case, we are having a 0, which means a 0 is the state false. So these values can have multiple meanings in this case. Okay, And then we are putting this false back into our this object. And what kind of this object? We will find this after the error here. It's the this.state. So we've got a this.state instance field. And we can also see this over here. This.state is from type Boolean, which makes sense because we are putting a Boolean into this. Okay, this means we've got our this.state is now equals v0, which means our this.state is now equals false, because our 0 is a Boolean value and it's false. Okay, alrighty. Let's get back to green. What's going on right here? Then we've got this one. Let's mark this really quick. So we got this one. We also got this one. This is just a line number. So yeah, regarding to our Java code. And then we've got this goto over here. This looks interesting because this is the second condition. If we have a goto starting with those colons over here, in this case, goto 0, we can skip this. This is really important because I also struggle a lot at this point. If you later on patch some code and then you came across this instruction, you're thinking about, oh well, now what I have to do, do I have to jump or can I just leave it? Do I have to delete it? The rule of this is if we've gotten colon and then afterwards a goto, we can simply skip this. This will be ignored. So we just go over through this instruction here. Hey, it's me from the future. Within my quality assurance, I stumble across this one over here. And yeah, you know what? We can make this a lot easier. It does of course not only affect gotos. So we can keep the following rule in mind. If we are having a colon and afterwards our label, this is a label where someone else in the program is referred to. So we can simply skip this one. But if you're having an instruction and condition, something like this in front of our semicolon, then we have to investigate this because this is a decision which is being made and afterwards we are taking this jump or not. So this instruction cannot be simply skipped. And to summarize this real quick, having a line starting with a colon, this is just the jump reference, we are ignoring this. But having an instruction in front of our colon, then we need to consider this. So we cannot simply skip this. We have to find out what's going on over there and then if we take this jump or not. Alrighty? Perfect. Okay, and afterwards we return from our function. So we also understand this one and this one. Return afterwards. Alright. Okay, this is our if statement true. It looks a little bit messy, but yeah. We introduced some new commands over here or new instructions. We've got our if, which makes a statement and condition. If v0 is less equals 0, that's what the set over here means, the comparison against 0, then we jump to this condition. So this is our true statement. Okay, let's clean this up before it's getting even more messy. Okay, now we have discussed our true statement, but we also have a false case. Therefore, let's have a look how the code looks like regarding to the false, or in this case, the else case. Let's have a look. So we start reading this once again. We say this loud to ourselves. We say, if v0 is less equals 0, then jump to this condition. But now we do not jump to this condition because we are assuming we have a false state. Alright, regarding to the false state, we simply move on in the code line. So we are now right here. This means line 22. Yeah, and line 22, this is just our Java reference. So nothing special about this one. Then we've got our output Boolean once again. Interesting, let's see. We are putting now v1 into p0. And it's again, p0 is our this. And here we are having the instance field of this, which is state from type Boolean. So we can simply write our code here on. So what do we have right here? We've got this dot state is now equals v1. And this is why I like keeping those registers, because we can now look up our code, what was v1 the last time. In this case, we can see this one over here. Afterwards, we subtracted this one, but we didn't reassign this. Therefore, yeah, the value is still the same. And here we can see, okay, we didn't use it further. This means our v1 is holding this value over here. And now we are putting a boolean into this state, which means we are putting the value 1, which means the state true in our this.state. So this.state is now equals true based on this one. Okay, so we also got this one over here. All right, now we've gotten goto. Let's mark this different. Some purple color. All right. We have now here our jump instruction, because otherwise we would go on in this code over here, and this is this code over here. So the goto at the beginning signals afterwards there's a label, and we jump to this label right now. And this is the difference between this goto and this goto. This one has this goto in front and then this colon goto underscore 0. So in this case, we are looking for this label over here, and we find this at this line. This means we are jumping from this one over here to this one. Okay, I guess you cannot read this anymore, therefore let's clean this up real quick. So we are jumping from this to this. Way better. This automatically means we are skipping the following part. This, and this. All right, and what is this part? This part is exactly what's in here. And therefore it's good that we've skipped this, otherwise we would interfere with this code over here, okay? So some rules we have to mention. We've gotten if dash less equals 0, then we've gotten condition afterwards, which is a label. If the statement is true, we jump to this label. In this case, it would be here. If the statement is false, we simply move on with our code until we reach this goto. It doesn't have to be in goto. For example, we could also leave the function right now and there might be no goto in there. That's also possible. But if we reach this goto, then we have to check the label behind this goto. In this case, it's starting with a colon, and then, yeah, most of the time, I guess every time, it's having this goto underscore 102 and so on. And then we have to look in our code for this goto label. And then we jump to this one over here. And by doing this, we are skipping some code, which is intended. And then we move on simply right here. So now we've got return void. Let's see. Okay. So afterwards, we are returning out of this function. And this is what the code looks like. And this is super interesting, isn't it? Because if you take a close look onto this, maybe you figure out something. I will give you some moments, and yeah, I will come back afterwards. Let's have a look into this code and see if there's something strange going on. A few moments later, let's create some space first. So let's get rid of this one. All right. And now, can you still remember how the Java code did look like? Yes, interesting, isn't this? Our Java code was looking like this. So we've got our if, then we've got this.lives is greater than 0. I'm pretty sure this was what our Java code looks like. So did we make a mistake over here? Did we do something wrong? Absolutely not. We did interpret this code absolutely correctly. We go through this line by line, and this one is the correct code extracted from the Smiley part. So now's the question, do we get the same result? It would be ridiculous if not, right? Let's have a look. So in our case, in our Java code, we have this.lives greater 0, then move on. Otherwise, we lose the game. Let's see. Now we've got if v0 is less equals 0. Okay, this means we are having we are not having any lives left, right? Because this is what we get if we are having 0 or less than 0 lives. Then we have this statement over here. Interestingly, that's correct. We are putting our this.state into a false mode. This was exactly the part we got in our Java code in the else case. And here we've got, okay, this means we are having more than 0 lives. This part over here. And here we can see, yes, we can move on with the game because we have our this state equals true. Okay, so now is the question, why is the compiler doing this? Well, this might be regarding to compiler optimization. For the computer, it might be faster to calculate if we've got less or equals 0 lives than calculating if we've got more than 0 lives. And this is why the compiler has chosen to build this code in this instruction over here, in this way. And in my opinion, this is really amazing. Why? Because we are even more or even closer to the original part than the Java code. Because here we can see what's going to be executed. We are not checking if the value is greater than 0. No, we are checking if the value is less than 0. And then we go into this instruction over here. Otherwise, we move on this part here. And in my opinion, I find this super amazing because we are more exact than the Java code. Ridiculous if we check out the Smiley code over here. Okay, so you see I'm super hyped up about this. And the first time I was really confused because I thought, okay, there must be a mistake over here. Then I checked the code and I realized, wait, what? This is exactly the same code, but a little bit different. Just in a different order, but still correct the result. And this was absolutely mind-blowing for me. Okay, beside all my hype right now, let's get back to the if statements. What have we learned? Therefore, let's clean this up real quick. So, okay, if we get to an if statement, we have several points to consider. First of all, we have to check what's the statement. We read it in the following way. If v0 less than equals 0, go to this condition. This is our true statement. Then we ignored the rest of this and we jump to this condition or this label over here. This one. Therefore, this code will be ignored for now. We simply move on, and if we encounter an goto starting with a colon over here, we simply ignore this because this is not regarding to our instruction. Okay, then we have to do this once again regarding to the false statement. And within the false statement, we ignore this target over here and we simply move on with our code until we get to an goto and this label afterwards. Then we jump to this label and we move on this part right here. This means we are ignoring all the rest. All right. I know, if I look at this picture over here, it might be a little bit confusing, but don't worry. We go through this several times. We will also take a look into some slides and we will keep practicing a lot because this time we are only comparing against a 0 value. There's also an additional if case if we've got two register values. Something like if v0 is greater than v1, for example. Then we get an additional register over here, but we will learn this later on. For now, we just focus on the comparison against 0, and then we simply introduce a new register into this and the rest keeps the same. Okay, that's all for this video right now. In the next one, we do the same approach, but on our slides, which looks a little bit more clean. And we will go through this further and further. If you've got some questions, feel free to write me, of course, but maybe they might be also clarified in the next videos, because we will keep practicing this over and over again. If statements are super important, and therefore let's move on in the next video. Welcome back. In the last video, we took a deep dive into the Smiley code and figured out how these if statements work. Now we will recap this knowledge and also move on regarding to other instructions. And we directly start with our huge table over here. There we go. Okay, this one looks a little bit complicated. Let's discuss this. So what do we have here? We have our comparison, our if statement. And we got on the left the syntax and on the right the description. And in the middle, this is how you say this out loud. And if you do this, you will recognize or even know what this if statement does. For example, if you take a look at the last line, if less equals 0, means we are comparing Vx against the value 0 and we check if it's less than equal. Okay, to be honest, the last 4 I also look up sometimes because I'm not sure if the 0 is now included or not. Therefore, let's go to the first 2. There we have if equal 0. So if Vx is equal 0, not equal 0, less than 0, and so on. It looks super dumb, but say this out loud if you're watching this, or maybe if you're alone in a room and keep practicing. So this will help you a lot in recognizing what this if statement does. Okay, if we are only having one register, the Vx register, we are comparing against 0, sometimes including, sometimes not. All right? Okay. And afterwards there's this target, this label where we jump to. This is the true statement. Otherwise, if our statement is false, we move on in the code. But we will have a look into this also. Okay, here we have the instruction and say it out loud, then you realize or recognize what it does. And we have to read it in the following way. If v0 is greater equals 0, then we jump to condition 0. I know it looks dumb, but if you keep doing this, these if statements will be no problem for you. Okay, and this is what we get here. If v0 greater equals 0, then jump to condition 0. All right. This is our, let's say, schema on this. We've got an if statement, then we've got the comparison, we've got our register, and we've got the 2 jump conditions. One is our condition, which is directly after this if statement, if the statement is true. And then we also got those go-tos. And regarding to the go-tos, please try to recognize this, that we've gotten go-to in front of this and afterwards the label. If we are encountering only our colon and then this label, we can simply ignore or skip this function. If you do some smiley patching afterwards or later in this course, you will get through this or come over this go-to label a lot. And in my case, I struggled a little bit after I just memorized, okay, we need to have a go-to in front of this, otherwise it's just a jump instruction where we end here and we can ignore this. Alrighty. Next we've got 2 registers, so the tempo is increasing, you see this already. But this is absolutely the same as before. Instead of 0, we are having now 2 registers. So I mark this in this way. And we also keep the saying in the same way. So in this case, we are comparing, or in the first line, we are comparing if Vx is equals Vy. In the next one, we check if these are not equal, less than, greater equal, and so on. So if we are having 2 registers, we are comparing against another register, not the value 0. Okay, the register can have the value 0, but nevertheless, it would be compared against this register. Okay, let's see how we would say this out loud. So let's go. We've got if, then we've got v0, and now we get back to the condition. Once again, exactly the same. So I guess I should stop talking during this. And let's do it once again. If v0 is greater than v1, we jump to this condition. Okay? So if we are having 2 registers, we do it in this way. And this will give us the following statement, and this is correct. So if v0 is greater than v1, we jump to this condition. Otherwise, we go on or we move on in our code. And maybe there's a go-to label, or maybe the function is returning in there. We do not have, or it's not required to have a go-to label. This is also important to keep in mind. All right, there we go, exactly the same. If this time we do not have the value 0, therefore we are only having equal, not equal, less or greater, and our registers and the conditions where we jump to. So these are exactly the same, beside the fact that we are having another register and not comparing against the value 0. All right, last time it was a little bit messy. Let's see if this approach is easier for you to handle. So let's see. We've got our method collision. It's returning void, and on the left side we've got the Java code. So we've got a local register. We do not know if it's a variable or a placeholder for a value. In the first line we can see, or sorry, in the line 38 we can see we are getting, or yeah, we are fetching this object, this.lives, and putting it into v0. Then we make our comparison. So say this out loud. If v0 is greater equals 0, we jump to condition 0. Condition 0 is over here, so we skip this part, this code underneath, until we get to this condition. Then we are adding and -1, which means we are subtracting a value, so pretty ridiculous, but never mind. And then we are putting this value back again into our lives. So we are subtracting 1 from our lives. Okay, this is our true statement. In case it's a false statement, we are moving on until we hit this goto label, and then we move on to the goto label. By the way, at the first time I forgot to mention that we skipped this goto in line 56. But yeah, you should be familiar with this. All right? Okay, and let's do the comparison regarding to the code on the left. Interesting. Our if statement is different. We are comparing if this lives is less than 0. But on the right in our smiley code, we have a condition vice versa. We talked about this in the video, and again, we have it the same way right now. Then we can see our v0 is going to be initialized with 1, and this 1 is going to be put or referenced with the variable named loose. So we are putting 1 into our loose, which is from type boolean. This means loose is equals true at this line over here. Okay, this is our blue part. All right, and these are our two cases. The first one, if our if statement above is true, we are subtracting 1 live from our player.lives and we return out. We skip this goto and return out. And if our statement in line 40 is false, then we move on and we set our variable name loose to the value true. And yeah, that's it. Afterwards, we go to this label and return out of this function. All right. If we do this on the smiley part, we can see this over here. This is what it looks like. And we can see once again, the smiley part is different regarding to the Java part. And it's also what's Android telling us or reminding us. Therefore, do not stick to the Java code regarding to if statements. Have a look at this, but these might be different in the smiley part. And the smiley part is the one that matters, because this is the one that's getting executed and the one we can patch. Okay? Therefore, try to understand the if statement first and then try to apply your patch. And do not try guessing with line numbers or things like this. I tried this and it didn't go that well. So you will lose a lot of time and you get a little bit frustrating. Therefore, try to do a clean reverse engineering approach on the if statement you want to patch. Then you're good to go and you will lose less time. All right? Okay, next we want to keep practicing, because this is the most important part if you want to learn Smiley. Therefore, I extend our code in our Java app and I will provide this afterwards to you. We do not look up the source code of the Java part because this might be even more confusing regarding to if statements. We do our approach once again on the Smiley part, and by doing this we will also recap all the stuff. We will introduce maybe new if statements we haven't seen right now, at least in the table, and things like this. So we keep practicing, and by doing this over and over again, you will become a Smiley master after this chapter. Believe me, you will be able to read and write fancy, nice Smiley code. Okay, the practicing part will be in the next video, and this was some kind of spoiler for this. Therefore, I'm looking forward to see you there. Okay, let's have a look into this. By the way, I already marked those if conditions over there to make it a little bit more easier to follow afterwards. Alright, so we've got our method, check high score. We've got a parameter, we've got this capital L, which means we've got a class reference, and the class reference is player. But this time it's from Smiley1, but do not get distracted by this. The player class looks pretty identical to what we have seen in the last video. And then we are returning in void. Okay, then we've got two local variables. Can be placeholder, can be certain values. We do not know this right now. Here we get our label for our parameter, p1. So we've got an object from the class player, and this object is named player. Let's write this down. p1 is our object and its player. And then we've got iGet, which means we are putting an instance field from p1 into v0. Our instance field is player.score from type integer. And this is now going to be put into v0. Let's put it down. All right, next we've got an instance field once again, but this time into v1. Let's see. p1 is also now an instance field, and it's referenced by player.highscore from type integer. And this is going to be put into v1. All right, this looks pretty identical as the last example, but now it's different. So what do we have here? We've got an if statement. If v0 is greater equal v1, we jump to this condition over here. Let's write this down. If v0 is greater equal v1, then we jump to this condition over here. And here we have directly afterwards again another if statement. So in this case we are having if v0 is less equal v1. We jump to this condition. Okay, if v0 is less than equal v1, we jump to this condition. Let's see. We jump down here and then we are simply returning void. So we're getting out of this function. All right, that was okay, I guess. Okay, this is for the true statements for both if statements. Let's go backwards slowly. So we go into line 18 in this one, and now we are doing the same for the false statement. So if v0 is less or equal v1, we jump to this condition. This is the true part. Now we assume it's false. Therefore, we move on directly underneath. We've got this reference in our Java code, line 41, okay? And now we can see, okay, we are putting this value into an instance field. But now it's interesting because we do not have p1 at this point. We are having p0. And we can see com AppHacking smiley1 player. So this time we are using not this object, we are using the this part. So this means p0 this.highscore. So let's do this step by step. The first part is we introduce our else case for this one. Okay. And now we are putting v0 into p0. p0 is this.highscore, and yeah, we are putting v0 into this. This means this.highscore is equals v0, and v0 is player.score. So we are putting player.score into this.highscore. This is pretty important, and I created this case to confuse you a little bit about this, that you do not interpret your own stuff into this, that we follow simply the strict rules of the Smiley code. Okay, so here we are having an object in our player class. Okay, so here we are having an object as a parameter, the player object as parameter. But now we are referencing to this.player. This is now the player class. So we are within our player class. But if you write this down in the exact same way, you shouldn't have any struggle with this. It might be a little bit confusing, but just remember p0 is our this operator and p1 is our object over here. Okay, let's see. So we also got this case right now. That's great. The last case we got to solve is this one over here. This has been true. Now let's put this to false. Easy peasy. We get our else statement, and this else statement simply got a return over here. This return void. And that's it. This is our code, and this one is, yeah, this is corrected, this part. Now let's get out our Java code, because this might have confused you a little bit. I'm not sure about this one. For me, it would be absolutely confusing. So we've got two player objects here. This one is a parameter, and this one over here is our this. Let's see how the code looks like. Okay, and once again we can see this one over here. The first check is if player score is less than player.highscore. And in our case, our first check is greater equal. But it's still correct because our else statement will be the case if we are having v0 lower than v1. This is this statement over here, and then we are returning out. So we got it again vice versa. And here let's see, also the same for this one over here. Our else statement is this one over here, and here we are having the statement which is returning out. So this statement here is greater than player.highscore, but in our case we are checking if we are having the other case. If it's less or equal, then we jump out. So out of this one. Okay, so if you reverse engineer Smiley code and if statements, my advice is not looking into JADX. Maybe just a little bit to get some knowledge about what's used in there, but please do not rely on this. This will confuse you a lot if you reverse engineer the Smiley part regarding to this. Just simply ignore what you have seen in the JADX code regarding to these if statements and simply do it in the Smiley part step by step. Then you shouldn't have any trouble. Alrighty. Next we have some little quiz, and afterwards we take a look at patching those if instructions, because you can do a lot of funny things to change the statement itself or simply skip parts in the statement. So it's pretty ridiculous what's possible there, and the code is still working even if you do some really crazy patching. Okay, that's all for this video right now. If you're not feeling comfortable regarding to if statements, please keep practicing this within Android Studio. In case of any questions, feel free to write me a message. And otherwise, I'm looking forward to see you at the quiz. Welcome back. After finishing the quiz, let's have a look into patching these if instructions. We are now pretty familiar with how they work, but how can we patch them to modify the application behavior to get into the other branches or things like this? Generally speaking, there are a lot of methods. I will introduce 3 of them because I guess, with those 3 you will solve all your tasks you want to do. Alright, let's dive into the first one. Method 1 is logic flipping. Sounds promising, let's see how it works. Okay, on the right side we've got our Java code and on the left we've got the corresponding Smiley code. And let's have a look into this. We are creating a new player object over here. Then the player gets hit. So in the last exercise we lose a player life over here. But now there's something different. The player has now a new instance field named shield. You got a feeling what we are going to do in the next couple of videos? Yes, absolutely. So in this case, our player has now a new instance field shield. And if the player has now a shield and the player gets hit, the player doesn't lose a life, the shield gets removed. So player.shield is now equals false and we move on in our code. And in case we do not have a shield, so if player.shield is false, then the player loses 1 life and we also move on in our code. Alright? Okay, let's have a look at the Smiley code. So in this line we are having v1 initialized with 0x1. Then we've got an iGet boolean, so we are getting this instance player.shield, which is from type boolean, into v2. And now we've got an if statement. And this if statement is, please read it out loud, if v2 is equal 0, then jump to condition 0. So it looks like this. Now we need to step back and think about this. Let's see what we are checking. Okay, we are checking if we are having a shield. The shield is from type boolean. This means the shield can be true or false. If we are now doing a comparison against 0, it means we are checking if the player does not have a shield. Because if the shield is 0, then it's false. And this is the comparison against 0. So this statement would have been or would be true. Alright, so this is our statement if we do not have a shield. Then we jump to condition 0. Let's see. Condition 0 is over here. We are fetching our player.lives into v2. We are subtracting 1 from this. We are putting it back. And then, we return out of this. Alright, this looks good. Otherwise, let's have a look. So if we are having a shield, it means it's not equal 0. Then we can see v1 is initialized with 0 and we're putting our shield state to 0, which means our player.shield is now false. So we lose our shield, but we do not lose a life in this approach. Okay, and then we jump to go to 0, which is here, and we return out. Alright, this looks okay for me. Now let's see how we can patch this code that we get an advantage out of this. So there are many different approaches we can do. In my case, I want to talk about flipping the logic, which means if we are not having a shield, we do not get hit. And if we are having a shield, we do get hit. Alright, how can we do this? With only one instruction over there. Think about the if statements and all these different types. Can we use this to change the behavior? Absolutely correct. We can do this. And we do this with the following sign. We are adding this exclamation mark. And by doing this, we will flip the logic. Our if equals 0 will become if not equals 0. And let's do this approach once again. How does it look like? So still we've got a 1 within our register v1. Now we are putting our player.shield into v2. We are not having a shield right now. So this statement or v2 is holding the value false. Now we've got, this becomes now a little bit of a brain task. So it's getting a little bit complicated, but let's see. Let's do this once again. If v2, which is false, is not equal 0, we jump to condition 0. All right, once again, if v2 is not equal 0, we jump to condition 0. Okay, this means if our v0 is not equal 0, we jump to condition 0. So in our case, v2 is not true. v2 is false. Therefore, we do not jump to condition 0. Okay, then we move on over here. We are putting 0 into v1, and then we are putting false back again into our player shield state. And this is ridiculous because this means we still keep our player shield on because we have flipped the logic. By having player shield equals false, we cannot get hit. And this is good because we are putting this value here once again into this. Therefore, it does not get overwritten. Therefore, we are having still our shield, our imaginary shield over here. But it will protect us. So that's good. Okay, and afterwards we go out of this. So flipping a logic makes it really complicated. Therefore, we have to say it out loud and think about what we want to check and what we did. Normally, if you understood the initial if statement and you want to have the opposite of this, you can simply flip this by not even thinking about this. By thinking about this, you might get a little bit confused afterwards, but you will figure out it's still correct. So that's what we've got right here. And this is something we want to code right now and then analyze back again because it's really complicated, I know. But we practice this. That's why you're here. And together we will make this, and afterwards you can do a lot of funny things. We will learn some other methods, which might be sometimes a little bit easier. But for now, let's stick to this one. Okay, before we code it, let's do it once again together. Let's do it for the initial state. If v2 is equal 0, we jump to our condition 0. This means we are not having a player shield. Now we patch this instruction with the exclamation mark. And therefore we switch the equal 0 to not equal 0, which means unless we are not having a player shield, we do not lose a life. It's also for me not easy to do this, so I have to think about this. But by thinking about, we get the solution. Okay? All right. Now let's get back to our Ubuntu VM and code this real quick. Okay, here we are at our Ubuntu VM and we still got this old project open. Let's see. Yes, we've got the check high score and we've got this get hit over here. All right, let's write this piece of code to implement that we've gotten shield. So we are having a new instance field, boolean shield. And let's set this to true because then we start with a shield and if we get hit, we shouldn't lose a life. Afterwards, we remove the shield and if we get hit once again, then we lose a life. Alrighty, so let's see. We are now in our getHit method. So if this.shield is equals true, we do not get hit. Otherwise, which is in this else over here, we do get hit. Okay. After getting hit and having a shield, we need to remove the shield because the shield blocked this collision. So this shield is equals false. And here we can also see an additional patch possibility, which comes handy for us. Let's say we are not removing our shield. So let's say this one stays true. This would mean that if we pick up once a shield, it does not get removed. So it stays there forever until we end the game. This would be also a nice patch, but with a little bit of a downside. we have to pick up the shield first. And this is something we do not want to do. We are super lazy and we want to start with all we want to have. Therefore, it's a nice patch, but not what we are looking for. All right, so this one is set to false afterwards we get hit. Okay, and that's our code. Let's try this out. So we click on build. And I'm also making the ADB connection to our VM. Already connected, that's good. And locate, there we go. And yeah, let's install this app. A screen copy, there we go. Smiley 2. This is our application, let's see. So we are now having a shield. This means if we get hit or if we press the button, we get hit, but we have our shield. Therefore, we should not lose a life. There should be in 5 afterwards, 5 lives. Let's see. We get hit in 3, 2, 1, now. All right, nice, it's working. We have now lost our shield. We can check this by hitting this button once again. Yes, now it's reducing the lives. All right, let's do a quick check if it's really correct. So let's close this one over here. Okay, and now let's remove this shield. We build it once again. Okay, locate. ADB install app debug. We are opening it. Okay, if we now get hit, we do not have a shield. Therefore, we should lose a life and there should be a 4. Let's see. 3, 2, 1. Yes. Okay, I'm glad that this worked. Otherwise, I had to figure out what goes wrong. But this is exactly what we want to have. All right. Regarding to the state, this doesn't really matter because the state changes in the game over and over again. We take a look at this over here, at this if statement and how to patch this. So I'm going to decompile this application and then we pull out our graphic tablet. And so before we decompile this application, I really would like to add something. So this is not an Android development course and the things I have shown so far are perfectly fine to create simple mockup apps to test or train a special topic like if conditions. However, these applications might not look that fancy, or let's say they are a little bit boring. And therefore I have also provided a more fancy version of this application over here. The code is pretty identical, so the only difference is that the Smiley 2 design version has an additional button to pick up a shield and some form of visual output. You can do exactly the same in the mockup application with some sort of debug statements, for example system out print line. This is also perfectly fine. And so to patch this application, to start with the shield, I recommend using the Smiley 2 design version or to set the shield state to false in our mockup version. I also provide you all 3 applications in this section as an attachment. In the Smiley 2 design version, you have some sort of visual output. In the Smiley 2 no shield version, you shouldn't lose a life after patching it. It doesn't matter in which version you apply the patch. All that matters is that we understand how flipping the logic affects our application and that we can achieve what we want in there. Because later on we will take our approach to real-world applications, for example, to bypass the routing detection or to modify our SpacePing application to achieve certain features. Alrighty? Perfect. Okay, let's reverse this real quick and then we figure out how we can patch this to, get and shield permanent. Okay, this time I also try to write this a little bit more clean, that it doesn't get that messy, but I'm not sure how good this goes, so let's see. All right, we've got our method over here, get hit. So here we have our method name. We can see 0 parameters, okay, and return void. This is our function prototype. Okay, then we've got iGet, and we have our this object over here. So P0 is this. iGet means we've got an instance field. So we've got this, and here's our instance field, this dot shield. And this is being put into v0. Okay, so v0 is now this dot shield. Okay. Then we are having v1 is being initialized with 0, and we are having v2 is also being initialized with v2. By the way, I skipped about this, but we are already familiar with this. So I guess I do not have to explain regarding to the local 3 anymore. You might be bored about this one, and I can fully understand this. Okay, so back on track. We are within v1. v1 is now 0. And v2 is now 1. Okay, then we have our if statement. So we stick to this dramatic color over here. And let's read this out loud together. If v0 is not equal v2. If v0 is not equal v2. Then we jump to this condition, and this condition is here. So we jump to this one over here. Okay, let's check what this if is about. v0 is our this dot shield. So if this dot shield. Okay, my promise, I guess it's already over. So let's see. If shield, okay, is not equal and v2 is true. Oops, there we go. Okay, this is our if statement. So if this shield is not equal true. Sounds a little bit strange, but we will figure out what this is about. Let's see, then we get into this one, iGet. We are fetching P0, this once is our this back again, this dot lives, and we are fetching this value and putting it into v0. So v0, oh, that's interesting. Let's change the color. v0 is this dot lives. So why is it interesting? Because we are overwriting v0 at this point over here. So here v0 is referenced to this dot shield, but now it's being overwritten to this dot lives. So take care, overwritten. And yeah, if we keep track on those registers in this way, we do not have any trouble. Therefore, we know, okay, v0 is now this dot lives. Okay. So we are at this line over here. Then we are subtracting v0 equals v0 minus v2. So we are subtracting v2 from v0 and storing the result back in v0. Okay. v0 is now v0 minus v2, which is v0 is now this dot lives. This dot lives subtracted with 1. Yes, this one over here. Minus 1. Okay. And then, yeah, we are putting this value back again. And you can see those patterns. You have seen this in the past, and you will see this also in some other examples. And by practicing Smiley, you immediately identify those patterns. So we are getting this value, we are subtracting 1, and then we are putting it back again. This is simply just the subtraction from 1 of this instance field. Okay, this means this dot lives, which is now P0, okay. So this dot lives, or let's change the color for this, because we are not having V0 in this case, we are having P0 is equals V0. P.0.lives to be more correct. Okay, so this dot lives is now equals V0. All right, we just subtract 1 from this dot lives and put it now back again into this one. Okay, then we have another if statement, this one over here. So let's see. Okay, if V0 is less equals 0, we jump to this condition. So if V0 is less equal 0, we jump to this condition. And this condition is over here. Okay, let's recap this. What is V0? V0 is our this dot lives, as I can see it from here. Yes, V0 has been referenced last at this line over here. So this was the last time we have referenced or initialized V0. It's not initialized, assigned a value to V0. And this means this is our this dot lives. This dot lives. Okay, if this dot lives is less than equals 0. Yes, this means we are about to losing the game. Okay, so let's see. Then we are putting V1 into this one over here, P0. And this is now, P0 is our this object. So this, and here we have our instance field, this dot state. Okay. This dot state is now we are putting V1 into this. V1 is 0. 0. Okay. But we are putting a boolean into this. This means we are not having 0. Yes, we are having 0, but in this case we are having false. So this dot state is false afterwards. Okay, then we have our goto, but this is not our goto instruction. This is just our goto label, which can be ignored. And then we are simply returning out of this function. So return afterwards. All right, and that's it. So now we've got the true statement for this case over here. Now we need to do the same for the false statement. Therefore, we are having our else. And I hope it's not that long, but let's figure out. First, I want to clean this up real quick. There we go. All right. Okay. So we've got this condition, so we are not jumping right now, we are moving on at this part. Now we are putting V0 into P0. This is once again our instance field. This dot also state, okay. So this dot state is now V2. Oh, I realized there, I'm not sure why I did write it in this way. Normally I do not do this. So let's clean this real up. Yeah, I'm not sure why I did write the 0 in there. That's not what I like to do because we lose track of the registers. And sorry for this, but now we are back on track. We've got I put V2 into this dot state. Okay, we are at this line, yes. And V2 is now true. This makes sense. So now we're putting true into our this dot state. And then we've got this goto label and also the goto instruction, which is even more important because now we know we jump to this goto underneath. And then we are returning out. Okay. So that's it for the else statement over here. Now we've got this complete if block. We've got both. Let's do it here. So we've got both branches. We've got the true and the false branch. We need to repeat this for this one over here. And I hope it's not that large, but I will minimize this a little bit, that we can write on this in this clean state here. Okay, we are back. Let's see. We are in this statement over here. We've got this part already. So here we are done, but we need to get back to the false statement over here. And this one is this part underneath. So this is our if statement. And now we've got the else, which is the false part. Okay, regarding to the false part, we move on right here. Let's see. We are putting v1 into p0. So again, this is our this object. And it's this dot shield. All right. So this dot shield, I hope the space is enough. Let's see. Is now equals v1. Let's see what is v1. V1 is false. Nice. False. All right. Okay, nice. Then we've got our goto label, and this goto label we can see here. Yes. So we are jumping right down here, and then we are simply returning out of this function. Okay, that's good. So we are done. Okay, so this is our code. It fit to this page, which I'm very happy about this. So let's see what this code does and how we get an advantage out of this. Let's recap this first. So we've got our player object over here. This is our player. And this player doesn't start with a shield. If we get hit by a shot, for example, we lose a life. So if this one hits us, we lose a life. Okay, and if we are picking up a coin, so we didn't write the code regarding to the coin, but this is when the player shield state changes, at least for the space ping application. So we have our space ping, and now we are fetching this coin, then we get our player shield around us. All right. And if we now get hit, we do not lose a life, but we lose our shield afterwards. Okay. Let's see where we can find this part in our if statement on the right. So we start over here. We are looking for the point where we are losing lives and where we change the shield state. So is it within this or this if statement? Let's see. This one over here. We are having here this one. This is the initial first one, this one over here. And here we can see, okay, that's it. We already found this. Because in this if statement, we make the decision. If we lose a life, which is this one over here, this line, or if we change the player shield, which is this line over here. So we even do not have to look it up in this if statement here. So this one can be simply ignored from our side right now. All right. Now let's check this if statement. So let's do this. v0 is our this.shield. Okay. So we are having our player, and this player has now a shield. So if this.shield is not equal v2, v2 is true. And we write this down in the exact same way. We say, or we write this down as if our shield is not equal true. Then we go into this condition. Okay, this condition is, let's check this once again. Where do we have it? There. Okay, this was this one. Okay, and this is this part over here. All right. It's a little bit hard regarding to thinking about this, and also the brain is a little bit confused. But if we keep doing this, you get practice and then you will be faster on this. So let's check this out. What do we have here? If our shield is not equals true, this means we are not having a shield. This is what this statement is about. We are losing a life. This line over here. And that's absolutely correct. Yes? If we do it differently, well, no, I guess that's too confusing. Let's just go in the false statement. Do not try to flip this right now. So if our shield is not equals true, so we are having no shield, we go into this part, otherwise we go into this part. One line beneath this if statement. Okay, and this line is doing this part over here. So this line is doing this part over here. So it's resetting or setting the shield to false. Okay, so we got our statement and what's doing, and yeah, we know everything about this right now, even if it's a little bit confusing. Now it's getting a little bit more confused, but think of what I have recommended. So in this case, our player has no shield. If the player has no shield and get hit, it loses a life. Now we want to change it. We want to change it that our player has a shield. And if we get hit, we do not lose a life. And to get this state, we can simply flip this if statement. This will lead to, if the player on the left, this is the original statement, picks up a shield. So let's do it this way. The player will be protected. So this is this part over here, regarding to the correct statement. In our case, it would mean if we are picking up a shield, we are not having any shield anymore and we are vulnerable. So as long as we are not picking up a shield, we are safe. But I guess it's even a little bit complicated right now. So just stick to the recommendation. If you want the opposite case, so starting with a shield, this one over here, we want to start with a shield and lose 0 lives if we get hit. Then we have to flip this logic over here. This means instead of not equal, we are having equal. But still, let's think about this. Let's go through this if statement and see if it's correct. Therefore, we clean this up on this side over here. So we have flipped the logic. This means we should now have the case that our player starts with a shield until the player picks up another one. But that's not important. So this would be our case. Our player starts with a shield. Let's see. Okay. If v0 is this dot shield. If this dot shield is equals true. Okay, so we are changing this to this statement. If shield is equals true. Then we go into this instruction or this branch over here, which means we are losing a life. Yes. Okay, that's bad. But let's take a look at the other side of this coin. So this one here becomes now false. So we are not having a shield. Is equals true. This is of course not the case. So this will be false at an outcome, this if statement. This means we go into this line over here. And this means we are ending up here. All right, this is confusing, I know. Try to think about this once again, maybe twice or 3 times. It's really hard, but by keep practicing this, you will be doing this in a few seconds for the next sections. Okay? So let's check this once again. If we are now not having a shield, we cannot get hit, or no. Let's say if we are not having a shield, so our player starts the game and the player does not have a shield. If the player does not have a shield, we get into this branch over here. And this means our shield will be false. All right. But this also means we are not losing a life because we are not getting into this branch over here. And let's see how this goes. Okay, so we start our game, we are not having a shield. If we are not having a shield, we end up at this branch over here. So if we get hit, we lose our shield. All right, let's get back. If we get hit, let's see, our shield is still on the state false. This means we are still having no shield. This means if false equals true, we end up here. Okay, but regarding to the flipping the logic, it's super hard for, at least for my brain, to follow this. And if you also struggle, write it down in this way. Maybe a little bit more clean than I do, but yeah, if you write this down and if you keep saying it loud, it will help you a lot. Okay. All right, and so let's practice this real quick. And so first, let's get our connection to our device. Okay. So let's get the screen and then let's install this application over here. And this time I'm using the Smiley 2 design version, but as already mentioned, it works exactly the same with the other one, the Smiley 2 version. But this has a more fancy output. So we are installing this app. All right, and then we have a quick look into this one. We can see we've got a very nice icon over here. And if you open this, nice, this looks absolutely beautiful. So we have our lives, and if we click on hit, then we can see we lose a life, and if we get a shield, then we can see we have a shield over here. If we get hit once again, then we lose our shield. And we have also track about this one over here. So if we now get hit, we are not having a shield, we are losing a life. That easy. 2 lives left, let's get back a shield. We are immune for 1 shot. All right, perfect. Let's decode this application and then apply our patch. So we are using the APK tool D. And now we are opening the Smiley directory once again with Visual Studio Code. So Smiley classes 2. And this time not only this time, I always trusted author, but this time we are having a little bit of a diversity regarding to the line numbers. So if we go into app hacking and then into player.smiley, and let's enable Java. And then if we scroll down, we can see this line number is now 38 and before it has been 37. The code is exactly the same. So every instruction over here is the same, but the line numbers are different. Nevertheless, we do not care about line numbers, we just care about those code lines over here. Therefore, we can simply ignore them, and within our application, so if we have a look into our application with JADX GUI, then they perfectly match once again. So do not get distracted by different line numbers, focus on your application, on your state, and then you're good to go. Alrighty, so over here we've got our condition, if not equal, and now we are flipping the logic. So we have extensively reverse engineered every line in here, and now we fully understand this part over here. Which means if we are flipping the logic, then we are flipping the logic regarding to the shield. So now what we should have is, we shouldn't start with a shield, but we should be immune until we pick up a shield. Alrighty? Okay, let's verify this. We apply our logic flipping, not equal becomes equal, and now we are building back this application. We've got it still here. So APK tool B, smiley to design. All right, and now let's sign this application. And first we need to zip align it. So this is now smiley to design. Then we need our APK signer to sign this application. Change it as the password. And now we need to uninstall the current version. Let's do this real quick. Oh, not this one over here, it's this one. All right, and now let's install our version, out APK. Get back the screen and then let's see if our patch has been successful. So we start this application and now let's see. If we can see shield is false, so everything looks normal until we press the hit button. We can see we are not losing any life, which is super amazing, right? So we have now flipped the logic that we are having a shield, and based on our infinited loop, we are not changing the state. So we do not lose any life because our shield state doesn't change anymore. And yeah, based on the logic flipping, we are now immune for this application until we pick up a shield. So if we are now picking up a shield, we can see visually wonderful output, and we can also see a shield has been set to true. If we now click the hit button, then we can see our shield stays active, but we are losing lives. So this is exactly what we have expected, and this is how flipping the logic works. We have flipped the logic of this application, and yeah, we get a huge advantage out of this until we pick up a shield. Alrighty. In the next one, we take a look at the method 2 and then method 3, and then we have tons of exercises where you can practice all these things. Okay, so I'm looking forward to see you there. Welcome back. So the last video was a little bit long, but yeah, I guess it doesn't work if we cut out certain pieces of this code because we need to understand it in a whole. Therefore, yes, sorry for going through all of this, but I hope it helps you understanding this topic, even if it takes a little bit longer. Now we have a shorter version. We are looking at the second method, the erasing method, and this one is pretty easy. Let's see how this goes. So we are having a new object over here. This is our player, and the player can now get some items. For example, a master cap. By getting this master cap, the player gets a power upgrade from 100. Otherwise, we just get a power upgrade from 10. Okay, this is our code. Now, this time we want to achieve to always have this power upgrade without having this item. And yeah, we can do the same approach as before. We can simply flip the logic out of this, which means we are having always the item unless we really fetch this, and then yeah, we end in the else case. So this was a little bit of an brainy task, but we solved this in the last video. Now we do a different approach. We simply go into this if statement and yeah, we erase this line. By erasing this line, this is pretty ridiculous, I know, because what's about the rest of this code? So what's happened here? Well, if we erase this line, we simply have sequential code. So if we get into this method, this is simply a normal instruction right now without having a condition. And after this instruction, there's now some strange code, isn't it? So this looks very strange regarding to the Java part right now, because we are having some brackets open and there's an else without an if and things like this. But regarding to the smiley part, it's not that strange looking. Not really, because we are most of the time having a goto afterwards where we end up or skip the other part, this part over here. So by erasing this if statement, the code doesn't get necessarily broken. To be honest, in most cases, it works as normal, just without having a condition. And this is a super neat trick and also very helpful. And this is what we want to try out right now. So we write this little piece of code in here, and then we simply delete this line. And by running this app once again, we get our power level automatically without having a condition in there. And this is super nice. And we will also figure out that we automatically skip this part over here without doing anything. This is just the intended code, like it would be regarding to the if statement. Okay, so enough talking, let's take a look. Okay, here we are at our Ubuntu VM and we can see the old code. And if we look at this code, it looks pretty ridiculous already. But it's also pretty amazing because we can understand every line which is in there regarding to the Smiley part. Okay, but for now, let's take the example from the slides. So let's see. We're creating a new method and we name this method public void has item. Okay, and we provide a player object over here. All right, and then we create a new item, which is Boolean master cap, and this one is false. Okay. Now we are checking if the player has this item. If player dot master cap. Oh, yeah. Let me change this. I'm not liking this in this way. Yes, that's better. Okay, if we are having this item, we increase our power level. Power level bonus plus 100. So player dot power plus equals 100. Otherwise, we only get the power level bonus from 10. Player dot power plus equals 10. All right, this looks good now. Yes. And what we are trying to do is we try to patch this line. So by removing this if statement over here, that this one becomes a generic statement. So we would end up with this. Yes, and regarding to the Java part, it looks strange and also not possible, because else without an if, strange. But regarding to the Smiley part, this will work, because Smiley does not have if or else. Smiley gets registers and comparisons and doesn't care about this, okay? Alrighty, so I'm super excited how this looks like. So let's build this application. Let's see, should we test this? I guess we should test this. So, whoops, sorry. Let's call this one over here. Yeah, instead of get hit, we are now using our method over here has item. So we also need to provide a player object. This is now a little bit ridiculous, but okay, it's working in this way. All right. And now we print out our power. Okay. Yes. Now let's build this application. And don't worry, I will provide you this app, of course, as always, in this section over here. So you do not have to code it on your own. Let's see. Okay, we are installing this new application real quick. Then we check if it's working and then we take a look at the Smiley part. So already installed. Whoops. There we go. SCR copy. All right. Smiley 2, let's see. Hello Udemy. Power 20. Okay, this looks good, I guess. Let's see. We are having power 10 at the beginning and now we're getting a bonus of 10. If we do this once again, we should have 30. Yes, okay. And so on. You see complicated math behind this. And now we already or finally finished or reached the same power level with our bonus. This took me way too long. I want to have this immediately. Let's take a look at the Smiley code. So let's close this one. Debug. At debug, we are opening the whole directory over here with Visual Studio Code. Okay, there we go. We change to Java. We are within our player.smiley file and let's see. Get hit, it's not get hit. Also not check high score. Old version of this file. So simply close this one over here. Don't save. And we got tons of other windows over here. But now let's see. Java, constructor, check high score, get hit, has item. There we go. Okay. Let's pull out the graphic tablet and figure out how this works and then figure out what happens if we simply remove this if line over there. Let's go. All right, I've got my graphic tablet out there. Let's go. So we are having our method hasItem. And this time I try to write this super clean. Let's see. So this method hasItem. Beautiful. Okay. We are having an object or a parameter, which is player. So this one is P1 and we are having this player. All right. Player. Okay. And we are returning void. Looks good. Next, we are having only one local register over there. So this might be variable, a placeholder, we do not know. Okay. Then we've got this line over here. So we know what this one is. We know what this one is. We know what this one is. And we also know what this one is. But we have to read it first. I get Boolean. So we are fetching from our player parameter an instance field. Or, yeah, this field over here. Master cap from type Boolean. And we put this into V0. So V0 is now player dot master cap from type Boolean. Okay, then we've got our if condition. You know what we are doing right now? Yes, we read it out loud. So let's see. If V0 is equals 0, we jump to this condition. If V0 is equals 0, we jump to this condition. And this one is there. We're jumping downwards to this one. Okay, let's see what we do have here. V0 is our player master cap. And this means if our player master cap is false. So if this one over here is false, then we are having false equals false. Then we go into this if statement. Okay, what do we do here? We've got an iGet, so we take our blue once again. Now we are taking our power from type integer from our parameter and we store this in V0. All right, we are overriding V0 at this point. So let's put out some alert sign over here. Alrighty, V0 is now player.power. Overwritten. Okay, then we are adding int 0xa, which is 10. Oh, that's sad. So we are not adding more than 10. So we are not having our super bonus level. We add this to V0 and we store this back to V0. So V0 is V0 plus 10. Which means we are having our player power. I write this a little bit shorter to make this clean. Player power plus equal 10. Sorry, that's not how it works. Plus equal 10. There we go. All right. And then we are putting or getting this object, this register and putting it back into this object P1. Our player.power. Player.power is afterwards V0. And you can see this pattern once again. So yeah, keep practicing Smiley and this will be even more easier in the future. All right, and what's next? Our line and go to label which can be ignored and then we are returning out. Return. That's it. Oh, I'll leave it as it is. Okay, you can see it's getting a little bit more clean, I guess. And yeah, this wasn't that hard anymore. So we are having a lot of practice in this right now. Okay, maybe I need to practice over there, but you know that's return. Okay, so we've got our true statement here. Let's recap this real quick in our mind that we know what's going on. If we are having our true statement over here, we do not get our bonus. So true means no bonus. This means false should end up here in giving us the bonus. Let's clean this up real quick and have a look. So false, okay, we are in this line. We have the true statement already done. Now we're taking a look at the false statement, which means we are directly underneath this. Okay, I get, so we are getting player power and moving it into v0. Okay, let's also write this down here. Else, oh, I hope the space is enough. Let's see. v0 is now equals player.power. Okay, then we are adding this value over here. And let's do the math. We are having 4 plus 6 times 16. 100. Okay, I cheated a little bit, but it is 100. So let's pretend we did solve this just here. Okay, then we are adding this value to v0 and storing it back in v0. This means we're having the equivalent from this, but with our new power level. So v0 plus 0x64, which means still no space, plus 100. There we go. Okay. And then we are putting it back into P1. So player.power. There we go. Player.power is equals v0. So now is the important part. Now we jump to our goto over here. So our goto label is this one. So we're jumping directly to this and we are skipping all this code over here. Okay? So afterwards we return out. And this is our else statement. Okay. And let's clean this up real quick and then let's check. Alrighty, let's have a look. Okay. If we are having a false over here, we do not get our power. No bonus, or not the big bonus. It's really hard to write in this direction, but I guess it works. And here we're having our big bonus. Okay, maybe I wanted too much. There we go. So let's see. We are in this if statement over here. And what we want to do is we want to patch this in the following way. We do our 200 IQ play and we simply erase this line. Yes. Okay. Then we have our code. Let's see. We have a code. We are putting our master cap from type Boolean into v0. Okay. So at this line over here, we have v0. So we are at this line. v0 is equals player.masterCap. All right. And then we do not have our if statement over here because, we did our 200 IQ play and simply removed it from the Smiley code. Then we directly jump into this line. Nice. What we're doing here, we jump directly into this part, into the else part over here. So this line means we are putting player.power into v0. So we are overwriting the last one. v0 is player.power. Oh, still wrong, sorry. Player.power. And then we move on in the code. We already got this over here. So this is now our code. And why do we not have this strange else statement without an if right now? Because if you take a look, so I already messed it up already very much, but I guess we can still figure this out. So this line, okay, this is this line. Then we are having this line. All right. Then we're having this line. All right. And now's the important part. Smiley does not have an if-else statement. Smiley gets branch jump instructions. And we're having a jump instruction over here. And this jump instruction gets us out this function here, which means we are skipping this part and it's like we are having an else statement without an if over there. And this is how Smiley can still work if we remove an if statement at this line. Really amazing, isn't it? And by doing this, we simply get our power without doing anything. And this is what we want to have. We do not want to have any effort in this game, and we want to get the maximum out of this, even a little bit more of this. Okay, let's patch this application and see how it works. So let's get back to the Ubuntu VM. Okay, here we are back at the Ubuntu VM, and the thing we want to do is we do our analysis. We know this one is straight in our way, so we hit this button, and that's it. It was pretty hard, but at least finally we get this. Okay, so let's save this. By the way, we do not have or add those space or new lines. We can simply leave the code as it is. But it doesn't hurt if you do this until you mess this up. But yeah, I will show you real quick. So having those new lines over here is no problem. But what's a problem, of course, if you do something like this? This would be, of course, a problem, but I guess it's self-explained. Okay. And let's build this app back again. APK tool, B, app debug. Meanwhile, I'm getting the Android screen. That's our old version over here. Yes. Okay, then we have our destination file. We zip align this. Oh, that's the wrong part. So zip align -v4 app debug out APK. Then we sign this. Change it. Yes, okay. And then we install this. By running or starting this application via Android Studio, we have a different certificate. So we need to uninstall it first. adb uninstall com app hacking smiley 2. Now we can install it once again. Oops. There we go. Let's get back to our code. So let's see. We are having now a power level from, what do we have? After hitting the button, it should be 10 plus 100, right? Let's see. There we go. We have 110. And by hitting it once again, we get, do you know the value? Of course you do, because we've gotten simple instruction that increases our power level. And this patching comes super handy. It's really easy if we understand the Smiley code and if it's possible, because if you would have it vice versa, then it's not that easy. But what we can also do, for example, is, let me open this code once again. Okay, we can also delete the whole negative impact from this one, or let's say the least amount over here. So we can simply go into this and delete it completely. But we need to take care, because if we are filling out registers which gets used afterwards, then they do not get initialized and we get up, or this application throws up some errors. So therefore, deleting larger code parts is not really recommended. If you reverse engineered this part and figured out, okay, this one, for example, is only this part over here, then we can simply delete this. So what we have right now is the following. We have this one, but not here. We deleted this part. We also deleted this one. And here we have the opposite of this one. So this is the else statement. Yes. This is what the patched code looks right now. Okay. And what we can also do, of course, if we take a look into this, we increase our player power over here, and we do not need this part. Then we can also delete this part to only have this one, for example, left in our function. Therefore, we can also go into this and we can say, okay, we can delete this part over here. Yes, this should also work. Let's figure this out. I saved it. And then we go back and build this application. And let's do the clean approach. So adb uninstall com app hacking smally2 adb install out apk. Okay, so now we're having this Java code, which simply is one line increasing our power by 100. And we can see, I hope we can see this, that the application, yes, it still works. So we just deleted the code we do not want to have in there. And this is what we can do by having the Smally code. We can simply patch whatever we like, unless we do something wrong. But we can also fix this part. For example, if we're using necessary variables, we can set them up once again afterwards. But we will do this in the later chapter. It's just some kind of preview what we are going to do later on. Okay, for now, removing if lines or simply one if statement works. And let's do this. Let's open this with JADX GUI. And then we do the quick Smally comparison once again to see what our patched function looks like. So here's our player and we can see this one over here. Yes, we still check if we are having this Boolean set over here, but we are not using it anymore. So we got the initialization of this set. So we are assigning this Boolean state there, but we are not going to use this variable anymore. Therefore, it just hangs around there. And then we've got our player.power plus 100. Okay. But the thing I wanted to show was the following. So we go back into our Visual Studio. Yes, so we close this one, open it once again. And yes, okay, this is now the patch state. So we can see we have removed the if statement. This is our assignment, our variable set in our JADX code over here. And then we've got our player power over here, which gets increased by 100. And then we jump out. That's it. Okay, to recap this a little bit. So we have seen we can patch if instructions by simply removing the if statement itself. This means our next line will get a simply sequential code part. So the program code goes on into this without having this condition anymore. But we do not break the code most of the time, because within our if statement, there's already a way out of this. So there's a return or at least a jump instruction already inserted there. This is like having or always meeting the if condition if we simply remove this part over there. Okay? And this trick is super handy. And it's just, one of three I would like to show you right here. So this trick can come super handy. Also not just regarding to if statements. We can use this for every instruction also. If we are having some code which we do not like, we can try to remove this. But we have to take a look above and underneath if the code still works. So if we have some register initialized there with certain values that would be needed later on, then we have to fix this. But we will learn about this, okay? So removing Smally code is also as valid as patching Smally lines, okay? All right, and the next one, we take a look at abusing those jump instructions. And this is the last patch method regarding to if statements from my side. Of course, there are tons other, but with these three, we can achieve everything we want. All right, so I see you there. Welcome back. In this video, we check out our last method regarding to patching if instructions, which is patching jump statements. So we do not have some slides here. We directly jump into our last example and modify this a little bit. Because let's say we got lucky that the if statement lay out in the correct way. Therefore, we could simply remove the first if line and increased our power. But what if? You get it? What if? What if the if statement has been switched? We are not having our preferred if statement at the beginning, we are having it at the end. And therefore, by patching the if statement or removing the if line above, we get in the code we do not want to. Therefore, we simply switch the jump. We are not going to the first, we are going to jump into our second by having this condition. But before we make it too complicated talking about this, let's dive into this. Okay, here we are at the Ubuntu VM and I already opened Android Studio. So this is our example from the last section. Okay, let's have a look into this. So we do not have a master cap over here. This means we cannot or did not get into this condition, which would increase our power level by 100. Therefore, this was not possible. We end up in the else statement and only increased it by 10. Afterwards, we return out. Okay, so this was the regular code, but this was something we didn't accept because we do not want just 10, we want the power upgrade of 100. So what we did was the following. We removed this line over here. And this leads to this becoming a regular instruction, which means we are having a power upgrade of 100. And this part right now will be skipped because we cannot enter this else statement anymore. Okay, so I would say this was a fair approach for us. Yes, so we got a power upgrade by 100 immediately without having a condition over there. That's nice. But let's say we got a little bit lucky with this. Why? Let's say things get switched. So let's say we've got it in the following way. Our power upgrade is now not within this statement anymore, it's within this statement. And we are also having this set to true. Okay, let's see how good our approach now works. So we are going to delete this line over here. Okay, this means we get a power upgrade of 10. Okay, not bad, but we cannot reach this if statement anymore, or the else case of this if statement. So we are going out of this function with only having 10. And to be honest, this is not acceptable for us, right? Absolutely. Therefore, what we are going to do right now is the following. So I clear the screen once again. All right, so we are having the master cap, and this is acceptable for us. So we are going into this statement because we have it set to true. All right. Then we've got a power upgrade of 10. Okay. And now, instead of leaving this function here, we are patching it that we reach this one, the else part. This would lead to another power upgrade of 100 once again. So we are getting 110 right now. And we can do this with changing the jump instruction. So before we go out at this point, we simply go in back again. And we can do this with the condition. So let's build this application and have a look at the Smiley output. Okay, so here we are at the Smiley code. Let's have a look into this. We've got our has item. And I try to improve my writing. Let's see. Has item. There we go. We've got a player object. Player. We are returning void. All right. So we've got a local register. Okay. We've got our player as parameter. Yes. And now we are fetching the instance from our parameter, which means master cap. So this is player.masterCap, and we store it into v0. So v0 is equals player.masterCap. And this is from type Boolean. Okay, then we've got our if statement. Let's do this together. If v0 is equals 0, we jump to condition 0. So if v0 is equals 0, we jump to this condition, and this one is here. So we do this jump, which means we are increasing the player power by 100. So I just, let's wrap these three lines up in this one over here, because we already analyzed this function. Player.power plus equals 100. Okay. Otherwise, we get into this one, which means we are getting the player power and just increasing it by 10. So our else part over here is else player dot power plus equals 10. All right. So our master cap is a Boolean value, and this one is set to true in our case right now. This means we do not take this jump because our v0 is not false. So if false equals false, this is not the case. What we have here is if true equals false, therefore we go into the else statement. And this means we increase our player power by plus 10. All right. So how can we change this regarding to the jump instruction? Well, let's have a look. So let's clean this up real quick. Okay, let's go through this once again. So we are having not this condition. This one is false. We end up here. Okay. This means we increase our power level by 10, and then we've got this go to jump here, which means we are jumping from here to here regularly. All right, what if we take this go to and instead of this go to label, let's say we insert condition underscore 0. Then in this case, instead of jumping downwards, we should jump to the condition 0 label, which is just underneath, which means we get into this one over here, which means we get another upgrade of plus 100 once again. So we're getting plus 10 and plus 100. And afterwards, we do our stuff over here, and then we've got this go to label, but this gets simply ignored because it's not a jump instruction, and we return out. So let's see how this works out, okay? All right, let me clean the screen real quick. Okay, so we've got our if equals 0, condition 0. We do not met this condition, therefore we go into this one. And here we've got this jump out of this. And this will now be replaced with condition underscore 0. So exactly this, yes. This means this jumps to this condition, and this now also jumps into this. And this should lead to a power level increasement or power level upgrade of 110. Let's see. Okay, so I built this app, I signed it. I do not want to bore you with those steps again. So I guess you have seen this a lot in the past, and I will cut this video at this right now. All right, we already got our connection to the device. Let's get this. There we go. Now let's install it. All right, we open this application. Our power level is now 10, which means if I hit the button, we should have a power level of 120, because 10 plus 100, let's see. There we go. I hit it once again. 230, we increased it again with 110, and so on. We can do this as long as we want. So what we're doing right now is we're going into this condition, but instead of jumping out, we get into this, and this is by changing the jump and this is by changing the jump instruction over here. Nice. Okay, so to recap this real quick, I restored the original state. All right, so what can we do? We can change the jump label over here. All right, that's nice. We have seen this regarding to this one here. What's also possible is we can move the jump label around. So we can take this one and simply add it over here. This will also work. I restore it back. Okay, what we also can do is we can invert those. So instead of if equals 0, we can say if not equals 0. And what's also working is we can change the register value just right before the if statement. So if we get this one over here, we can simply say const/for v0 is now true or is now false, whatever we want. These are the options we've got right now. And this leads us to patching every if instruction we want to have designed in our way. To be honest, I'm not using the jump instruction very often, but sometimes it can come super handy. Okay, regarding to inserting new code like this one over here, we didn't talk about this yet, but we will do pretty soon. So we are close to this topic right now. I just want to show you this option that this is a possibility. Because, yeah, patching Smiley gives us unlimited power. We can do whatever we want here. Alright, so that's all for if statements right now. The only thing we didn't talk about was a switch case, but a switch case is just multiple if statements. So if we are having a switch case with 4 values, 1, 2, 3, 4, the compiler simply generates 4 if statements. If equals 1 equals 2 equals 3. Therefore, we do not need to talk about this. This is just multiple if statements. And this is all you need to know about these if statements. You also know how to patch them in certain ways. Regarding to this one, I have introduced this right now, but we will also learn this in the inserting Smiley section. Okay, therefore you are now well prepared regarding to if statements, and you've got a lot of power already. And we will take this and do our first real-world application patching. We will circumvent a routing detection, so this will be the next exercise. I have prepared one on a well-known code, but I've also got an application which is designed as a routing detector. And this comes super handy if you want to perform penetration tests and have to circumvent routing detections. There are nice frameworks out there that do a good job, but sometimes they fail because the implementation is quite unique and it's not known to the program. But by analyzing and patching the code, you can circumvent this right now. Therefore, I see you in the next video. Alright guys, I've got my black hoodie on, so now it's time for another challenge, the next bell challenge. We are dealing with an application that has a routing detection enabled, and we need to bypass this to analyze this application. By identifying that the device is rooted, the application goes into a secure mode and will disable the user login. If we want to analyze this app, we need to bypass this routing detection. To do this, we need to reverse engineer this app and figure out how this routing detection works. Most of the time they work in the same pattern. They try to identify certain binaries, for example the SU binary, strange system settings, for example if the system partition is read-writable mounted, or other tags and features. After identifying them, there will be a state or a flag that signals, okay, for example true, a boolean value, this device is rooted, or false, this device is not rooted. Your task will be to identify and patch this check. So the application needs to think that it's running on a non-rooted device, even if it does run on a rooted device. You are well prepared regarding to skills and knowledge to solve this task, which is super amazing, because this routing detection has been taken from a real-world application. I will name the author and give the credits to him in the solution video, because I do not want to spoiler it right now. But if you can solve this task right now, you can solve a real-world application routing detection. And this is an amazing and also necessary step, because if we analyze real-world applications, we often have to perform this task. Sometimes they are pretty easy and sometimes it's really hard to bypass them. But we need to consider a routing detection is not a security mechanism to block attackers. A routing detection is a security mechanism regarding to the client, the user, that the user does not accidentally install an application on a rooted device. Sometimes developers get this wrong and thinks, okay, if I implement a routing detection, an attacker cannot analyze and hack my application anymore. But a routing detection is always a client-side mechanism. By having a client-side security mechanism, an attacker can bypass and circumvent this. Sometimes it doesn't take that much effort and time, and sometimes it's really hard, but at the end it will be possible. So please keep this in mind. Even if you implement the hardest routing detection ever, it will be still possible to bypass it. And even if not, an attacker can still analyze your application or hack this application without having root privileges. We are doing this for quite a while right now. We are patching the Smiley code, and this has nothing to do with having root privileges. You can do this on a normal smartphone also. Therefore, just please consider a routing detection as another protection layer, but not as the de facto protection layer that your application cannot get hacked. Okay? Okay, but now let's get back to this topic. We are installing this application and have a look into this, how it works. Then you will have all the time that is required for you to solve this challenge. And we do it as always. I provide you a solution video where I give some additional hints, and you can pause and rewind this video to solve this challenge, even if you struggled at the beginning a little bit. This is now a real-world application, and it would be very amazing if you can already solve this. But even if not, if you are able to solve it after this video, so if you understand how it works, and if you have patched it on your own even once, then you are well prepared for real-world applications. Alright, so let's have a look. Okay, I've downloaded this application, and you can find it here. It's named root check. So let's install this. ADB connect, connected, ADB install root check, and let's get the screen. All right, here we go. We've got this root check over here, and if you open this application, device is rooted, secure mode is enabled, we do not have a login over there. So the user is being protected for not doing dummy things on a rooted device with this application. It's a user protection. It blocks you right now from accessing or analyzing this application. But maybe you can bypass this and then the protection has gone. So you can do this challenge in very different ways. But one way is enough. So you do not have to do it in 3 or 4 ways. It's of course a nice practice if you do so. But having one working solution is absolutely fine for me right now. Also have a look at the cheat sheet regarding to registers, Boolean values, patching, and also the if statements. These are useful hints and they can help you out on this. Not all of them at the same time, but regarding to certain single steps. Alright, now good luck on this one, and I see you in the solution video. Let's go! Alright guys, welcome back. This challenge was different regarding to the ones we have faced so far. Because now you've got several options, things you have learned in the past. So it was not regarding to a special topic, it was regarding to what we have learned so far. This makes it of course harder, and in case if you struggled a little bit, don't worry too much about this. We will take a look together into this right now. And afterwards I'm pretty sure that you understand the whole application function and how you can patch this the next time on your own. In case of course if you have successfully patched this, congratulations. This is a real world application example, and I have encountered this many times in applications regarding to different types of customers. So therefore you successfully bypassed a real world rooting detection, which is really, really amazing. So whatever which case we have right now, let's take a look into this together. So I still got it open here, and let's grab this application, downloads, root check, and put it into a new app directory. All right. So let's have a look first with JADX GUI. Okay, so here we have the main activity. Let's see. We've got some Android stuff and text view and button. We've got an if statement over here, root util, is device rooted. This sounds very promising. Then we've got some stuff, the device is rooted. So we know regarding to the text, this one is our, this is the state we do not want to have. We want to have this one over here, because here we will return out of this method, out of this function, so we leave this application. Okay, so now we know what we are dealing with. Regarding to this one over here, let's see if we can already patch this without taking a look into the routing detection. I get out my graphic tablet and then we discuss this, okay? And let's go. Okay, here we are back again. Let's have a look into this. Alright, this one is our if statement in this line. So if we go into this function, we've got a lot of instructions, but here we leave this function. So this one is our exit. And we do not want to go into this. So let's recap this real quick. What we have learned in the last couple of videos. Let's say we get rid of this instruction over here. We patch this or delete this if statement. Does this brings us anything further? Let's have a look. So let's say this one does not exist anymore. Okay, then we've got a regular instruction, another one, but at this point we are still leaving. So this doesn't bring us that much until we also delete the return statement here. If we delete this one, then we have some other additional instruction. This one, and this one. Yes, that's missing. All right, this means we are having a device which shows, oh, this device is rooted. But we are also having a device which says, oh, everything is fine. So by having these two states, we got our task done. But in my opinion, this is not a really clean solution. Because if we do not patch this if instruction over here, this one, and just delete it, the device still gets flagged as being rooted. And this will mean that, some features might not be possible to use in this app. Of course, in this activity, it's fine, but maybe regarding to other services, we might encounter some trouble. Therefore, this is a nice approach, but not the solution. If you want to, you can try this to, get rid of the return statement and also of the if statement there and see how good it goes. But now I will come to the, real solution, okay? So let me clean the screen real quick. All right, and now let's have a look into this. So this is our routing detection. Let's see how it works. I click into the class and here we go. So first of all, I want to thank and mention the author of this. I will, blend it in right now. So this routing detection is working absolutely fine. There's no problem within this routing detection. It protects the user from running an application on a modified smartphone. But still, as an attacker, we need to patch this. So let's have a look how it works and how we can circumvent this. Okay, the first one sounds pretty promising. So I get back my pen, there we go. The first method is device rooted? And let's have a look at the function itself. We do not have any parameters here, and we return a Boolean value, this one. Okay, that's pretty interesting. Let's see how it looks internally. So let's clean this. Okay, so we are returning this method or the value of this method or the value of this method. Whoops. Or this method. There we go. Okay, so this sign means an OR statement. What does an OR statement do? And let's see. We've got this following binary table. So we've got A and B. And this one is 0, 1, 0, 1, and A is 0, 0, 1, 1. So if we combine them with an OR, then we get the following result. 0 and 0 will be 0 regarding to an OR statement. 0, 1 will be 1. 1 and 0 will be also 1. And 1 and 1 will be also 1. This means if one condition is set to 1, then the output will be 1. Otherwise, if both are negative or false, then the output will be 0. All right. Regarding to our routing detection, this means if one of them returns true, so 1, then the whole function here will become true. So this Boolean value here will become true. This is pretty neat for the routing detection because let's have a look into this. For example, the first method, check method 1. Check method 1 checks if we've got test keys enabled in a build tag. Okay, whatever this means. If we have here a true statement, we do not need to go into this and this to flag this device as being rooted, because one true statement here is enough to make the whole output being rooted. This means if the function here returns 1, we get a true, and this means the device is rooted. If this function returns a 0, which means false, the device is not being rooted. Okay? So let's see, how can we get a 0 and false statement? Well, we have to be, or all three methods, so in this case we also have a method C, and also this method C needs to be 0. Okay, so And let me clean this up real quick and then we go into the functions in detail. All right, so we are having 3 methods. Each of them returns a value. And if one of these values is true, we lose. Or let's say I lose, because it's not your fault if I do not bypass this, okay? All right, let's have a look into the first method. The first method checks if we've got some build tags with the test keys enabled. So if this is the case, we are returning true, otherwise we are returning false. Okay. Next, we've got this one here, check method 2, this. And this checks if certain applications are being installed. For example, the super user, the SU binary, and yeah, other stuff. If one of them is installed, the device, the path exists, it will return true. So there we lose, or let's say I lose. And if it's false, we win. False means none of these binaries or APKs has been identified on the system. Last but not least, we've got check root method 3 and and this method executes a system command, which means we are checking if the SU binary exists on the system. So these are our 3 routing detections. And if one of them becomes true, then the whole device is being flagged as rooted. Okay, so one approach would be to patch all of these 3 methods over here. So instead of returning true, we can go into this and return false. But we have to do this for all methods. So also here and also here. By doing this, all of them will return false, which means if we combine 3 false together, the output will be false regarding to this OR statement over here. And this means our device is not rooted. Okay, this is a valid approach, but it requires a lot of effort. And we are super lazy hackers, therefore we want to take the path with the least resistance, like the electronic stuff does. So what other options do we have? Let's clean this up. Instead of patching all of them, we can go for the master routing detection, which is this method over here. This method checks all 3, and afterwards it returns true or false if the device has been rooted. So by patching this method over here, we can simply say always return the value false. So regarding to this challenge, I would recommend you to go for this part. Simply patching it at this point by adding a new const value regarding to the register that's being returned and set it to false. All right, you can now pause and rewind this video in case you want to try this out. I will move on with the real challenge and here provide a solution for this. Okay, here we are back. On the left we've got the Smiley code and on the right we've got the decompiled Java code. Let's have a look into this. We've got our file root util, this is our class. We do not extend a certain special class, it's just Java-lang object. This is our file name, okay. Then we have the constructor. And here we can see check root method 1. Okay, if we take a look at the right, we can see, oh, that's strange. Because here we have is device rooted. But yeah, this one seems to be missing right now on the left. And this happens quite often in Smiley. You can check this if you click left into these line numbers. So here you have your line numbers regarding to your Java code. And if you click left with the mouse button, then you can see the line numbers regarding to the Smiley code. And here we can see those line numbers are increasing, but here we have some strange looking. So we are having 32, 37, 32, 30 back again. So the Smiley code is a little bit different regarding to the order than the Java code. We have seen this in the if statements. The compiler has produced a different order which is faster for the CPU to execute instead of going the Java approach, so the Java order of this code. Alright, but this is not a big deal. We have seen this in the past and yeah, we can handle this. So we just need to navigate around with the Smiley code and we have to trust the Smiley code on this. Okay, we can see this one is check root method 1. This one over here. Let's go down. Here we have check root method 2. This one over here. Then we can see all those strings and binaries that's getting checked. We go down. Here we have check root method 3. Alright. If we go down, there we go. At the end we've got is device rooted. Alright. And we can see this over here. Line 10. This is line number 10. Okay, it's at the end of this file, but I mean, who cares? So we have found this and yeah, let's analyze this and try to patch it. So the first one is a new instruction and we haven't talked about this yet. But if you take a look at the Smiley instruction that exists, so I hope you have your cheat sheet prepared, you can see we cannot talk about all of them. But we have learned a lot of things about Smiley and maybe we can apply this knowledge in reading and also understanding what this instruction does. So let's have a look. This instruction is named invoke static. So copy. So now we are searching for this. Alright, invokes a static method with parameters. That's all. It just invokes the method. It doesn't do anything more. Okay, let's see. Which method? Let's have a look. So I enable my pen and we can see we've gotten capital L. This means we're having a class reference. The class reference ends at the semicolon. So we are dealing with root util over here. We are having root util. Okay, then we've got this arrow, which means we are having a dot, and after this dot, we've got the method name. In this case, check root method 1. And so on. And we can also see the return type of this is Boolean. Okay, so we do not know, or we didn't know what this one does. But now we know this one executes this method call. So regarding to static methods, we do not have to create a new object. We can simply use the class and then the method name to invoke this. Okay? So this one is just executing this function, but it doesn't do more. So therefore we have this next line. This one moves the result into v0. But nevertheless, let's verify this because we are not familiar with this. So let's see. Move result. Move the result values of the previous method invocation into Vx. Alright. So the return value of the previous method, which is this one here, gets now moved into v0. This means our v0 is now being true or false. Depends on what the return value of this method is. Which means we are having 0x1 for true and 0x0 if we've got a false. Okay, then let's have a look into the next one. Nice, an if statement. So if v0 is not equal 0, let's write this down. Yeah, I enlarge this and we write this next to it. Yeah, it still fits, nice. So at this line, if v0 is not equals 0, we jump to this condition. This means if our v0 is set to true, because then we are having a 0x1 in there, we jump to condition 1. And if we look at condition 1, let's see, here's the label. Okay, so we are jumping down there. And then we are writing 0x1 into v0, which is interesting because v0 is still set to 0x1, but nevertheless. So v0 is 0x1, that's what this line does. And then we are returning back this v0. Okay, this means our method will return true because this one is set to true. It means our routing detection is being set to true and therefore our device is rooted. So let's take a look at the code once again to verify if everything is correct right now. We've got a boolean, is device rooted? Is device rooted true means our device is rooted. And if this method returns true, then the whole method returns true, which means our device is being rooted. So we can also circumvent this right now by patching this if instruction. So we can flip the logic of this. So here we get an additional patching option. Instead of going for this one over here at the end, we can also flip the logic over here. But we need to take care about this because in our case, this method will return false. So this doesn't flag our device as being rooted. If we now start flipping the logic, this method will tell that our device is rooted, even if it's not the case regarding to this check. So this is something we need to consider. All right. So therefore we do not go for this one. Okay. So let's clean this up a little bit and then we do the next check. So we've got the false statement for this one over here. Okay. So if this one is false, which is the case, by the way, for our routing detection, and therefore by flipping the logic, this will become true. We will end up with a rooted device. Therefore, we do not, or flipping this logic here will not work for us right now. Okay, but if it's false, we go into the next one. And here we have check root method 2. We've got the same approach like this one here. So we have our class root util dot, let's write it in this way, dot check root method method 2 returning this boolean value. This boolean value gets stored into v0 over here, and we can see the same approach. So also right here, if v0 is not equals, if v0 is not equals 0, we jump to this condition. And our v0 is the output of the one before. So, sorry. The one before is only this and this line. So v0 is equals to, let's write it down. Root util dot check method. Okay, there we go. It's getting a little bit, messy, but I guess we can follow on this. Okay, so this one is this over here. We are still using the v0 register, and if this one is not equal 0, we jump to condition 1 back again, which is this one here. And here we set our v0 to 1, and then we return v0, which means we are having the same case. Let's do this once again. So if our v0 is not equal 0 means our v0 is 1. Then our v0 will be set to 1, okay. And then we are returning 1, okay, which means we are returning true, which is not okay, because then we know our device is rooted. So this method also needs to return false. Not also. This method needs to definitely return false. So regarding to the patching approach, we can flip the logic over here. This will work, because if you take a look, we can see this method will definitely flag our device as being rooted because we have the SU binary on our device. We might also have the super user APK, I'm not sure, but one of these will definitely be true. Therefore, this method will return true. So let's toggle the visibility. Okay. I clear this up real quick. So this method here returns false for our case, that's okay. But this one here will return true. And therefore we can flip this logic over here. This should work. Yes, okay. But we are going to make it a little bit easier. So we are not patching it vice versa. I just want to show you all or many possibilities to solve this challenge right now. You can also try this on yourself later on. And if you have questions, yeah, please write me a message. I'm super glad if I receive feedback on challenges like this. And of course, I try my best to help you out on it. Okay? All right. So this will be also an approach that should work. So what's next? Okay, we are in this method over here. Yes, we talked about this one. We end up here. Otherwise, we talked about the true statement. But now we need to go into the false. And the false statement, once again, exactly the same. But okay, now it's a little bit different. Let's see. All right, let's do this. We invoke this method over here, root util check method 3. So regarding to this line and this line, it means one last chance to write it clean. So let's see. V0 is root util check method 3. Then we are having an if statement. If, oh, that's interesting. If v0 is equal 0, we jump to condition 0. All right, where's condition 0? There's condition 0, nice. This means we are writing 0 into v0. Okay, and then we go to label 1, go to 1, which is this one here, and we are returning out. So we are returning v0. All right, this is different. Oh, nice. So what do we have here? If this method now returns 0, then this device is being flagged as not rooted. But the thing about this method is we can only reach this method, this point over here, this one, if this one has been false and if this one has been false. Only then we can reach this point over here, which means if one of them has been not false, then we end up here in a rooted device. All right, so this is how the logic is implemented in Smali. It's maybe a little bit confusing at the beginning, but if you go through this once again and yeah, write it down exactly like we've done this on a whole paper completely, then you will realize this, okay, this is how the logic works, and yeah, maybe then it's not that hard anymore. I really encourage you to write it down in the following way. Maybe a little bit more clean than I do, and maybe also, yeah, more complete than I do, but this is a really good approach to understand Smali. Okay, so now let's see. So if this one, then we jump to condition 0. Condition 0 was here, okay. And then from this one, we jump to this one, and yeah, we skip this part here. All right. So by looking at this, I came up with 2 additional patching options, or at least one. The other solution I see right now is regarding to the labels. This one, and yeah, also this one, for example. So these labels define a branch instruction. We have our code, let's say this one, check, let's call it check, root, and so on. Based on this, there's a decision. If we go on the left one, which is for example true, which is in this case condition 1, device is rooted. Or if we go into false, and then not rooted. This is what we want to have. And this false statement over here is not regarding to condition 1, it's regarding to condition 0. Condition underscore 0. So we can also change the label to achieve this task. But yeah, to manipulate the jump instruction to not go into this way, to always go into this way. That's also a really nice solution in my opinion. And yeah, feel free and have a try on this one. So the easiest solution I want to show you right now is the following. We've got only 2 Boolean values in our function over here. We've got this one here and this one. This sets the device to false, or not the device, sorry, the routing detection to being false, which means not rooted. This one here sets the device to true, sorry, the routing detection to true, which means the device is rooted. So the simplest way to patch this routing detection is to change this value to 0x0. By doing this, the device will be also not rooted, and therefore we can run our application as a normal app. Alright, the other solution is, let me clear this real quick. Before we return out of this, at this point here, we can apply a new command or a new instruction, which is const /for v0 0x0. So we can simply write this instruction once again, just right before we return out of this function. This means no matter what, even if our v0 register is being set to 1 at this point over here, which means true, we are overwriting v0 at this point with false. And then we are returning the last value, this one over here. Okay, so I will show these two approaches in this video right now, and I will make an additional video regarding to patching those jump labels. Okay, so one easy patch is simply this one. I know this is ridiculous, but it should work. If you take a look into this, all methods now return false because there's no option for them to return true anymore. All right, so let's have a look. So ADB uninstall, uninstalled, ADB install, out APK, success, root check. There we go. The device is not rooted, login is now possible. And if we click login, we've got our flag because yeah, we've got some insane Smiley skills. Nice. So that's all we need to do. I know it looks super simple and you might think, oh well, was it really that easy? Yes, but we did a lot of work to understand that it's that easy because we reverse engineered this application and figured out what's going on. Okay, in this case, this is a nice trick to check, okay, there are only 2 Boolean states available in here, but this comes with practice and experience in Smiley. Okay, so don't worry about this if you've got some really complex or if you put a lot of effort into this. This is absolutely normal and it's not always that easy to patch this. Alright, let's revert this change. So now we've got back the original change. If we build this, our device is still being flagged as rooted. The other approach is to introduce a new Smiley instruction over there. So just before we turn out, we overwrite this register which returns true or false for this Boolean value. And yeah, let's build this application also once again and install it. I will fast forward this right now. So I will see you in a few moments. And yes, you can see this one also works. Nice. Yes, all right. Let's have a look into the decompiled output, how our routing detection works right now. So this is our patched version. So this is now this version over here. We are overriding the return value with a false. Let's see how the Java code looks to this. Root util. There we go. This one has been now added. So no matter what the first output is, it will return false. This is what we have added by introducing this new instruction just before we return out of this function. All right. So this was a really rough challenge right now. Okay, this patch was easy, but understanding what's going on was really not that easy. And therefore, no matter how it worked out for you, if you could solve this or not solve this, and if you also gone through this once again and solved it, no matter if you received some help regarding to the solution video right here, but if you have gone through this and have understood what's going on, and if you have been able to reproduce this, then this belt is for you right now. There you go. Alright, I will make an additional bonus video regarding to this challenge because it was also pretty interesting for me that there are these many options for us already to solve this. So it's really nice to see how many opportunities we already have right now, because we are just the half of the Smiley topic. So we get a lot of more power in the next chapter when we talk about methods and also introducing or inserting more complex instructions. So the bonus video will be directly after this video, but if you already have patched this conditional jumps over here, the labels, then you can of course skip this. If you're feeling pretty confident in doing this, of course feel free to skip this. It's not really required. We will move on with objects, which is the last huge chapter in our Smiley learning process. And by doing this, we will get even more power in hacking these applications. So I see you. Okay, welcome back. This is the bonus video. So we take a look into another approach on how to solve this challenge. And I would like to provide this to you to see there are lots of opportunities we've already got to solve this challenge. Okay, so let's see. First, let's get this application screen back. So this is our root check here. Yes, our device is rooted. All right, so this is the application. And now we want to bypass this by patching the labels. So we close this one and we go into apps. Then, the root check. There we go. Okay, we first decompile this application. Then we open the whole Smiley directory with Visual Studio Code. All right, then we go into app hacking and then the root util. There we go. We click away those annoying windows, select Java, click it away. All right, let's open it up on the decompiled version right next to us. So JADX GUI rootcheck.apk. Okay, so I've got my graphic tablet out and we are still talking about the isDevices_rooted method. So if you go down, there we go. So here we can see, okay, we've got several checks. Check root method 1, 2, and this one is 3. There we go. Okay, so this is the method on the Java side, and let's take a look into the Smiley part. So here we have our method, isDeviceRooted. This returns a Boolean value. Then we've got our 3 checks over here, and these are combined with an OR statement. So with this one over here. Let's analyze this real quick. Okay, we start at the beginning. Is device rooted? No parameters, Boolean return value. So we've got a local variable, a local register over here. Then we've got our line 10. And then we've got our first invoke static. This is the class name, root util dot check root method 1. Okay, this result gets moved into v0. So this means our v0 is root util dot check root method 1. And so on. Then we've got our if statement. So we've got this and this. Next we've got our if statement. If v0 is not equal 0, we jump to condition 1. If v0 is not equal 0, we jump to condition 1. Condition 1 is this one here. So we jump down here. And yeah, before we take a look into this, let's analyze this real quick. What do we have here? Okay, this means if our v0 is not equal 0, it means our v0 is set to 1, which means the return value of this function over here, this one here, has been 1 in the case of a true statement here. This means we've got a routing detection, or the routing detection signals identified something strange on the device and it flags it as being rooted, because we have here a Boolean value. So check root method 1 returns true, and then we know, okay, this device is rooted. This means we go into the condition 1 over here. We've also got this goto label, but we can ignore this. And then we write 1 into our v0 and we return out. But with the return value of v0, which is 1. And this means it's true. And this means is device rooted becomes true. And this means this is bad, at least for us as an attacker, because then our device is being flagged as rooted. Therefore, we know every jump condition which ends up here in this part will be the true case. This means our device is rooted. And this means every jump to condition 1 and also the go to 0 label will make or will flag our device as being rooted. Okay, so let's clean this up real quick. These 3 here mean device is rooted. Okay, so regarding to our check, we've got our check over here. This one is device rooted. Then we've got true. The device is rooted. And we've got false. True means we end up at condition 1. And also with the goto label 0. Okay. Let's see where we end up if we want to get our false statement here. So which jump instruction we need to get to have this false enabled. Okay, so if this one is true, we go downwards. Therefore, this is our false statement. Okay, then we have this once again for method 2. We move this in v0. All right. So v0 once again, not equal 0. We've got exactly the same code over here. All right, here we can see true. We still end up in condition 1, which means our device is being rooted. Therefore, if this one is also false, we move check root method 3 into v0. Oops, wrong color. Okay. And then we've got if equals 0, v0. So let's write this down here. So if v0 is equal 0, we jump to condition 0. If v0 is equal 0, we jump to condition 0. Okay. When v0 is 0, it means v0 is false. So our check root method over here will return false if we go into condition 0. And condition 0 is this one over here. So we move the value false into v0. And afterwards we go to label go to 1, which is this one over here. And then we return out. So this means we are returning v0. Okay, if we look at this, let me clean this up a little bit. Okay, so if we get into this jump over here, condition 0, then we end up here. This will move false into v0, and then this one is a jump we always take if we are at this line, because this is a jump instruction go to and also the label. So if we end up at this line, or let's say in condition 0, we also take this jump to go to 1. And go to 1 simply skips this bad code over here, which moves true into v0, and this is not what we want to have. Therefore, we know our false condition is set to, let's see, condition 0. Okay, so now let's adjust our labels, no matter what's the output, to always go this way, even if it would have taken this way. So we get rid of this path, and we direct all of these jump instructions to this path over here on the right. And we can do this by simply adjusting all labels to condition 0. So if this one is condition 0, and this one is condition 0, and everything is condition 0, then there's no option to get into another branch over here. So we've got no option to get into this one. This one is out right now. And we only can reach condition 0, which means we are putting false into v0, and then we are leaving out this function. So this will be code that can never be reached again. Alrighty, let's adjust this patch. It looks a little bit messy, but I guess, but I hope you could follow on this. All right, so let me clear this up. And now let's do the patch. All right, by applying the patch, we do not have to consider, is this now a true or false statement? Do we have our test keys enabled or not? This is things we need to care about if we flip the logic, but not if we adjust all labels over here. So in this case, this is simply our false, this one over here, and therefore we direct all to this one right now. So this becomes condition 0. Also, this becomes condition 0. This one also becomes condition 0. All right, and I guess that's it. Yes, even if this check fails right now, we jump to condition 0, which is this one over here. All right, this was the only thing we have to take care about, because now we've got a reversed logic. Let's say it in this way. Here we are checking if it's not equal 0. Now we're checking if it's equal 0, but by changing the label also to go to condition 0, which is, where is it? There is it. It's directly underneath. I do not see this. Okay. If we change it in this way, then we do not get into this one, and this will become that code. I'm also super excited how this application looks like if you patch it in this way. I guess there will be some hard-coded statement, something like return false, but let's see. Okay, one thing I want to additionally add to this video is, if you patch those labels, you need to be pretty careful, because you can accidentally create endless loops, and this can happen super easily. I would like to show you what I mean over here. So over here, for example, we have this jump to condition 0. Here we are also having a jump to condition 0, and this one over here. Here we are having an additional jump to condition 0, and here we are having our condition 0. So this is our patched version. And if the compiler is creating this code, the compiler makes sure that the program flow is correct. But now, if we get into this control flow and patching it, we need to make sure that the control flow is still correct. Because what can happen is the following. Over here, we're having now all these jump labels to condition 0. So let's say this one on the right is our program code. Okay, and so here we're having our program code. And this one over here, this is, for example, the jump to condition 0. And let's write it down in the following way. Condition 0. This is also the case over here. And this is also the case over here. And this one over here, condition 0. And now finally, where do we have it? Here we're having it. Okay, so this one over here is then finally our condition 0. It's not that straight anymore, but it's still our condition. So this means all these jumps end up over here. And this is perfectly fine. So here we are ending up with all these jumps. All right, this is okay so far. But it could be easily the case that this condition 0 over here is not related here at our program code. So let's say this condition 0 is, for example, in between them. Let's say this condition 0 sits here. This is now our condition 0 label. So what happens right now? Let's remove this part. So now our condition 0 is here. And this means this jump, the first jump, and also the second jump are referring to this one, okay? But now we could have a problem, because after this one over here, we are having a jump back. This could be an invalid case. For example, if we're having a for loop, then we are also creating a case like this one. So this is our for loop. And within a for loop, we are also having these conditions, for example, this block over here. So within the for loop, we jump, for example, back to this one, then we subtract -1 from I. Let's write it different. I minus, and then we will leave this conditional jump, this loop, if I is less than equals 0. And then we break out of this one and we move on with our original code. So this could be a valid behavior, but in our case right now, we have modified this jump label and we are not having a condition when we leave this code. This means we are having now the following case. So let me clean this up real quick. So we are having now this condition 0. And let's say we move on at this point in our program code. And then we end up at this point over here. At this point, we are jumping back to condition 0. Okay. Then the program once again goes down until we once again are at this point. Oh, we are jumping back to this point. Once again, the program, and so on. I guess you get this point. Here we are having now an endless loop. Because we are not having a condition to break out of this one. And this is the case because we have modified additional jump instruction. For example, this one over here, this has not been, I'm not sure if this has the case right now, but in our case right now, let's assume this has been conditional 1 before and this one also. If conditional 1 is underneath, like this one over here, conditional 1, then those jumps are definitely correct because they have been created by the compiler and the compiler have taken care of this one over here. Jumps doesn't have to go always down. They could be also correct if they go upwards, but then there are certain conditions that we do not end up back in this, in an endless loop like over here. But if we modify them that they are not going this way, that they are going back to condition 0 over here, then we need to really take care of this one over here. All right? Okay, so if you adjust a lot of labels in your code, maybe draw this on the right and make sure that you're not accidentally created an endless loop like we're having at this case over here. So this one over here, that's an endless loop. Okay. Now let's get back to the video and move on. First, we apply our patch. Okay, so we hit the save button multiple times. All right. Then we build this application. All right. And now, oh no, it's not possible in this way. ADB install because our APK is named out APK. Alrighty, screen copy, slide up, root check. There we go. We've also successfully patched it by adjusting these labels. Nice. Is login possible? Yes. We've got really insane smiley skills right now. Nice. All right, and let's have a quick look into what this application now looks like regarding to the Java code. Com, root check, root util. Yes, exactly. I didn't look it up, but I've got this feeling that it exactly turned it in this way. All right. Nice, super nice. Okay, so we can also adjust our labels, but we have to understand the code. The code, which is within the Visual Studio file I already closed, this one over here. So if we identify what's the condition we want to end up, we can simply adjust all other labels to jump to this condition, which is this one over here. Okay, so I hope this helped you if you tried this approach. It's not that easy to think about this if you start learning Smiley, but I guess this approach can be also super helpful to you in the future. Therefore, I would like to make an own separate video regarding to this one, because you also do not see this very often in the wild. Okay, so that's all for now. In the next section, we take a look at objects and methods, and this will be even more exciting because we are going to insert our own code into the Smiley part. Not just in single instruction like this one, we insert own code. So I see you there.